यार तेरा भाई 20,000
हेलो बच्चों, सत श्री अकाल and namaste from my side. So hope so I am audible to everyone and visible to everyone. So guys, I want to tell you all, this is Indrajit Singh welcoming you all into the most sensible platform for an aspirants, those who are preparing for JEE NET. So lots of students might be having thousands of questions into their mind, what we are going to do, how we are going to conduct, how it is going to be so long, a last minute revision session. So guys, I want to just convey a single message and a motive, okay? With that motive, we are going to stick till end. All physics shortcuts and the respective formulas. We are going to start from the units and measurement. We are going to end to the semiconductors and the communication systems. Till then, whatever the single-handed approaches are there that are going to help you all in solving the questions into the physics, we are going to discuss, okay, with the respective formulas, the chapters, the respective formulas, and in that, the specific shortcuts, like the shortcuts into the projectile, the shortcuts into the NLM, the shortcuts into the SHM, the shortcuts into the respective chapters and the respective formulas. Okay. So, good morning everyone. So, first of all, those who are live, can I have the thumbs up into the comment box? Good morning. Okay, after a long time, I'm being live. So, shall we start? So, this time, again, no break, and we are going to okay, neither Indrajit sir is going to take the break, neither, I'm going to, tell you all to take that break. Hi everyone, good morning. Okay, lots of people are there, like Jashwant is there, Mukesh is there, Mr. Raj is there, Bhavishya is there. Hi everyone, good morning. So, Venkatesh is there. Hello, Bacha ji. So, is it cool? Is it cool? Okay, it is at the very last moment. Okay, I am not going to show you all something different. I am not going to discuss that problem that is very creative, because only 2 to 3 days are there into an examination. So obviously you are prepared. Okay, the thing that is needed at the last moment, is boosting up your preparation to enhance. Right. Okay, so at that moment only the shortcuts and the formulas are going to help. Chaudhary Sahab is saying love you too, sir. Thanks, bacha. Okay, hi everyone from Tamil Nadu. Good morning, good morning, good morning. So, shall we begin? Come on, everyone, thumbs up into the comment box, please. Shall we begin? Yes or no? Come on, thumbs up. I'm going to start. We are not going to waste the time because lots of things we are going to discuss. Okay, lots of things we are going to discuss. I'm going to give you all the approaches, okay, through which you can, okay, solve all of those physics sums into the JEE mains into the very rapid and manner. Good morning. Okay, so I think we should start. So everyone, we are going to start with the units and measurement. Why? There is no need to get scared. Okay, love from Uttarakhand. Hi everyone. Okay, just it's my advice to stay till end and you are going to enjoy. Okay, good morning. Just stay till end. Okay, I guarantee, okay, I guarantee none of the moment you are going to miss, none of the moment, none of the single second you are going to get bored into it. Okay, so I think lots of lots of thumbs up are going to come and we should start. So let's start with the units and measurement, the first and a very easy chapter of the units and measurement. It starts with lots of things, lots of formulas I'm having directly depicted on the board. Okay, apart from this, the approaches, the thing I'm going to discuss in front of you. Okay, So units and measurement, the basics of the units and measurement from the JEE point of view starts from the physical quantity. Any physical quantity, it is made up of the two things, N and U. N is a numeric value, U is the unit, right? So physical quantity is P, that comprises of N and U, right? And it is defined as numeric value, right? U as unit. On basis of this, what kind of sums are asked into an examination, right? Okay, first, a theoretical question of graph may appear from it. Okay, what kind of the theoretical question, right, from the graph? See here, seeing this relation, we can say N is inversely proportional to U. N is inversely proportional to U. How? See, 1 kg, that is equal to 1000 gram. The lower is a numeric value, the higher will be the unit of the unit system. The higher will be the numeric value, the lower will be the unit of the unit system. Is it understood? Come on everyone. Is it understood? Okay. So for that reason, this is an important result. The numeric value is inversely proportional to the unit of the unit system. Numeric value is inversely proportional to the unit of unit system. Okay. Now, from this, okay, lots of slides are going to come. Don't get worried. Okay. The missing part, the approaches, I'm going to discuss you into the green slide. Simple thing it is, right? Don't get so much panic. Okay. Just concentrate on the board. Okay. So here, how we are going to start? Suppose the first theoretical question, it is going to come. Plot the graph of N versus U. Right? Plot the graph of N versus U. So this is going to be N, this is going to be U, right? As N is going to increase, U is going to decrease, U is going to increase, N is going to decrease. So for that relation, right, we are having this kind of the curve. Suppose the graph is asked to plot 1 by N versus U, right? Okay, 1 by N versus U, then it is going to be the straight line. Okay, 1 by N versus U, okay, this graph is gonna be the straight line. Yes or no, guys? Okay, so on basis of this, right, two graph based two important notations are there. Okay, and apart from this, one important thing that is going to come into the dimensional analysis, right, and that part is what? Okay, deriving the relation between the units. Right, deriving the relation between the units. Okay, so it's gonna be like, suppose any physical quantity, it is made up of the two values, right? The one that is a numeric and second that is a unit system, right? So how to compare the two unit systems for the single physical quantity? Again, I'm writing down. Okay, how to compare two unit system for physical quantity. How to compare the two unit system for the physical quantity? Let's say N1 U1, that is equal to N2 U2, and that is equal to NU, and that is always constant. The product of N and U in all of those unit system is constant. For physical quantity, the product of N and U is always constant. Right? So this was a quite basic thing about a very basic thing about the physical quantity. Is it okay, guys? Thumbs up into the comment box. Right? Be responsive. Physics class should always be interactive, else we are going to get stuck. Right? Physics is always horrible because you always are judging the physics by the cover of its book. So it is always going to be horrible. So I'm here to make that thing at the very last moment, right? To make you all comfortable. Okay, make you all comfortable. It doesn't mean I'm going to dance like this way, blah, blah, blah. Like, please don't mind it, right? Okay, I'm going to give you all an approach at the very last moment so that you can feel, right? So, guys, thumbs up. Okay, Josh is high. Comment into the box. Josh is high. Yes. So now, the next part of the most important part, right? Apart from this, right, after the before errors and measurements and the fundamental, right, small things are there, like validating the physical quantities, some part of the dimensional analysis, the dimensional formulas. The most important is the dimensional formula, validating the dimensional quantities. Okay, unit conversion, what is deca, pico, fermi, nano, Armstrong into the centimeters, what is a 1 light year, blah blah, lots of small chit-put things are there. Lots of chit-put things are there. So we are not going to move into that you all are aware of. Directly we are moving forward to the most important stuff, that is vernier caliper, okay, vernier caliper and micrometer screw gauge. Vernier caliper and micrometer screw gauge. See, basically we are going to deal, right, the most important stuff, the formula of zero error. This is important. Positive zero error, negative zero error. The second formula is the formula of least count. Okay, for vernier caliper it differs, for micrometer screw gauge it differs. The last formula, right, that is a formula of actual reading, it is going to come. Okay, the formula of actual reading. These three are the important formulas, okay, into any specific measuring instrument. Apart from this, measuring the spirometer, Searle's experiment, measuring the Young's modulus, okay, there exists an experiment apart from this, but maximum number of, like we can say from this topic, the vernier caliper and micrometer screw gauge. Okay, vernier caliper and micrometer screw gauge, there is an highest possibility for a question to come up into an examination. And this chapter is like, just apply the formula, get the answer, things are gonna be quite easy. Okay, apply the formula, get the answer, things are gonna be quite easy for you. Okay, so the first formula is of this like zero error. Okay, the first formula is of the zero error. Zero error, it is defined as, right, that is plus or minus nth division when both jaws touch together. In vernier caliper, one technical word that is used for zero error, that is when object is not kept. In question you have seen always these two languages are there. When object is not kept, when both jaws touch together. Both jaws touch together. Whenever you are having these two statements, immediately you should all have a click into the mind that it's talking about the zero error. It's talking about the zero error. Is it clear, guys? Everyone, those who are live? Okay. Yes. Everything will be done by the end. Don't get worried. Just you have to stay present here. That's it. Everything will be done by the end. Okay. So now let's move on to the next part. Least count. Okay, least count formula into the vernier caliper is 1 MSD minus 1 VSD. Okay, now what is the definition of the least count? Okay, the definition of the smallest value measured on instrument by an eye. Smallest value you can measure. On main scale, one division is of this. On vernier scale, one division of this. Right? So difference of one main scale to one vernier scale is the smallest value that we can measure through an eyes, and it is a least count. A very simple explanation, right? And we are not going to so much elaborate it. Direct hit, direct question, ball out of the boundary line. Actual reading is having the formula AR, that is equal to main scale reading. MSR stands for main scale reading plus N into the least count plus or minus zero error. This is the formula of the actual reading into the vernier caliper. Okay, this is the formula of the actual reading into the vernier caliper. Okay, MSR. MSR stands for main scale reading, right? MSR stands for main scale reading. The main scale reading is always given into the two forms. Either the value, the direct value is given into the question, or right, we can say that, okay, either the direct value is given into the question, or we can say it is given into the form of main scale division. The specific statement it is written, what? The main scale reading is equivalent to 10 main scale division, and one main scale division is of 1 mm. It means main scale division, main scale reading is of 10 mm. So like this way, questions are quite easy, but they always used to confused. Okay, clear? 11th and 12th, entire physics we are going to discuss. We are going to take 4 to 5 hours. Okay, and entire physics we are going to discuss. Okay, guys, everyone. Okay, so this was regarding the vernier caliper. Now, micrometer screw gauge is quite easy. Right? Micrometer screw gauge is quite easy, and by end of this lecture you are going to get the PDF, the final last moment PDF. By scrolling this PDF, then notes, immediately the entire physics will start scrolling into your mind. Right? Okay. Questions wouldn't be that, but some of the questions we are going to discuss, if they are important, don't get worried, because at the last moment I think the revision of the topic and the shortcuts you need, so that you can what we can say, help you all into the scoring the marks into an examination. So micrometer screw gauge. Micrometer screw gauge. Again, three most important stuff. First, the formula of pitch is important into micrometer screw gauge. Second, the formula of the least count, it is important into micrometer screw gauge. The third, formula of zero error, it is important into the micrometer screw gauge. The fourth, actual reading is important into the micrometer screw gauge. Is it okay, guys? Everyone, those who are live, come on everyone, Josh is high or not? In Hindi I am saying, घबरा गए क्या? साथ छोड़ दिए क्या? जम के बैठना है, अभी तो ये पहली मंजिल है, तुम तो अभी से घबरा गए. घबरा गए क्या? Right? Come on everyone. Pitch. Okay, pitch. You should share it with everyone, so that everyone should come on this session, right? Okay. Pitch. A very simple explanation of the pitch. Linear distance covered on main scale on completing one full rotation. On completing one full rotation, the linear distance that is covered on the main scale, it is known as, right? And the nicer, it's okay. On completing one rotation on the circular scale, the linear distance covered on the main scale. On completion of one rotation on the circular scale, linear distance covered on the main scale, this is known as pitch. Right? Least count, again, the formula of the pitch. Right, we are having only the simple explanation of the pitch. In micrometer screw gauge, the least count is equal to pitch, right, whole divided by number of division on circular scale. Right, this is the formula of least count. Okay, now apart from this, we are having the formula of zero error. Zero error as usual remains same, that is number of the division coinciding into the least count. Right, it can be positive, it can be negative. If zero is beyond the reference line, right, then it is a positive error which is going to get subtracted. Okay, which is going to get subtracted. I'm sorry, in this formula we are having the, okay, negative zero error, and here, right, plus or minus going to add. Here there is a negative. Okay, similarly in this, right, into the formula of the actual reading is equal to main scale reading plus nth division coinciding into LC, okay, minus zero error. Okay, this is the actual formula of the micrometer screw gauge. Okay, if you are able to understand this, things are going to be quite easy. Come on everyone, those who are live, yes or no? Okay. Yes. So that thing is mentioned here. Okay. That thing is mentioned here. Okay. See, least count. Okay. For screw gauge, for the vernier caliper, for the meter scale. Oh, why screw gauge and the micrometer screw gauge and vernier scales calipers were introduced? Because up to 2 or 3 decimal places we are not able to measure that stuff. For that reason, this thing, right, it was important to introduce the screw gauge and caliper. Why? Through meter sticks and the regular measurements we can't measure up to 2, 3, 4 decimal places, right? So for that reason, these instruments are quite useful. Okay. For stopwatch, least count is this. For temperature of the thermometer. In errors and measurements, right, the least count, these values are quite important, mark my words, because a maximum time, right, maximum number of time, right, these values are not given and we have to accept it. Yes or no? Come on everyone. Sat Sri Akal and Namaste from my side. Yes or no, guys? So this least count are important. Okay. Apart from this, significant figures you all are aware of. Okay. There are some rules like non-zero digits are significant, trailing zeros in the number. This all things are there. We are not going to waste time on the significant figures that you all are completely aware of. Now directly we are moving forward right to the errors. Okay. Directly we are moving for the errors. Okay. Now what kind of the errors are available? First, systematic errors, random errors, errors due to the personal reasons, sir, instrumental errors, lots of errors there, sir, entire physics is an error, that apple fell on the Newton's head, right? If it would happen, it was an error, right? Right, on that time it fell near to the Newton and Newton thought, right, and discovered the gravity. That was an error, sir. Entire physics is an error. What we can do? We want to have an admission into the IIT. That's why we are accepting this error, sir. Okay, this kind of the thoughts, right? You all might be having this scrolling into your mind. Okay, yes or no? Okay, so error. Simply, we are going to discuss error into the very simplified form. Okay, so error states that states that the first error it is going to help, that is absolute error. The first error that is going to help us, right, into understanding the phenomena of the errors, that is absolute error. Absolute error, it is a very simple thing. Difference of true value and measured value. Difference of true value and the measured value. It is a very simple thing. Difference of true value and the measured value. My papa gave me 10 rupees for the pocket money. It is impossible. I demanded for the 1000 rupees. My dad gave me 1000 rupees for the pocket money, right? And when he was just, he was just writing up into the system to find out the, whatever the amount of the expenses I have done by end of the month. So the system was saying that he has given, write me 2000 rupees. But what was an actual thing? He had given me as a pocket money 1000 rupees. So what is a true value? 1000 rupees. What is a measured value that system has measured, right, wrongly measured? 2000. The difference between them is an absolute error. Sir, please don't dream. My dada never gave me 1000 rupees. It's not fair, sir. Your dad has given you 1000 rupees. Daily 30 rupees you are spending into the momos, right? The bloody hell momos, right? Okay. So now this was an first absolute error. Delta A is an absolute error, that is true value minus measured value. Absolute error can be positive, can be negative, can be zero. But whenever the absolute error, right, it is calculated right, with respect to, with the relative, or whenever the percentage error of any experiment is calculated, then absolute error is always positive. There is a difference, mark my words. Absolute error individually can be positive, can be negative, can be zero. But in summarized form, when entire percentage error of an experiment is measured, is calculated, then the absolute error is always positive. Yeah, it will cover all concept, it will cover all chapter, it will cover all physics. You have to just stay till end. Please don't questions and enjoy the lecture, right? Please don't pose the questions, okay? So now, the second one, it is, right, the relative error. Relative error is having no relation, okay? The relative error is having no relation with else person, right? Else relative, those who are unnecessary coming to your houses and continuously commenting, beta ka hua, ka kiya. Bas, the percentage. That much only, right? Sharma ji ka beta 99%, what the hell, huh? Only. So this is not that relative, an error into that is completely different. My father gave me 1000 rupees as a pocket money. His system was showing 2000. My true value is 1000, system is showing the measured value 2000. So the relative error is, true value is what fraction? I'm sorry. Absolute error is what fraction? Absolute error is what fraction of the true value? The difference is of the 1000. That is an absolute error. That absolute error is what fractional part of the true value? Right? So that is a relative error. We can define it as delta A by A. Okay, this is going to be, okay, relative error, not absolute error, I'm sorry. Okay, relative error, this is going to be, right, relative error. Okay, and the third one, that is the last, percentage error. When the relative error is multiplied by 100, okay, we are going to get the percentage error. Apart from this, into the errors, and see, this is what the description it has been given. The mean absolute error, if we are having the lots of measurements, right? If we in an experiment, right, if we are having the n number of the measurements, one absolute error can be calculated by this way. If you are having more than one absolute errors, then you have to take the mean value. More than one absolute errors only arises when we are having more than one observations. So this is a relative error and this is a percentage error. The very basic explanation of that, right? Okay, this is the formula of the screw gauge. The readings of the screw gauge, how they are taken. This is the formula of the least count of the screw gauge. Okay, this is the formula of the vernier caliper and the least count of the vernier caliper. Okay, one thing that is remaining in this chapter now is the combination of the errors, and we are going to complete the first chapter. Yes or no? Okay, please everyone like this session, because PW2, yes beta, we do a lot, we work day and night for you all, because, right? This session is also going to be more than 12 hours long, right? So now, rapidly we are going to discuss this first chapter, and immediately, because lots of time, right, we have consumed. Okay, so yeah, combination of errors. Simply we am going to tell you all combination of errors. The first is the case of addition, okay, and subtraction. Okay, case of addition and the subtraction. How we are going to deal with that stuff? Suppose Z is a physical quantity that is made up, Z we want to measure, that is made up of the two physical quantities A and B, either they are added or subtracted. Okay, so we can say if they are added, then their absolute errors will also be added, right? And the relative error, that will be equivalent to delta A plus delta B whole divided by A plus B. Similarly, if they are going to get subtracted, then the relative errors, the absolute errors are going to get added, and similarly delta del Z by Z, it is going to be delta A plus delta B whole divided by A minus B. Okay, so this is going to be the case of the addition and subtraction. Apart from this, the second case, it would be, okay, let's discuss the third case, that is multiplication and division. Multiplication and division, right? So in this case, what is going to happen? Suppose Z is a physical quantity, either it is multiplied, or Z is a physical quantity, either it is divided. Okay, so in this case, what is going to happen? In the case of addition and subtraction, absolute errors are easy to calculate. In case of multiplication and the division, the relative errors are easy to calculate. So delta Z by Z is equal to delta A by A plus delta B by B. Okay, and if you want to calculate the absolute error from this, right, then you have to do delta A by A plus delta, right, B by B into Z. Similarly, delta Z is equal to, right, delta A by A plus delta B by B. Here Z would be A multiplied by B, here Z would be A divided by B, that's it. And the third case, the second case is one physical quantity that is multiplied by n times, or one physical quantity that is minus n. In all of those cases, delta Z by Z is equal to n delta A by A. Okay, this is all the combination of errors is all about. Good morning, everyone. Sat Sri Akal. Is it clear, guys? Come on, everyone, those who are live, is it clear? Okay, so here the first chapter ends. Now directly we are moving forward to the rectilinear motion. Directly we are moving forward to the rectilinear motion. Okay, in units and measurement, measuring instrument, caliper, screw gauge, errors, and some of the theoretical aspects, right, like dimensional formulas and validity is not going to come, right, but NU, the thing that is discussed here, it is having the highest possibility to come up into an examination. Right, and don't get worried, the energy with which we started our lecture till end, we are going to be like that only. Okay, till end. Okay, because this is right. Okay, come on everyone, thumbs up into the comment box. We are moving forward to the next chapter fast. Come on, is it all? I want everyone to thumbs up. All are live. Jinda ho, nikal liye, yes or no? Okay. Now, rectilinear motion, entire third chapter is only about three kind of motion. Entire third chapter. Please don't get confused. Let's summarize the entire chapter into on a tips. Entire third chapter is only about three types of the motion. The first one, that is the, just hold on guys. Okay. The first one, that is the uniform motion. The second one, that is uniformly accelerated motion. And the third one, right, that is least asked into an examination, that is non-uniform motion. The fourth, sir, you told us three. Yes, but I'm going to deliver you all the fourth one. Sometimes, why I told three? Because sometimes the relative motion is explained into 2D only, direct. It is explained into the 2D, but separately we can also do that. It's not a big deal. Only 3 to 4 formulas are there into the relative motion. Right, guys? Come on, everyone. Lots of medical loves I am getting from Abhishek. Okay, lots of thumbs up, lots of fires. Someone is saying English, cool, sir. English, cool, because this is a pure English channel, my dear friend. Let's have the English accent, right? The US accent states that, whoa, that's as English. How we can deal with that, my dear? And Indian English. So students, this is the lecture into the pure English mode. Okay, this is an Indian accent. So that was the first US accent, right? So lots of things are there, and this channel is completely about the English mode. So we have to focus on that. Okay, come on everyone. Okay, someone is saying sound is not balanced, beta. Before coming up into the everything is tested. Okay, so you can check your system, your headphones. Okay, please lower down the volume because I'm Sardarji. I'm having already having the high pitch. Okay, I'm Sardarji. I'm already having the high pitch, so you can lower down the volume because I can see the bits, the volume levels here into my system. Okay, they are touching an edge. Okay, they are touching an edge. It's okay. So, now things apart, we are going to discuss the most important thing now in this chapter. The four most important types of the motion: uniform motion, uniformly accelerated motion, non-uniform motion, the least asked into an examination, the most asked into the calculus method, and apart from this, relative motion. Now, distance, displacement, speed, velocity, average velocity, acceleration, graph, blah blah, everything is summarized, everything is included into these 3-4 statements. Everything is included into the 4 statement. Yes or no, guys? Everything is included into the 4-3 statement. Okay, that might be possible. I'm moving aside near to the board, then sound might immediately reacting it. Okay, or sorry, reflecting it. This might be possible, but things are okay from our side. Don't get worried. Now please concentrate on the lecture. See, the first right definition from this chapter, it is going to come up as an average velocity displacement by time. Now at the last moment, I'm not going to discuss what is distance, what is displacement, right? I'm not going to discuss that part. Okay, the 3 most important definitions related to the velocity: average speed, instantaneous velocity. Instantaneous velocity is right, you are going to maximum use the instantaneous velocity into the calculus part, right? Okay, the instantaneous velocity is in summarized form, it is dx by dt. Okay, dx by dt. Similarly, okay, maximum, okay, river problem, rain problem, everything. For river problem, I'm going to provide you all a shortcut. For rain problem, I'm going to provide you all a shortcut. Okay, in 2D, I'm going to provide you, in NLM, I'm going to provide a shortcut. In work energy power, shortcuts are going to come. In rotational motion, rolling motion, the shortcuts are going to come. Lots of things are going to come. In SHM, in waves, our shortcuts are going to come. Okay, in Doppler effect, shortcuts are going to come. Don't get worried. Okay, lots of shortcuts are going to come. We are discussing rapidly only, so stay till end. Okay, so this is an instantaneous velocity. Directly we are moving forward to the next part. Okay, apart from this speed, okay, apart from this, we are having average speed, okay, average acceleration and instantaneous acceleration. Average acceleration is change in velocity by change in time, and instantaneous acceleration is completely about maximum used into the calculus method. Maximum used into the calculus method, and it is defined as the small change time rate of change of velocity. The velocity is right changing by very small value, that limits tends to 0. Okay, yes, everyone from NDA, for Air Force, everyone can watch this. Okay, lots of things you are going to help, right? So this is what a very basic and chitput things. Okay, apart from this, see, for graph and graph conversion, before moving on to this value, I am going to give you all the Ramban of the graph. Alright, at the very end moment, I am going to give you all the Ramban of the graph. First, right, what are the Ramban? See, in graph, right, y is equal to mx plus c. The equation of line is going to help, right, into multiple forms. It is going to help in multiple forms, right? Yes or no? The equation of the line, it is going to help you into the multiple forms. Second, the equation of parabola. Y is directly proportional to x square, right? Y square is directly proportional to x. Okay, this is y versus x graph like this way. Okay, and this, okay, this is the y versus x graph, parabola kind of thing. Okay, the third graph it is going to help you all is the graph of the circle. Okay, that is x square plus y square, that is equal to r square. Okay, apart from this, okay, the graph of, okay, the ellipse is going to help x square by a square plus y square by b square, that is equal to 1, right? This is a graph of ellipse, right? Okay, a is a semi major axis, this a and b, you can say it like that way. Okay, yes or no? Okay, so apart from this graph, what is going to help? First of all, these are the fundamentals. Okay, this thing are really going to hit up. These are the fundamentals, and these things are really going to hit up, and you need to remember, because entire calculus part, maximum number of the questions that are coming from the graph are graph conversion, and I'm going to give you all a shortcut for this. First, basics of the graph. Right, the basics of the graph includes the slope and area. Right, this is y-axis, this is x-axis. Suppose this is a straight line, this is a theta, then slope, that is equal to y by x, that is equal to tan of theta. Right, the first part. Okay, the second part, suppose if the curve is crossing through single point, or if the curve that is crossing through 2 points, how you are going to calculate the slope? If it is crossing through single point, right, draw the tangent, this theta will be the slope, right, that is equal to dy by dx, and that is equal to tan of theta. If it is crossing through 2 points, then you have to draw the secant, right? This is a secant, okay, and this is going to be the slope, right, that is equal to tan theta, that is del y by del of x. Okay, so these are the slopes calculated from the multiple graph. Now how areas are calculated? Okay, areas, right, how areas are calculated. Suppose we are having the symmetric graph like this way, okay, then this will be the area, this will be the area under the graph, and that is always right defined as y physical quantity into the x physical quantity. It is always defined as y physical quantity into the x physical quantity, yes or no? It is always defined as y physical quantity into the x physical quantity. Okay, similarly, if you want to find out the area of the curve, okay, so this is y, this is x. Suppose you want to calculate the area of the curve between these two limits, right, between these two limits, this is x initial, this is x final, right, then area, that is integration of y dx. Okay, integration of y dx. So this is how slope is calculated, this is how area is calculated. These are the types, right, of the graphs that are going to come up into the examination. Now what about the Brahmastra for the graph conversion? What are the Brahmastra of the graph conversion, right? Okay, Brahmastra of the graph conversion, right, that we are going to discuss. Come on everyone, okay, those who are live. See, lots of unusual requests are coming on. Please concentrate on the lecture. Okay, please concentrate on the lecture. So what about the graph conversion we are talking about? Brahmastra and shortcut of the graph conversion. Okay, first, identify the nature of given graph. In the question, step 2, apply, obtain the equation, right? Okay, apply calculus method. Fourth, according to the result, obtain the graph. Right? These are the 4 steps, and Ramban, I'm going to solve one question for you all. Because these are the steps that are newly introduced in front of you all. These steps are newly introduced in front of you all. So guys, are you all, see, these steps are applicable for all kind of the questions. So come on everyone, into the comment box. Are you all ready? Thumbs up. Come on guys. Are you all ready? Yes or no? Yes, Tanish. Wait. एक famous question भी तो है deceleration वाली. Let's don't. Are you ready? Come on everyone. We are going to discuss one question of the graph conversion using this step, and these steps are applicable for all kind of the questions, right? Yes or no? Okay. So what is going to help? First, suppose in the question data is given as, right? Okay, data is given as, just hold on. The V versus X graph is given like this way. V versus X graph is given like this way. Obtain the respective X acceleration versus X graph. Okay, find acceleration versus X graph. Right. Step 1. Identify the nature of the graph. This is the data given. Identify the nature of the graph. It is a straight line. Straight line, it means we are going to follow this equation. Y is equal to mx plus c. On y-axis, we are having velocity. On x-axis, we are having displacement. Let's say slope is m. Are we having any kind of the intercept into the graph? No, 0. Step 2, obtain the mathematical equation. Successfully we completed. First, identify the nature of the graph, straight line. Second, obtain the mathematical equation, successfully completed. Now, third step, apply the calculus method. There are 3 formulas into the calculus method, right? A is equal to V dV by dx, right? A is equal to dV by dt, V is equal to dx by dt. From these 3 methods, right, you have to remember how we can reach from velocity to acceleration using x. How? Using the, see, velocity is given now, we have to reach up to the acceleration via x, not time, via x. How we can reach from velocity to acceleration via x? It means we can only use this formula. So what I'm going to do, I'm going to differentiate this equation with respect to time with x. I'm going to get dv by dx, that is equal to m. I applied the calculus method, but still, right? Acceleration is v dv by dx. Velocity is mx. dv by dx we got it as m. So the equation of acceleration we got it as m square x. See, this is how we reach from velocity to the acceleration. Third step successfully completed. First step, identifying the graph, straight line. Second, obtain the mathematical equation, we obtain. Third, apply the calculus method. With respect to the x, I differentiated and find this is equation number 1, this is equation number 2. What is the formula of acceleration depending on the x? A is equal to dv by dx. Depending on this, I obtain. Now from this expression, obtain the last step of the graph. See, this is also the straight line. So the graph of acceleration versus x would be the straight line with 0 intercept, and the slope that will be equivalent to tan theta, that is equal to m square. This is how, right, the shortcut is applied and graph conversion based sums are done. Is it clear? Thumbs up guys, come on everyone. The 4 immediate steps on the graph conversion. The thing that is having the highest possibility to come up into the examination, I'm focusing more on that. I'm consuming more time on that. Come on, thumbs up guys. Right? So these are the 4 simple steps, right? Okay, to solve all the sums of the graph conversion. Identify the nature of the graph, obtain the mathematical expression from that, right, from the given nature, apply the calculus, obtain the final equation depending on whatever the question is asked into an examination. From that equation, plot the graph. Thumbs up, guys. Great. Let's move on to the next part. Graphs for uniformly accelerated motion. First of all, I want to... Okay. Before moving on to the graphs of the uniformly accelerated motion, directly we are moving on to the graph of uniform motion. Rapidly we are going to discuss. Uniform motion, it means velocity, speed constant. Okay. So, the x versus t graph, okay, would be like this way. Okay. V versus t graph would be like this way. And acceleration, right, versus time graph would be 0, nothing. Okay, so these are the graphs of the uniform motion. These are the graphs of the uniform motion, yes or no? Okay, now directly we are moving forward to the second type, that is the graph of the uniformly accelerated motion. The graph of the uniformly accelerated motion, right? Uniformly accelerated motion, it means it is very simple thing. The acceleration of the particle is constant. Constant means it can be any value. It can be positive, it can be negative. Positive, it is acceleration. Negative, it is deceleration. Right? X versus t graph. Uniformly accelerated motion, x is equal to ut plus half at square. Right? This is the equation of the displacement. Velocity equation, v is equal to u plus at. Right? Okay? And acceleration is always constant. So in this case, if you want to plot the x versus time graph, okay, then here see, you can see the relation. X is directly proportional to t square with some constant value, that is ut. So this graph is gonna be curve, the parabolic graph. Okay, so these are the two graphs. When acceleration is greater than 0, okay, it is written, see, it is a quadratic polynomial in terms of the... What is a v versus t graph? If velocity is increasing with respect to the time, from the equation v plus u, v is equal to u plus at, velocity is increasing. V is equal to u minus at, velocity is decreasing. These are the two graphs of the velocity. One, the slope. See here, area of v versus t graph will give distance and displacement. The slope, right, will give the acceleration. Okay. Apart from this, the acceleration graph, the area of this graph will give change in velocity. Okay. Positive acceleration, negative acceleration. So these are all of the graphs. Apart from this, lots of graphs are given into the thousands of books, but we are not interested into that part. Okay, these are the graphs. Okay, now let's move on to the next part. Okay, maxima and minimas are there. These are the equation for the uniformly. S is equal to V this, right? Okay, this is an equation of the nth displacement. Okay, now let's move forward to the next part. Okay. One of the applications of the uniformly accelerated motion, it is a case of motion under gravity. One of the applications of the uniformly accelerated motion, it is the motion under the gravity. Sir, your name is Indrajit Singh, just asking. Yes, right? Yes, I am Indrajit Singh. Indrajit Singh. Indrajit Singh. Okay. So, motion under gravity, according to the Galileo, if object is released, two objects are released from the top of Leaning Tower of Pisa, irrespective of masses, and atmosphere is completely avoided, then they are going to constantly accelerate it towards the center of the earth. And that acceleration value with which particles are getting accelerated towards the center, It is G, gravitational acceleration. Value is 9.8 meter per second square. Generally, we are taken into the consideration as 10 meter per second square. Okay. So these are all of this equation. The most important thing into the motion under gravity is sign convention. Students are aware of what does this concepts convey to you all. Students are aware of what actual it is. Students are always confused of how to apply these sign conventions. For entire physics, this is positive x, this is negative x, this is positive y, this is negative y. For entire physics, we are going to follow this convention. The direction in which vector is there, take it positive. Suppose if the vector is in this direction, we are taking it as a positive I. Suppose vector is in this direction, we are taking it as a negative I, right? Suppose vector is in this direction, we are taking it as a positive j. Vector is in this direction, we are taking it as a negative j. That's it. That's it. That's it. Whenever the kinematics is taught, right, before that, generally what happens, the vectors, somewhere vectors are there, somewhere vectors are not there. So for that reason, at many institutes or many schools, it has been taught take downward as positive and upward as negative. No. In entire physics, in entire syllabus, we are going to take upward as a positive j, negative as a negative j, this side as a positive I and this side as a negative I. That's it. Bankim Sarkar, I know you sir, you was my physics teacher in 2020 NEET batch. Okay, thank you Bankim. Okay. So this was the sign convention with respect to the point of projection. T is equal to 0 is the point of projection POP. With respect to point of projection or in between 2 points, sign conventions are applied. Okay. Now let's move on to the next part, the projectile motion. Relative 1D and 2D we are going to discuss into the riverman and rainman problem and going to provide into shortcuts for it. Are you all ready? Guys, yes or no? Come on everyone. Okay. Are you all enjoying the, see 1 hour as we have completed approximately. Are you all enjoying or not? Yes or no? Come on everyone, those who are live. Can I have the thumbs up into the comment box? Are you all getting bored? Yes or no? Certainly someone is saying note sound. Please, guys, please increase the volume of your device. Everything is there. Everything is going perfectly fine. Yes. You all are enjoying? Okay, you all are enjoying. It's okay. Shall we move forward? Okay, someone is saying you are not enjoying. You are free to move. Thank you. So now, projectile motion. Entire projectile motion, like entire 1D, right, was in between. Uniform, uniformly accelerated applications and relative, like that way. Entire projectile is classified into 3. The first one, that is oblique projectile motion. The second one, right, that is the horizontal projectile motion. And the third one, right, oblique projectile motion, horizontal projectile motion. Okay, inclined plane projectile. Horizontal projectile, oblique projectile, right? These 3 are the examples, right, in which entire projectile motion is getting covered. Someone is saying no sir, please do sums, right? At the end moment here we can only do the revisions, right? At the end moment we can only do the revision, and for the important things, right, we can see I gave you all, show you all the sums of the graph conversion. The moment at which I can understand the sums are important, I'm going to deliver that part, right? So don't get worried. Okay, yes or no? Okay, now let's move on to the next part, right? Okay, yes. First, these are the formulas for the oblique projectile motion. This is the time of flight, horizontal range, maximum height, and the equation of the trajectory. Basically, there are two equations of the trajectory. One is x tan theta minus gx square by 2u square, and second is x tan theta 1 minus x by r. But what is an actual logic of the projectile motion? An assumption. See, whenever the particle is thrown with some specific velocity at an angle theta with respect to ground, projectile is 2D, right? It means one component of the velocity that is contributing into the horizontal motion, one component of the velocity that is contributing into the vertical motion, one component of the velocity that is contributing into the horizontal, right? One component of the velocity that is contributing into the vertical. Now, air resistance is absent. Right? Air resistance is absent. It means there is no acceleration into the x direction, right? That can see. Velocity into the direction of the acceleration, it is going to speed up the system. Velocity into the opposite direction of the particle, it is going to speed down. Velocity and acceleration in same direction, speeding up the system. Velocity and acceleration into the opposite direction, speeding down the system. Right? So here u cos theta is constant. So generally projectile is defined as the contribution of horizontal, right, plus vertical, right, horizontal and vertical. Horizontal, no acceleration, so the nature of the horizontal motion is uniform, right? Okay, vertical motion, we are having g. Opposite to the velocity, we are having g, that can increase or decrease the value of u sin theta. This g is constant. So for that reason, the vertical motion is uniformly accelerated. Right? So in another sense, projectile is nothing else but uniform motion plus uniformly accelerated. This is I vector, this is j vector, this is I vector, and this is j vector. Okay, this is all about the very summarized thing I wrote in front of you all. Okay, a very summarized thing I am telling in front of you all. This is the oblique projectile. The logic is all about, all of those projectiles are combination of two, horizontal, vertical. Horizontal, the nature of horizontal and vertical motion combinedly are going to define all of the equations of the projectile. Yes, dropper wedge is going to come soon. Okay. Horizontal inclined plane projectile. But before moving on to that, let's move on to the horizontal projectile motion. Right? Inclined plane projectile and horizontal projectile motion. Okay? Horizontal projectile motion, simple, right? From the height h with respect to ground, the object is thrown with some horizontal velocity and the trajectory that is covered, it is known as horizontal projectile. With respect to the point of projection, again I am saying, right, the projectile, it is combination of horizontal motion into I, vertical motion into j. Here again two factors. Initial vertical component is 0. But what is the nature of horizontal and nature of vertical? Horizontal velocity is affected by no acceleration because air resistance is absent. Right? Air resistance is absent. So it means that horizontal motion, it is the right uniform motion, okay, of I. Okay. Plus vertical motion is uniformly accelerated motion of j. Horizontal motion is the uniform motion of I plus vertical uniformly accelerated motion of J. Yes or no, guys? Come on, everyone. Okay, so in this case, first it is going to come upon as equation of trajectory minus gx square whole divided by 2u square. This is the equation of the trajectory for the horizontal projectile motion. Time of flight under root of 2h by g, right? Range, okay, that is equal to, okay, under that is u under root of 2h by g. So these are the three most important formulas, okay, that are used into the horizontal projectile motion. Okay, three most important formulas. Okay, next class, see, right now I'm into the mid of the live session. I can't change out the screen now. Okay, you requested, sir, from next time please bring that black screen. It's okay, I'm going to deliver that part, right? Don't get worried. But from now onwards, for this session, we can move on to like that now. Into the horizontal projectile, into the oblique projectile motion, right? Okay, lots of equations are there. Now, the third type of the projectile, it is the inclined plane projectile motion. All of those formulas of the inclined plane projectile motion are mentioned here. Okay, now here, all of those, right, those who are teaching, they used to confuse you all, okay, with projectile thrown from bottom to top, top to bottom, bottom to top, top to bottom, like that way. Bottom to top, top to bottom, bottom to top, like, but there is no need, right? For the horizontal, like for the projectile at the inclined plane, there is only one Brahmastra, right? I'm going to show you all. Inclined plane projectile. Right, inclined plane projectile, there is only one Brahmastra. Inclination angle is alpha, right? Object is thrown as beta. In entire physics, if you are going to solve the sums on the inclined plane, in entire physics, always takes the inclined plane as the x-axis, perpendicular to it as a y-axis. Always take inclined plane as the x-axis and perpendicular to it as a y-axis. Always, right? Inclined plane as the x-axis, perpendicular to the, this is only in all of those, in mechanics and rotational and everywhere. Okay, spammers, please move aside. Please don't waste your data pack, because lots of students are there here to study. We don't care. Yeah, we respect you. For that reason, we respect spammers. For that reason, we are saying, please save your data pack. And please go and move on to the scrolling the Instagram reels, please. Right? And let those students, those who are present here, study. So first, inclined plane as an x-axis, perpendicular to it as an y-axis. Right? Now, there are two components of the acceleration, right? This one is a g cos of alpha. This one is a g sine of alpha. Similarly, two component of the velocity, u sine of beta, right? U cos of beta. Now, this thing is going to be the awesome. In oblique and horizontal projectile motion, okay, in oblique and horizontal projectile motion, one was uniform, second was uniformly accelerated. But in inclined projectile motion, with respect to the inclined plane, the x is also having the nature of uniformly accelerated, plus y is also having the nature of uniformly accelerated. Why? See how, right? How? Okay, see, u sine beta, to increase and decrease u sine beta, we are having g cos of alpha. This is all about vertical motion. Okay, for about the horizontal motion, we can say, right, u cos beta, to decrease u cos beta, we are having 1 sine alpha. To all of the horizontal component, to the vertical component, we are having one acceleration, and that is constant. So for that reason, we are having one acceleration that is constant, and for that reason, what is going to help? right? The vertical motion is also uniformly accelerated. The horizontal motion is also uniformly accelerated. Yes or no? Okay. So this was the logic behind the inclined plane projectile. Okay. And these are the formulas. Okay. Up the inclined plane, down the inclined plane, formula of range, formula of time of flight, right? Angle of projection. Okay. The formula of maximum range. Okay. These are the four most important formula, right? Okay. Saurabh is saying clear ho raha hai sab. Okay, they don't deserve your reply. Come on. Okay, now we are going to move forward, right, to the Brahmastra of the relative motion, right? We are moving forward to the Brahmastra of the relative motion. Entire relative motion is all about the position of the observer, right? Entire relative motion is all about the position or frame of the observer. Entire. And relative motion proves that if the frame is getting changed, observer is getting changed, things are getting changed. Frame is getting changed, observer is getting changed, things are getting changed. Yes or no? Observer is changing its position, right? Things are changing its right direction. Okay. Okay. So in relative motion, everything is, I'm going to give you all one example for the relative motion. Okay, then immediately we are going to move forward through the shortcuts and Brahmastra of the riverman and the rainman problems. Okay, see, a very simple example. Ground, right? Observer A. Observer B. Okay, one observer is on the ground. One observer is on A. One observer is on B. We have in one simple example. What simple example? A is moving with 15 meter per second. B is moving with 10 meter per second. Right? In a very simple example, I have taken the three observer. One is on the ground, second is on the A, third is on the B. Okay? Good morning, everyone. And guys, please mark your attendance by liking this session. Right? I'm not saying continuously in an entire part. Just like it, like it, like it. No. Just like the session. It is a kind of an honor for us that you all are giving. Okay, it helps us, it motivates us to do more and lots of things for you day and night. Okay, with, see, three statements I am writing it here that will define the, with respect to observer on ground, velocity of A is 15 meter per second, velocity of B, that is equal to 10 meter per second. With respect to observer on A, suppose observer is on A, I am on A, it means I am also having the velocity as compared to the A. My velocity 15 meter per second, A velocity 15 meter per second, relatively zero. So A appears stationary. Wow. A, I am on A. See, I'm on the car A, guys. Yes, nice. Very good. Now what happens if observer is on the A? Velocity of A with respect to observer is zero. So for that reason it appears as stationary. Velocity of B with respect to A, VB minus VA, 10 minus 15, negative of 5. What does this negative sign indicates? If observer is on A, negative sign indicates A, B is coming nearer. Oh, B is coming nearer. Why? B is having less velocity, right, as compared to A. I am on A, right? B coming nearer. When I was on the ground, A moving, B moving, A moving, B moving. But when I was in A, when I was observer on A, B, you are coming nearer. Now what happens to when the observer is with respect to B? I am on B. A. Now I am on B. So what is the velocity of B with respect to B? 0. What is the velocity of A with respect to B? Positive of 5. I was on A, B is coming. A, you are coming nearer. When I was on B, yeah, चला, you are saying A, आगे बढ़ो, चला, 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 आगे बढ़ो, चला, चल, छूटा नहीं, चला, move forward. With respect to observer on ground, balle, things were different. With respect to the observer on A, things were different. With respect to the observer on B, things are different. This is what the relative motion is all about, guys. If this logic you are having into your mind, right, I bet things are going to be quite easy. Now I'm going to give you all the Brahmastra for the relative motion for all kind of the questions. Okay, someone is saying Sardarji plus Pagnal plus teacher plus speak English in place of Punjabi. Lots of explain combinations are there. Oh Paji, मैं क्या तुसी ऐदे औदे नजर ना पाओ तुसी English में concentrate करो पाजी. Right. At channel the pure English mode सी. Pure English mode. तुसी ऐदा विच concentrate करना पऊगा. Let's move forward. Now, entire relative motion, okay, riverman and rainman problem I'm going to explain you all. But before that, the basic fundamental sums that are coming on the relative motion, I'm going to give you all a shortcut. Right? Shortcut for basic relative motion problems. RM stands for relative motion. Basic relative motion problems. RM stands for relative motion. Right, guys? Right. Okay, one of the best physics teacher. Thank you, Bacha ji. Thank you. Okay, rest of the communist people, please leave. So basic relative, always check. There are some steps. Always check in question whether A12 is 0. Acceleration. See, in relative motion, always two objects are involved. In relative motion, always two objects are involved. Basically, right, I'm not from Punjab, I'm from Gujarat. Right now, I'm taking live sessions from Gujarat, from my, right, okay, from Gujarat. I'm from Gujarat, right? So, right now, taking live sessions from here. Okay, so this is not the Sardarji with Pug, with not speaking Punjabi with English. मैंने गुजराती पर आवड़े छे, right? Okay, मुझे हिंदी भी आती है. गुजराती में भी हमें બધું वो एक्सप्लेन કરીએ છે, कोई प्रॉब्लम નથી. मुझे हिंदी भी आती है, right? I teach English, right? मुका सिंधी भी हिंदी है, right? I teach like lots of languages, total 6 languages, right? I read, write and speak. So it's not about, okay, break. We are not going to get break. I'm sorry, we are not going to get break. Okay, after physics you will get the break of 10 to 15 minutes, right? Okay, so for the basic relative motion problems, always just check it out. For the basic relative motion problems, always just check it out whether acceleration of, see, always two objects are involved. Acceleration of one with respect to two is going to be 0. Two possibilities are there, whether acceleration of 2 with respect to 1 or 1 with respect to 2 is going to be 0, or acceleration on 1 with respect to 2 or 2 with respect to 1 is not going to 0. If this is the case, then it is a case of relative uniform motion. In the case of relative uniform motion, we are having only one equation. S is equal to, V is equal to displacement by time. Right? Linguistic teacher. Yes. Hindi bhi aati hai, Gujarati padna avade chhe. I can teach in English. Right? 5 to 6 languages. Right? When I was in Hyderabad, right, I was a bit comfortable 6 years back. Right? When I was 8 years back, sorry. Yes. When I was in Hyderabad with some project work. So at that time, in my group, I was a bit comfortable with, right? I was aware of some Telugu also. Right, so that was what we can say, the half 6 language was adding up into my system, right? But now it has been 8 years, so I forget some of that part, right? Okay, so if two objects are involved, if acceleration of one with respect to another is 0, then directly it is the case of relative uniform motion, right? If it is not equivalent to 0, then it is the case of relative uniformly accelerated motion. It is the case of relative uniformly accelerated motion, right? So it means that either acceleration 1 with respect to 2 or 2 with respect to 1, both of them are constant values. So in that case, how we are going to solve the sums of the relative motion, right? V1 of 2 is equal to U1 of 2 plus A1 of 2 into T. S1 of 2 is equal to U1 of 2 of T plus half A1 of 2, right, into T square. V1 of 2 square minus U1 of 2 square to A1 of 2 S1 of 2, right? You can take your own observer. In this case, observer is 1. Sorry, observer is 2. You can take 1 as an observer. So this is what the basic, how we are going to solve the basic, right, relative motion problems. Clear, guys? Bagunara. Okay. Now, directly we are moving forward to the riverman and the rainman problem. You are not going to understand this, I guarantee, because lots of things are written. You are not going to understand this, I guarantee, because lots of things are written, right? You are not going to understand this, okay? So for that reason, I'm going to provide you all the shortcut for the riverman and the rainman problem, for all kind of the right relative problems, right? It's clear, guys? So here I want to move on to the riverman problems. The Brahmastra, right, of solving the riverman problem is always think what happens to observer with respect to ground. Always think what happens to the observer with respect to ground. Always think. This is the Ramban for the riverman problem. And in this, I'm going to give you all the shortcuts of it. The first one, shortest time. Right? The shortest time. Okay, see, shortest time is a very simple case. Come on guys, focus it here. And we are going to end up this 2D and directly we will move forward to the Newton's law of motion. Right, the shortest time. Observer on ground. Swimmer. Right, he want to start from point A. He want to reach onto the opposite side into the minimum time. right? He want to, right? No, nth equation has no relation, right? Nth equation will get differ. Someone is asking, can we apply the nth equation according to that? See, nth equation is just a simple approach as it is given into the lots of books. So you have considered that as a spatial formula. Nth equation is not a spatial formula. It is not a generalized approach. There are lots of limitations for the nth equation, right? If particle is going to retrace its path, particle is going to change back its path, then nth equation fails, right? So you have accepted it as a generalized form. No, generalized are those three equations of the uniform accelerated motion. That's it. Okay, we can do that, but it's not useful. Okay, someone is saying it is dimensionally or right, numerically correct. Okay, so don't get worried. Okay, S is equal to ut, right? While deriving this equation, lots of terminologies are getting cut. So for that reason, right, this equation appears to you in front as dimensionally incorrect. Okay. Now, let's concentrate to the shortcuts of the Riverman problem. Always considered what observer thinks who is on the ground. Now, shortest time. I am the swimmer. I want to reach to the opposite point. I am swimming perpendicular to the river. I am swimming perpendicular to the river. But what happens? River is also, blindly I am swimming perpendicular. Oh, I am moving straight. I am moving straight. I am moving straight. But river is trying to drift me with its flow. So VR stands for velocity of the river. So when I'm jumping off perpendicular to the river, when I am jumping off perpendicular to the river, it feels I'm moving forward, forward, forward. But unnecessarily, I don't, right, feel that river is trying to drift me up. Actually, with respect to river, I am moving like this way. But river is trying to drift me, so I am moving like this way. So who is able to, what is truth? What is a myth? Myth is, I am moving perpendicular with respect to river. So that's why this is velocity of a man with respect to river. What is a truth? Actually, this is a path man is following and this is seen. The truth is seen by the observer on the ground. For that reason, this is velocity of a man with respect to ground. Theta. So as of that reason, the man is scorned. He's stunned. He thought that he will reach at the point B, but unnecessary, he is going to cover the extra drift. That is D, and he is going to reach the opposite point. He is going to reach the opposite bank of the river, but not exactly to the point B, but to the point C. Okay. So what is going to happen here? Right. Directly, see, we are going to use the shortcut. This is VMR. This is VRG. Right. And this is VMG. So from the vector addition, the first equation, this is theta. The first equation that is going to come about as VMR square plus VRG square, that is equal to VMG square. The second, see, entire Riverman problem we are solving by geometry. Entire Riverman problem we are solving it by the geometry. Okay, how? What is the value of sine theta? If I am considering this triangle, the sine theta value is VR of G by Vm of G. That is equivalent to, see, this is drift. This is the width of the river. According to the Pythagoras, this is d square plus b square under root. So this is gonna be, right, d whole divided by under root of d square plus b square. What is cos theta? VMR whole divided by VMG, that is B under root of B square plus D square. What is tan of theta? That is equal to VRG whole divided by, right, VMR, that is equal to D by B. Now, two more important formulas. What will be the minimum time? This is a case of the minimum time, na, shortest time. Why? The man is going with the river flow. River is helping him to cross, right, it. So for that reason, he is going to reach to the opposite end into the very minimum time. Okay. So for that reason, here the two equations are there. Minimum time, that is, suppose if you are taking D, right, then it would be VRG. Suppose you are taking B, then it would be VMR. Suppose you are taking under root of D square plus B square, right, then we are having VMG. What is the length of journey? Actual journey covered by the man, that is under root of D square plus B square. So this all are the shortcuts for the first case, that is shortest time. Is it clear, guys? Okay, whatever the data is given, right, whatever the data is given, VMG is given, VMR is given, we need to find RG, apply this equation. Whatever the data is given, apply the equation from this, that's it. Okay. Second case, shortest path. Second case is of the shortest path. Now what happens into the shortest path? Right? What happens into the shortest path? Okay, come on everyone, those who are live. What happens to the case of the shortest path? Now man is conned. Here it is observer on ground. Right? Man is conned. Okay, man is completely conned. Now he decides something different. He thought first I, right, swam perpendicular to the river conned me and drifted. So this time he thought, if suppose he want to start from point A, then he thought I will jump at angle theta with respect to the vertical. Now I am going to jump like this way with respect to river. River is going to drift me here. I am going to swim like this way. River is going to drift me like this way. I am going to swim like this way. River is going to drift me like this way. See guys, those who are continuously spamming, now please explain in Hindi unnecessarily why you are wasting your time. You are all aware of this is a PW English into the pure English mode, right? Then why unnecessary you are creating a chaos? Okay. So this is VRG, right? This is velocity of man with respect to river. Actually with respect to river, he is swimming at angle theta. But with respect to the observer on the ground, he is able to see the truth. He is moving perpendicular. So this will be velocity of man with respect to ground. This is the width of the river. Right? This is the width of the river. Okay, this is the width of the river. And he thought that he might reach at the point C, but okay, he will reach at the point B. So here also we are having some kind of the right shortcut. The first, suppose if we are considering the triangle, then sine of theta, okay, then it would be VR of G whole divided by VM of G, right? So that will be D whole divided by under root of D square plus B square. Similarly, right, cos of theta, that is equal to V, I'm sorry, this is not VMG, okay, this is VMR. Okay, so it is VMG whole divided by VMR, that is equal to B under root of D square plus B square, right? Tan of theta, that is equal to VRG whole divided by VMG, that is equal to D by B. Minimum time, If we are taking D, then it will be VRG. If we are taking B, then it will be under root of, I'm sorry, it will be right, B VMG, right? And if we are taking under root of D square plus B square, then it will be VMR. So these are the shortcuts for the Riverman problem, right? Come on, everyone. All are live. So this is a shortcut to the Riverman problem. Rainman problem, right? We are having only one thing into the Rainman problem. Okay. Rainman problem, we are having the one thing only. Okay. How? See, for all of those solutions of the Rainman problem, I'm going to show you all a simple concept. How rain appears to running man. This is a Brahmastra and shortcut for all Rainman problems, right? This is a Brahmastra and shortcut, right, for all Rainman problems. How rain appears to the running man. Okay, how rain appears to the running man. Velocity of rain with respect to man. Velocity of rain with respect to man into x direction plus velocity of rain with respect to man into the y direction. The angle that will be equivalent to velocity of rain of y by velocity of rain with respect to man as x. Okay. The direction in which velocity of rain appears to the man, anti-parallel to it, umbrella is hold. The direction, see, I am standing straight, rain is for, like, it's raining vertically. When I start moving, rain is always tilted at some angle. Okay, rain is right tilted at some specific angle. So how rain appears to the running man? When I am moving, how rain is appearing, according to that, I have to hold the umbrella. Newton's law of motion. So guys, we have successfully completed the 3 chapters and it's 1 hour and 40 minutes, right? Slowly, now we are moving fast. Come on everyone, those who are live, is it okay? Guys, those who are live. Guys, it's okay, come on everyone. Thumbs up into the comment box. Okay, valid peoples, right? Okay. Now let's move forward to the Newton's law of motion. Okay, the first one is Newton's first law, right? The second one is the Newton's second law. Okay, the third one is the Newton's third law. The first one is Newton's first law. State of rest, state of motion until and unless external right force acts on it. Thumbs up, come on, thumbs up, fast, be active guys. Okay, from the beginning of the session, I'm containing my energy. It's 1 hour and 40 minutes, right? Come on everyone, those who are live, come on. Duration of the session is going more than 5 hours, guys. It will, because lots of things we are going to discuss now. Rapidly we are moving. First law, best example of the first law. I was sitting ideally sleeping on the I was dreaming. Suddenly what happens? I was dreaming, right? The best example of the Newton's first law, right? The best example of the Newton's first law. I was dreaming. Suddenly I was in the rest as of external force. I have to change my motion. Newton's second law, right? Newton's second law is all about two important things are going to come upon from the Newton's second law. The first is impulse, right? The second one is conservation of linear momentum. The first one is impulse and second is the conservation of the linear momentum. Impulse is in 1, right? Impulse, change in momentum is not 0. Conservation of linear momentum, change in momentum is not 0. Simple thing about the Newton's second law. Time rate of change of velocity is directly proportional to external force applied. Newton's second law states time rate of change of velocity is external force applied. If external force is not equal to 0, it is applied, impulse is there. If external force on this system, right, is 0, momentum is conserved. Momentum is conserved, right? These are the, till what we can say, till 4th chapter, motion in 1D, 2D, units and measurement is a general explanation. Motion in 1D and 2D, right? No, yes, you can score, okay? Okay, you are enjoying the lecture now, yes or no, guys? Come on, everyone, those who are live, are you enjoying this lecture or not? Are you enjoying this lecture or not? Motion 1D, 2D is all about kinematics, in which, right, the motion of particle is involved, right, but we are not considering the cause of the motion. We are not analyzing the cause of the motion, right? But after this, NLM, work energy and power in rotation, everything, the cause of the motion is identified. Are you going to stay till end, yes or no? Come on, everyone, answer into the comment box. Okay. Are you going to stay till end? Yes. Are you going to share this lecture? Are you again going to come back if after a 1 or 2 day again we are going to take back live? Yes or no? Yes, one studios is there. Yes, you are from class 9th. We got that, right? Okay, instead of that, if you are going to remind, then this would be quite easy. Okay, now let's move forward. So in this chapter, entire Newton's law of motion is all about the force. Okay, entire Newton's law of motion is all about the force. The first is the spring force, F is equal to minus kx, right? See what type of the forces we are going to deal in this chapter. Wait. Normal reaction. Normal reaction is a perpendicular component of the force, right, between two contact surfaces. Between two contact surfaces, these are the two contact surfaces, right? Perpendicular component of the force between the two contact surfaces is a normal reaction. In this chapter, you are going to deal with the force that is named as tension. In this chapter, you are going to deal with the pseudo force, right? In this chapter, you are going to deal with the frictional force, right? In this chapter, you are going to deal with the spring force. This 6 forces we are going to deal, and the calculation of all of this kind of the forces chapter is over. Right? Chapter is over. Okay. So among this, we got the first type of the, here in this, and rapidly things are given, right? Things are given rapidly. The weighing machine is all about the mg, right? Weighing machine is all about the mg, right? Here things are given quite rapidly. Okay. Spring forces F. Why spring forces? This you all are aware of. Spring is a kind of the helical structure, right? Spring is kind of the helical structure. In the helical structure, right, slowly the spring is getting elongated, right, or compressed. So slowly delta x part of the spring either elongates or it compresses. So in that case, right here, whatever the restoring, it is an elastic object. So whatever the restoring force is developed, it is directly proportional to delta x. Okay, spring properties there. When springs, right, they are cut. Okay, this kind of the questions are coming up into the examination. When two springs are cut, how to define the value of L, how to define the value of K when the springs are in series. Springs are in series like this way. This is K2, this is K1. Springs are in parallel like this way. This is K1 and this is K2. Right? So this is all a basic about the spring force. After that, immediately we are moving forward, right, to the spring balances and pulley based problems. Basically in this, right, entire tension is all about 3 to 4 things. Entire, right, tension is all about 3 to 4 things. The first one, entire tension is all about 3 to 4 things, right? The first one is tension, massless and frictionless strings, right? Tension, strings and ropes with masses, general constraints, shortcuts, work done by tension, and wedge constraints. The entire tension is all about these 5 things. Yes or no? Can we discuss this thing rapidly? Yes or no? These all are the shortcuts only. Can we discuss this thing rapidly? More about the, right, wedge constraint, the sums are going to come up into an examination. More about the wedge constraint, the sums are going to come up into an examination. So directly we are going to discuss that part. First, the sum of the general constraint. Sum of the general constraints. Yes or no? Okay. General constraint are having, right, lots of methods. Okay. But I'm going to follow the simple one. Going to give you all one example. This is moving with velocity v1 angle theta 1, right? Okay. This is moving with velocity v2 and this angle is theta 2. This kind of the constraint problems are involved, are there, in which angles and the respective velocities are involved. Angles and their respective velocities are involved. How we are going to solve that? What is the Brahmastra? Component of velocity that lies on strings are same. This is a Brahmastra for the general constraint. All of those general constraint problems, right? This is the, right, Brahmastra for it. Okay, the velocity component. Suppose this is v1 cos of theta 1. This is v2 cos of theta 2. The velocity component that lies on the string are same. The velocity component that lies on the string are same. Right? Why? Because the string is taut. v1 cos of theta 1, that is equal to v2 cos of theta 2, right? So v1 by v2, that is equal to cos of theta 2 by cos of theta 1. This is the equation of the general constraint, and this is the shortcut and Ramban for all of this kind of the question. Okay. Sir, be like Ashish Chanchalani. So this is the first method of the general constraint. Second, pulley shortcuts are going to come. Pulley shortcuts, it's a very simple thing, right? This is acceleration A, this is A1, this is A2, right? This is velocity V, this is V1, this is V2. These are the Pulley shortcuts constrained into the pulleys and the respective shortcuts. After that, we are going to discuss work done by detention. How we are going to solve? The two most important steps into it. The first is the sign conventions, right? And second, that is a formula, right? Sign conventions all about, see, the general equation is A1 plus A2 whole divided by 2. V is equal to V1 plus V2 whole divided by 2. This is a general equation, but for the sign conventions, as usual, what we are taking in the entire physics, we are going to take the same thing, upward as positive, downward as negative. Upward as positive, downward as negative. Yes or no, guys? Upward as positive and downward as negative, right? Just hold on, guys. Right. Okay, I'm going to message the moderator. Okay, please. Okay, I'm going to message the moderator. Block K Venkatesan and block another person, Addict Studios. Okay. Right? Is it cool? Okay. Pulleys are connected with respect to each other. Pulleys are connected with respect to each other. Pulleys are connected with respect to each other. Yes or no? Pulleys are connected with respect to each other. Okay, now here comes the another person. It's okay, please don't waste time, right? So now, apart from this pulley shortcuts, now here come the another method for a maximum constraint, that is work done by tension is 0. Right? Work done by tension is 0. Work done by tension, it is 0. Okay, how we are going to let's take an example to understand this. Okay, let's take an example, okay, to understand this. Okay, suppose this is having the acceleration A1 into downward direction and this is having the acceleration A2. Okay, what does this method states? Work done by tension is 0. The net work done by tension, right? Let's say here tension 2T is acting into the upward direction, here tension T is in upward direction. Suppose if we are considering this pulley as this block as 1 and this block as 2. For this block, tension is opposing the motion. For this block, tension is supporting. So for that reason, can I write it as, let's say here we are not taking the actual value of the tension, we are taking it as, right, T of 1, T of 2. So can I say negative of T1 of A1 plus here T2 of A2 is equal to 0. So T1 of A1 that is equal to T2 of A2. Let's follow this. Here it is displacement dx1, dx2. If this is getting displaced by dx2, right, this is getting displaced by dx1, right? See, we have the comment into the by the moderator. Okay, those who are continuously spamming and not letting others people to understand this concept will be immediately blocked from this channel. Okay, so please don't waste your data pack. Okay, please don't waste your data pack. So here it is T1 dx1 is equal to T2 dx2. Differentiating this equation, we are getting T1 v1, that is equal to T2. Again differentiating this equation, we are getting T1 a1, that is equal to T2 a2. This equation is maximum used in all of those kind of the Poulet constraint problems. Right, this equation has been used into the all kind of the Poulet constraint problems. Work done is about force and displacement. T is a force, X is a displacement. T is a force, X is a displacement. Right? Similarly, T1 D1, T2 D2. T1 D1, T2 D2. Differentiating this from displacement, we are reaching to the velocity. Again, differentiating this, we are reaching to the acceleration. Got it, everyone? Those who are live, thumbs up. So this is what the constraint is all about. The one thing that is remaining, that is a wedge constraint. Right, this is the concept of the advanced level. Right, in the concept of the wedge constraint, this is a ground. Right, these are the wedges. Okay, this is getting accelerated downwards with A1, this is getting accelerated downward with A2. Okay, sorry. This is theta. That is getting accelerated downward with A1 and this is getting accelerated downward with A2. So what is the right concept of the wedge constraint? The actual concept of the wedge constraint. So the actual concept of the wedge constraint states that, okay, relative of perpendicular component, relative of the perpendicular component of acceleration to incline to contact surfaces is 0. Why? See, this is a contact surface, this is A1, this is theta. A1 sine theta, A1 cos theta, right? Okay, this is A2, right? So this is A2 cos of theta. Relative A1 cos of theta, I'm sorry. This is A1 of X. See, we can say this is X and this is Y, right? I'm sorry. This is a relative of Y, okay, and this is A2 of Y. So here we are saying it as, let's not move on to that much approach. A1 of Y minus A2 of Y is equal to 0. Right? A1 of Y minus A2 of Y, that is equivalent to 0. Right? Relative of perpendicular component of the acceleration is 0. Why? Why this is a concept of the wedge constraint? Because the surfaces, whenever this wedge is sliding towards the left and upper wedge is sliding downwards, right? Right? So in that case, what is going to happen? They are not leaving the contact surfaces. They are not going to leave the contact surfaces. So for that reason, these perpendicular components are not going to contribute. So for that reason, they are equal. So this is all about the, okay, wedge constraint. This is in question, it is given, this is accelerating downwards with A1 and this is accelerating towards the left side with A2. So this all are the formulas. See, these are the shortcuts, right? This kind of the questions are asked. Okay. This is a very simple sum in which acceleration and tensions are calculated. Okay. A very simple sum in which accelerations and tensions are calculated. See, this is a concept of the wedge constraint. Okay, the relative component of the velocity and the accelerations. Okay. Newton's law of motions are only applicable for the inertial frame. To apply the Newton's law of motion into the non-inertial frame, pseudo force is needed. Okay. So for that reason, now we are going to discuss the concept of the pseudo force. After that, friction is going to come, and finally we are going to end this NLM. For the concept of pseudo force, we are going to discuss only one example. For the concept of pseudo force, right? For concept of pseudo force, right? We are going to discuss only one example. First, why pseudo force is needed to apply Newton's law of motion. To apply Newton's law of motion into the non-inertial frame. To apply Newton's law of motion into the non-inertial frame, right? Okay, the pseudo force is needed. Okay, now so for that reason, what is going to happen? Let's take an example. There is one observer, right, on ground. Okay, observer is on the ground. Lift that is accelerating into the upward direction. See, if the observer is on the ground, what happens? This is mg, this is tension T. One is mg that is acting into the downward direction, and second is a tension T that is acting. So according to the Newton's law, m of A that is equal to mg T minus mg. So here the equation of the tension is going to come upon mg plus ma. But if the observer position is getting changed, if observer is inside the lift, then this object appears stationary to it. If object is inside the lift, then object appears stationary to it. So for that reason, here T is equal to mg. Newton's law of motion should be applicable into the all reference frames. Here, when the frame was, observer was on the ground, frame was inertial frame. So as of that reason, we were getting the correct equation. So in the non-inertial frame also, the equation should be correct. But we are getting the incorrect equation. It means there is a presence of some fictitious force. As of that, all Newton's law of motions are applicable into the non-inertial frame. How they are applied? Apply acceleration of frame in reverse direction of block. What is the acceleration of frame? Upward. Apply into the reverse direction of the block. mg, ma, tension, observer inside the lift. See, by applying the pseudo force, we got the correct equation. So what is the formula of pseudo force? Mass of object, acceleration of frame. This is pseudo force is all about. One example. One example for friction. Thumbs up, guys. Like we understood the pseudo force into the one example friction. Come on, everyone. Those who are live, and we are going to end up this Newton's law of motion, and we are going to jump off. In work energy power, we are having only one equation and this application. Okay, an entire chapter is based on that. Okay, and after that, directly we'll move forward to the rotational motion. Come on, everyone. Those who are live. Thumbs up, come on. Do we need one example for the friction? Physics and chemistry both will be taught, right? थक गए क्या? जोश कम हो गया क्या? कम ऑन एवरीवन, थक गए क्या? जोश कम हो गया क्या? Okay, one example of the friction, right? From this one example, we are going to understand what limiting friction is, what static friction is, what kinetic friction is, everything. Yes, Tanisha, we got that part. Right. One simple example. See, here mass M is there. Here frictional force, external force F is acting. Here coefficient of static friction is given as 0.2. Coefficient of kinetic friction is given as 0.1. Mass of the object is 5 kg. How we are going to understand all of those concepts using this sum? Right, how all of those concepts are understood using this sum. Okay, we are going to plot the graph of, right, frictional force versus external force. We are going to plot the graph of frictional force versus the external force. Yes or no, guys? Frictional force versus, right, external force. So what is going to happen? Okay, what is going to happen? See here, first of all, limiting friction is mu s of n, that is 0.2 into phi of g, right? So that is equal to 10 Newton. The limiting value of the force, the system, the limiting friction of the force is 10 Newton. What does it means? If external force is applying value of force more than 10 Newton, then and then object is going to move. Sorry, object is going to get accelerated, not move. Object is going to get accelerated. Object is going to accelerate. Suppose, see, limiting the force is 10 Newton. Suppose F applied is 1 Newton. What happens? F applied is 1 Newton. Before the value of external force matches the limiting friction, the static friction acts. After that, kinetic friction acts. Before external force matches the limiting friction, static friction. After, kinetic friction. Yes or no, guys? So it's a very simple thing. Okay, it's a very simple thing. F is equal to 1 Newton. 1 Newton is less than limiting. Yes, it is going to move. No, interlocking is binding. Why? The static friction is having the characteristics. It will self-adjust according to the external force. Source is getting angry. External force is equal to 2 Newton. Static friction is adjusting itself to the 2 Newton. Object is not moving, interlocking is tight. External force 9 Newton. Static friction self-adjusted itself up to the 9 Newton. No, I'm not going to move. I'm not going to allow that block to move. External force 10 Newton. Interlocking is about to break. Why? External force matches the limiting friction. The static friction is having the capability to adjust itself maximum up to the value of the right, of the limiting friction. After that, it's not into the hand of the limiting friction. Now what will happen? Till this, static friction will try to self-adjust and will oppose the relative motion. See, what is the purpose of friction? Oppose the relative motion between the two contact surfaces. It's to oppose the relative motion between the two contact surfaces. Right? Okay, so now what is going to happen? Now if F value exceeds than 10 Newton, interlocking will break, jerk will be there. Jerk. This is a jerk. Okay. Now object starts moving and comes up the role of kinetic friction. So before, external forces matching the limiting friction, mu s value was acting. After that, when it starts moving, mu k value is acting. So this is a jerk. Jerk, it means interlocking is getting braked and the static is getting converted to the kinetic. After that, if I am applying the 1000 Newton also, right, the frictional force is going to be the constant. This is the graph. Is it clear, guys? And the most important purpose of the friction is to oppose the, see, generally students always used to get confused into the direction of the friction. Okay. Always they used to get confused into the direction of the friction. Okay. And that part. They consider friction is always acting right opposite to the external force. No. Friction is to stop the relative motion between two contact surfaces. Is it okay, guys? Come on, everyone, those who are live. See, this is a graph and everything. Okay. Now here comes the work, energy and power. The very simple things about the work, energy and power you all are aware of. Okay. Apart from this, into the Newton's law of motion, the small thing appears, right? A very small thing appears that, okay, very small thing appears, right, into the Newton's law of motion. Okay, like that on the banked road and the bank curve road, the 2 to 3 important formulas are there. Punjabiyan di battery charge rendi, okay. Did you found did you found any, what we can say, the energy with which we started the lecture, we are still continuing. It's 2.5 hours of this lecture. Yes or no? Okay. Did you found any, what we can say, energy loss in me? No. So can we move forward to the next chapter, work, energy and power? Yes or no? Can we move forward to the work, energy and power? Yes or no? Come on, guys, thumbs up into the comment box. Those who are live, I will be waiting for all of your comments beneath the video. Yes. Thumbs up, guys. Come on, yaar. Rocks. Basic work done formula you all are aware of. Work done can be positive, can be negative, can be zero, right? The simple formula of the work done, okay, and area under the fx graph is the work done. These small things you all are aware of, right? Okay, area under the fx graph, right? Area under the fx graph. Work done. Okay, lots of love you Sarji. Okay, lots of hearts, fires, sparks, everything I'm getting. Thank you, thanks a lot, guys. Okay, so you are getting now, you are enjoying physics now. Okay, now let's move forward. So these all are the basic things you all are aware of. We are more interested into the questions of the work, energy and power. Okay, we are more interested into the right what work energy theorem states. See, object here is M. Okay, what does the work energy theorem states? Okay, what does the work energy theorem states? Okay, the work energy theorem states that in this case, what is going to happen? Work done by all forces is equal to change in kinetic energy. Suppose here force F1 is acting, here suppose F2 is acting, here F3 is acting, right? Here F4 is acting. Okay, lots of n number of the forces are acting on the specific particle. N number of the forces are acting on the specific particle. So what does it states? It states that the work energy theorem states that work done by all forces is equivalent to that the work done, whatever the work is done by all forces, the resultant work done will change the kinetic energy of the particle. So here, work done by conservative force, work done by the non-conservative force, work done by external force will change the kinetic energy of the particle. Right? Okay. We are having only two equations of the work energy theorem. This is the first equation. Second equation, if non-conservative, okay, I'm sorry, I'm going to rewrite this first equation. Okay, I'm sorry, I'm going to rewrite this first equation. Okay, conservative force work done is stored into the form of the potential energy, right? So this is going to be delta K. So here work done by the non-conservative plus work done by the external, that is equal to delta K plus delta U. Okay, so this is the equation, the first equation of the work energy theorem. If external and non-conservative forces are absent, then mechanical energy is conserved. In that case, we have to use this equation. Initial kinetic, initial potential, final kinetic, final potentials. We are having only two equations of the work energy theorem. The general equations, right? And that we are going to use. Okay, all of the questions will be resolved using this case. How? See, there are some steps. All of the applications of the work energy theorem are having these steps. These are the Brahmastra. Check whether non-conservative forces are present, external forces are present or not. Example of the non-conservative forces are frictional force, path dependent force. Conservative forces are path independent forces. So there are only two possibilities. Check whether this or this. If this, directly apply, mechanical energy is conserved, right? Apply the equations of the total energy in between this is the initial point, right? And this one is the final point. And if it is not conserved, if mechanical energy is not conserved, then directly we can use this equation, the general equation, This is only the way you can apply the work energy theorem, and in all of those cases, this is the relation between the momentum and the kinetic energy. See, entire chapter is all about the work energy theorem and the collisions. Okay, this is a right. At some point the separate calculations of the potential energies are also there. Okay, this is a formula to define, to check it out whether the forces are conservative or not. Okay, so these are some chit-put things and a direct formula, okay, that you all are aware of at the very last moment. So we are just jumping it off. Okay, so this is a work energy theorem. Only two simple statements are there. Okay, two simple statements, and this is all about the power. Power is a rate of work done. Okay, and these are the formulas, respective formulas of the power. Power is the time of rate of work done. At what time rate work is getting done. Circular motion. Two type of the circular motion. Okay, cases. The first one is a uniform circular motion, right? The second one, that is the uniform circular motion and the non-uniform circular motion. Yes or no, guys? Uniform circular motion and the non-uniform circular motion. Okay. In uniform circular motion, we are having only one centripetal acceleration, that is v square by r, or that is omega square by r. In non-uniform acceleration or a non-uniform circular motion, we are having the two type of the acceleration. One that is in tangential acceleration, that is a centripetal. In this case, the net acceleration, you are going to tell it as centripetal square plus tangential square, right? So that will be, right, dv by dt whole square plus v square by r whole square. Okay. Yes, it is enough. Okay. These are some direct relation and direct formulas and relation between speed and velocity, tangential acceleration equation. Okay, these are the equations of the tangential acceleration. Okay, this is the equation of the radial or the centripetal. This is the equation of the net acceleration. Okay, these are some direct formulas of the, right. Sometimes the question based on radius of curvatures are asked. Sometimes the question based on the radius of curvature are asked, right? It's okay. This is what that was about to came into the 5th chapter, the banking of the road and the bank curve road. Okay, but here the formulas are included. Okay, now let's move on. Okay, this is a case of the motion into the vertical circle and the cases of the conical pendulum. But allow me to discuss the collisions. All of those collisions are based on the very simple formula. Are you interested in discussing the collision? Yes or no? Come on, everyone. Those who are live can have the answers into the comment box. Are you interested into discussing the right questions? Yes or no? Come on, everyone. Those who are live. Come on, everyone. Thumbs up into the comment box. Entire 1D collision. before, after. Entire 1D collision, before and after. Yes or no, guys? Okay. Yes or no, guys? Entire 1D collision is depending on the simple formulas, right? The formulas here, see, coefficient of restitution is always V2 minus V1 whole divided by U1 minus V2 is equal to velocity of separation by velocity of approach. Okay, velocity of separation by velocity of approach. Okay, so how we are going to, according to the conservation of momentum, M1 U1 M2 U2 is equal to M1 V1 plus M2 V2, because the external force on the system is 0, right? So momentum is conserved. So in this case, what is going to happen? M1 U1 M2 U2 M1 V1 M2 V2. Okay. So what happens here? Right, M1 U1 M2 U2 M1 V1 plus M2 V2. So what is going to happen now? Coefficient of restitution formula is this. Okay, so can we make on the subject? Okay, that is equal to V2 is equal to V1 plus E of U1 minus E of U2. Using the formula of coefficient of restitution, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V1 plus EU1 minus EU2. So it is M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V1 plus M2 E of U1 minus M2 E of U2. So from this, right, you are going to get it as U of 1 whole divided by M1 plus M2 plus U of 2 whole divided by M1 plus M2 is equal to velocity of an object after the collision, right? Velocity of an first object after the collision. Your M2 1 plus E M2 1 plus E U2 whole divided by M1 plus M2. Okay, and here you are going to get M1 M2. This is the velocity of a first object after the collision. The first formula, the second formula. Okay, this is going to help you all into the 1D collisions. Okay, all of the head-on collisions. Right, all of the head-on collisions. Right, I'm going to give you all the Brahmastra for the short trick, and this is only the short trick for all of those collisions, all of this head-on collision. Okay, replace the formula of U1, replace the formula of U2, value of U1, U2, coefficient of restitution and everything. This formula you have to remember. Okay, like this way even you can obtain the formula of V2. Okay, 2D collisions. All of those 2D collisions are based on the very single concept of common normal and common tangent. What is this common normal and common tangent? See, if you are analyzing the the questions of the 2D collisions, if you are analyzing the question of the previously were the oblique or the head-on or 1D collisions, right? These are the 2D collisions, right? Okay, let us take an example. If the object is coming on with the speed u and it is reflecting back with the speed v. So in the 2D collision, always consider the moment at which two particles are getting interacted. Here, the two particles are getting the interacted. Okay. Perpendicular component to this is common normal. This is common tangent. Another example, suppose particle is moving like this way, this particle is moving like this way, right? Select the moment at which they are going to collide. this will be common normal, this will be common tangent. This is how common normal and common tangent are decided, right? Another example of the 2D collision I gave you all. This is how the common tangent and common normals are decided. Now what is going to happen into the common normal and common tangent? It is a very simple thing. Okay, what is going to happen into the common normal and common tangent? It is a very simple thing. Okay. Conservation of momentum only applied to the velocity components that lie on common normal. Right, conservation of the momentum we are applying na, it can be only applied to the, say here we are having, let's say this is theta, so it is u cos of theta and this will be u sin of theta. Similarly this will be v of x, right, this will be v of y. The component that is along common tangent, no change into that. No change into the velocity component among the common tangent. Only the component along the velocity, right? Coefficient of restitution is also applied in 2D collision. It is only applied to the components that lie along the common normal. Conservation of linear momentum applied to the components of the velocity that lie along the common normal. Coefficient of restitution formula is applied, right, to the components that lies along the common normal. No change along the common tangent. 2D collision problems are always resolved. Okay, they can always be easily resolved by separating horizontal common tangent, vertical common normals. They can be solved separately. Then and then these sums are going to be quite easy. This is only the short trick. Is it cool? Is it cool, guys? So this is the case of the motion into the vertical circle that you all are aware of. How much minimum velocity is required at the bottom so that it can complete the vertical circle. Okay. If you are giving under root of 4gl, if you are giving under root of, okay, I think, yes. If you are going to give under root of 2gl, it is going to just reach the point B. If we are going to give under root of 2gl, it is just going to reach point B, right? If we are going to give under root of 3gl, it will cross the point B. B is here. If we are going to give under root of 4gl, in between B and C, if we are going to give under root of 5gl, right? Circle, complete circle. Apart from this, two equations are there. The first is the equation of the tension, that is equal to mu square by r. Equation of the velocity. Tension at any point, velocity at any point. This is the two formulas important through which the tension difference between the 2 points is calculated. Velocity at any point is calculated, and these are the conditions for the motion into the vertical circle. Yes or no, guys? Come on, everyone. Okay, if you have done collisions into the 2D into the different way, okay, then no one is right going to help you all. Come on, everyone. Those who are live, can I have the thumbs up? Okay, those who have joined this session now, right? Those who have joined this session now, right? Then you have missed more than 2 hours 35 minutes of this lecture. Okay, So why you are saying palle nahi pad raha na and all of that. Okay, those who are live, come on everyone, thumbs up into the comment box. Now we are moving forward to the most important chapter, that is center of mass. Right? The most important chapter. Come on everyone, fast. थक गए क्या? परेशान हो गए क्या? My energy is not less. Center of mass. Mass of the entire system gets concentrated at the single point. That imaginary point, it is known as the center of mass. One example for the center of mass. Mass of the entire system gets concentrated at the single point. Right? Mass of the entire system is getting concentrated at the single point. Mass of the entire system is shrinks at single point. Center of a mass can be calculated for three kind of the system. The first one is the system of discrete particles, right? The second one is for continuous bodies. Center of mass can be calculated for the discrete particles. Center of mass is calculated for the continuous bodies, right? And center of mass is calculated for the combined continuous bodies and bodies with cavities. For the discrete particles, continuous bodies, right? Continuous bodies and bodies with the cavities. For this three things, right, the center of mass is calculated. We are having the simple formula for the discrete particles forming the system, and we are having this formulas for, right, center of mass for the continuous bodies. Okay, now see, directly formulas are given for the square plate, right? For the square plate, it is center of mass lies at b by 2 and l by 2, half of the length, half of the breadth, right? This thing you all are aware of. Okay. Triangular plate, center of mass lies at h by 3. For semicircular ring, center of mass lies at 2r by pi. These are the direct formulas you have seen. Semicircular disc, 4r by 3 pi. Hemispherical shell, hollow hemisphere, r by 2. Solid hemisphere, center of mass lies at 3r by 8. Right, these are the direct formulas we are dealing till now. Yes or no, guys? Come on everyone. Sir, we haven't learned physics till now for that much amount of the time, and that's so even into the English mode. How things are going to get happen, sir? How things are going to get happen? You all are well, guys? Come on, let's move on to it. Okay, so this is all about the center of mass. Okay, for circular cone it lies, right, solid cone it is at h by 4. For the hollow cone it is at the h by 3. I told you all about the motion of the center of mass. It is very simple. See, this is a system. Suppose mass of the system is getting concentrated at the single point, and that imaginary point, it is known as center of mass. Now the question lies, how to locate the center of mass, right? We've got all of those equations. Now my question is whether the center of mass is moving or not. Whether the center of mass is moving or not. Whether this center of mass is moving or not. If it is moving, it is having some velocity. If it is accelerating, it is having some value. So if we are differentiating the formula of the center of mass, we are getting this stuff. If we are again differentiating the velocity of the center of mass, then we are getting the right formula of the acceleration. So this is what about the motion of the center of mass. It is fast, right? This is all about the motion of the center of mass. It is right. Yes or no? Come on, everyone. Okay, after center of mass, this is an impulse, right? Impulse, you all are aware of. Impulse and angular impulse. Impulse is nothing else but the change in momentum. Okay, impulse is nothing else but the change in momentum. It is given into this question. The gravitational force and spring forces are non-impulsive, and impulsive force can only be balanced by another impulsive force. It's okay, this is a very simple thing. Okay, directly we are moving forward to the next, right? The coefficient of the restitution, it's okay. I think some of the lines are misprint. Okay, these are the types of the collision, and for this, right, the coefficient of restitution values are there. It will be mentioned into the PDF. Okay, now directly we are moving forward to the rigid body dynamics. Moment of inertia. Why no one is commenting? Come on, everyone, those who are live, can I have the answers into the comment box, please? Right? Can I have the answers into the comment box? Come on, everyone. Okay, रसोड़े में कौन था? Physics था. Okay, so guys, moment of inertia. What is moment of inertia? Moment of inertia is taklif. As like taklif into the the inertia into the, as we have seen that inertia into the Newton's law of motion. Okay, we are having the moment of inertia, okay, into the rotational motion. Translational motion, inertia. Rotational motion, moment of inertia. How we are going to compare that stuff? See, very simple thing. I am going to compare the inertia and moment of inertia to explain that part. I am going to compare the inertia and the moment of inertia to explain that part. Right? I am going to compare the moment of inertia and inertia to explain that part. Inertia. Object was at rest. He wants to be at rest, but suddenly external force is acting on it. So as because of it, he has to state his motion, change his state of the motion. So as of that reason, he was facing the taklif into the internal property of matter. Inertia always opposes the change of state. Similarly, object was at rest, right, with the initial angular velocity as 0. Suddenly, the external torque is acting on the system. So as because of it, right, it forcefully has to change its motion. The same inertia was in translatory motion, the same that happens into the rotational is moment of inertia. Okay, so the formula of moment of inertia is mk square, right, where k is the radius of gyration. K is radius of gyration, where it is defined as under root of r1 square, r2 square, rn square whole divided by n. This is generally for the rigid bodies. Okay, that this is generally for the rigid bodies. If in system more than one particle is present, then resultant moment of inertia is explained by this formula. For n number of the particles, we are having the n number of the moment of inertias. This is a basic explanation of inertia. This is the formula of inertia. This is the formula of inertia for containing the n number of the discrete particles or the continuous bodies. See, it is given. Moment of inertia for the single particle, for many particles, right? For continuous body. It is written, see, that thing we have discussed. For the larger object, it's okay. Now we are having the two formulas, two important theorems into the right. Okay, I'm going to give you all the simple explanation for the perpendicular and the parallel axis theorem. Right, not more than that. Okay, the simple explanation of the parallel. See, whenever two axes of rotation are there, the first one is known axis of rotation. Known axis of rotation means the axis of rotation about which we need to calculate the moment of inertia. Desired axis of rotation. The axis of rotation about which the moment of inertia needs to be calculated. If known axis of rotation about which moment of inertia is known, the formula, the value is known to you all. Desired axis of rotation about which, right, the moment of inertia needed to be explained, need to be find out. If known axis of rotation and desired axis of rotations are perpendicular, apply perpendicular axis theorem. If known axis of rotation and desired axis of rotation are parallel, right, apply the parallel axis theorem. A very simple explanation. And perpendicular axis theorem is the limitation that is only applicable for the 2D objects. Is it clear, guys? Come on, everyone, those who are live. Is it clear, guys? Come on, everyone, those who are live. So these are all of the formulas of the moment of inertia. For the solid sphere, it is uniform, that is uniform, it means with the uniform mass distribution, uniform mass contained into the volume. Right, it's 2 by 5 mr square. For the hollow sphere is 2 by 3. Right, this is not for hollow sphere, this is wrong written. Right, this is mr square for the ring. Okay, disc, all of those formulas are mentioned. Hollow cylinder, right, this was of the previous page. Right, for rod it is ml square by 3, from in between ml square by 12. For the square plate, right, for all of those the respective formulas are mentioned. Okay, this was all of the previous cases, right? Don't get worried. Okay, this is the radius of the gyration, and here comes up the torque. Torque is nothing else but rotational analog of the force. Torque is nothing else but the rotational, right, analog of the force. Clear? Right. For translatory motion, the role that force plays, the same torque plays into the rotational motion. It is nothing else but the cross product of R and F. It is nothing else but the cross product of R and F. Yes or no, guys? Right? Okay. Apart from this, there are the two equilibrium conditions. Right? Okay. There are the two equilibrium conditions, not net torque. Another formula of the torque is moment of inertia into alpha. Right? Okay. There are the two important things. Okay, these are the rotational and it's not thing we are. These are the two important things that are used into the conditions of the torque. Okay. If for the translational equilibrium, the net acceleration along the x direction is 0, it means that net force along the x direction is 0. This thing we have seen into the NLM. The net acceleration right along the summation of net forces. Y is 0. The summation of all of those net forces along the y is 0. These are the conditions for the translational equilibrium. But what about the rotational equilibrium? How you can define the torque? I'm going to give you all an example of it. Suppose angular acceleration of the center of mass is 0. Then I can say the torque that is about the center of mass is 0. If acceleration of the center of mass is not equivalent to 0, then the net torque is equivalent to I alpha of center of mass. The entire, all of those torque based question you have seen, right? All of those torque based question you have seen are from these two formulas only. Mark my words, highlight it. If you want to have a screenshot, whatever you want to do, you can do that part. Come on everyone, those who are live. Angular momentum, rotational analog of the momentum. Torque is a rotational analog of the force. Like that way, angular momentum is a rotational analog. Two type of angular momentums are there, right? Angular momentum for the translational motion, right? Angular momentum for the rotational motion. Angular momentum for the translatory motion, right? Angular momentum for the rotational motion. Okay. And the third one is the direction of the angular momentum. Okay. Direction of angular momentum is always R cross P, the cross product of the cross product. Suppose this is R, this is P, right? Keep the hands right on R, curl it to P. Direction of thumb will show the angular momentum. Suppose this is R and this is P. Keep the hand on R, P. Direction of thumb will show the direction of the angular momentum. Conservation of angular, there is a relation between the torque and the angular momentum, that is torque is equal to dl by dt and that is equivalent to 0. Torque that is equal to dl by dt and that is equivalent to 0. So what happens here, it is a very simple thing. If net torque on system is 0, angular momentum is conserved. Same way like we have seen the conservation of linear momentum, right? The net force on the system was 0, momentum was conserved. Here net force on the system, the net torque on the system is 0, the momentum is conserved. Angular momentum is conserved. Is it clear guys? Come on everyone, those who are live. Okay. Before that, there are some rolling conditions, pure rolling, forward slipping, backward slipping. Okay, there is a bit of lag, but I think it's okay. Come on everyone, those who are live. It happens. It happens. Someone is saying lag is there. I think we should just hold on guys. I think now from there will be no lag. Less lag is there. See, now 3 hours are there, right? Since 3 hours, I think we have, okay. Now it's okay. Come on, everyone, those who are live. Now things are getting okay. I think 3 hours approximately to the sessions and went on, right? So for that reason, happens na yaar, technical specifications are there. Okay. Now it's okay. Now it's okay. Come on, everyone, those who are live. Now it's okay. Thumbs up. Thumbs up, guys. Come on, everyone, those who are live. Thumbs up into the comment box. Now we have reached up to the gravitation, and within next half an hour, right, we're going to complete the 11th. 12th is quite easy. It takes time to complete the 11th, and 12th is quite easy, right? Is it clear, guys? Come on, everyone, those who are live. Thumbs up into the comment box. Right? Is it clear? Those who are live, come on. Now, gravitation. Entire gravitation here you all know. This is a Newton's law of gravitation. What does it states? Right? Two masses separated by the distance r. The force, right, that is directly proportional to the product of the masses and inversely proportional to the square of distance between them. This is a scalar form. This is a vector form. Right? One is a scalar form. Second is a vector form. In that, superposition principle is there. Superposition principle into the scalar form for more than one particles, right? If you want to calculate the resultant force on one particle as because of many, superposition principle is there. Yes or no, guys? Come on, everyone, those who are live. Are you all live? Right. Now there are some right formulas after the gravitation. See, in entire gravitation, work energy theorem, gravitational potential energy, right, force. That's it. These things are, and Kepler's law. These four things, right, are quite important in the entire gravitation. And gravitation, solids, fluids are quite easy, guys. Gravitation, solids, fluids are quite easy. Yes or no? Gravitational potential, right? Direct formula V is equal to C. What is the difference? I'm going to give you all one example to right, to explain you the concept of the gravitational potential and gravitational potential energy. See, Earth, talking about the infinite point, Earth, and I'm talking about the infinite point. Yes or no, guys? Earth, and I'm talking about the infinite point. See, it's a very simple thing. Using external agent, I want to bring the point from infinite position, right? Using the external agent, I'm going to bring the point from the infinite point, right, to the point under the gravitational field of the Earth. The amount of the energy need to bring the point, right, from the infinite position to the point under the gravitational field such that velocity of the particle is constant. This is known as the potential energy of the system. The potential energy needed. Potential energy needed. Yes or no, guys? Come on, everyone, those who are live. Okay. Like this way, potential energy per unit mass is potential energy required to bring the object from. Some students might be thinking in NCERT the definition is same. Some students might be thinking in NCERT the definition is same. But the same thing I want to convey, there is a difference. If the energy that is needed to bring up the charge, bring up the mass from infinite position to the point under the gravitational field, right, then we can say yes, things are okay. It is a potential energy. At infinite position, only single particle is there? No, n number of the particles are there. So how much energy is needed per unit mass? That is the gravitational potential. So like this way, this is gravitational potential defined for the single mass, right? For the ring, we are having the formula, right? For ring, we are having the formulas and everything. Okay, these are the formulas direct. Okay, for the circular disc we are having the formula, right? For sphere, potential, right, gravitational potential for the circular disc, gravitational potential for the sphere, right? All of those formulas are given into the PDF. We can just judge it out. For the spherical shell, okay, so this was force and the gravitational potential. Now you all are aware of gravitational acceleration changes as because of the height, depth, and from pole to equator. Yes, similar to the electric potential energy. So for that reason, we are not wasting that much amount of the time. Right? So variation of the acceleration due to the gravity. Variation of the acceleration due to the gravity. At the height, at the depth. Okay? At the height, at the depth, as because of the surface of the earth. Right? As because of the surface of the earth. Right? And this is what the orbital velocity of the satellite, okay, that obtained through the work energy theorem, that you are all aware of, 7.92 kilometer per second. Okay, this is total energy of the satellite. This is the kinetic energy of the orbiting satellite, potential energy of the orbiting satellite, time period of the orbiting satellite. It all comes into the Kepler's law. 3 Kepler's law are there. First one, Kepler's first law, second law, third law. First one, law of, the third is the law of period, second is the law of areas. What is the first law? Right? Law of orbits. All of the planets, right, or you can say the earth is revolving around the sun, not into the circular orbit but the elliptical orbit, and sun is at the one of the foci points. Sun is at the one of the foci points. This is the first law. Second law states equal area swept in equal time intervals. Equal area swept in equal time intervals, right? Equal area swept in equal time interval. Third, right, Kepler's third law, T square is directly proportional to R cube. This is all the gravitation is all about, right? This is all the gravitation is all about. Yes or no, guys? Come on, everyone, those who are live. Come on, everyone, those who are live, can have the thumbs up into the comment box. Now we are moving forward to the solids and fluids, right? Okay, directly we are moving forward to the solids and fluids, right? Come on, everyone, those who are live, can have the answers into the comment box, please. Thumbs up, thumbs up. Come on, guys, everyone, thumbs up. Fast. Right, now solids, fluids, SHM, waves, right, rapidly we are going to discuss, and then we are moving to 12th. Is it okay, guys? Come on. Love you, Sirji. Thanks, bacha. Thanks a lot. Right. Thanks a lot. Okay. Fluid mechanics is everything about the surface tension equation. 3 important things are there. Bernoulli's equation, surface tension, right? Law of flotation. Okay. Fluidic pressure, Pascal's law. Pascal's law, law of flotation. Equation of continuity, Bernoulli's equation, surface tension. These 5 are the important thing. Apart from this small chitput things are there, like the acceleration of the moving fluidic containers, the rotation of the moving fluidic containers, how torque is acting, what is the formula of torque, right? What is the formula of torque, like this way. Okay, So we are not going to waste time on that. Simple definition of the pressure, that is force per unit area. There is a difference between the pressure and the stress. For the accelerated container, if the container is accelerated into the upward direction, then pressure is given by this formula, right? If it is accelerating horizontally, then the acceleration is given by this formula. Okay. If it is getting rotated, okay, then it is given by this formula. Equation of continuity, I am going to separate it, explain into the separate part. Are you all ready? Come on everyone, those who are live. Equation of continuity. Right? Equation of continuity, I am going to explain you all into the very simple part. Right? It is based on conservation of mass. Right? It is based on the conservation of mass. Yes or no, guys? Come on everyone, those who are live. Right? What does this conservation of mass states? What does this conservation of mass states? Right? The conservation of mass states that the amount of the fluid that is entering into the one side, the same amount of the fluid that is leaving another side. Mass of the fluid is the amount of the fluid that is flowing, right, is constant amount. So in that case, rho AV is equal to constant. Now density of the fluid is same on the both sides. So as of that reason, the equation of continuity states the AV is equal to constant. A is inversely proportional to V. A is inversely proportional to V. This is the equation of continuity. AV is equal to constant, that is equal to A1 V1 and that is equal to A2 V2. AV, that is equal to constant and that is equal to A1 V1 plus A2 V2. Yes or no? Come on guys, everyone, those who are live. Right? Okay, so this is the equation of the continuity. Now, okay, equation with the equation of the continuity, the most important stuff that is going to come upon is the Bernoulli's theorem. Bernoulli's theorem is nothing else but the conservation of energy, guys. Right? One of the application of energy conservation, right? One of the applications of the energy conservation. The Bernoulli's equation is nothing but the one of the applications of the energy conservation. Yes or no, guys? Come on everyone, those who are live. Right? One of the applications of the energy conservation. Okay, what does it states? Okay, work, see, I'm going to separately prove work done by all forces, that is equal to change in kinetic. Work done by non-conservative, work done by external, that is change in kinetic plus change in potential. Using this equation, I'm going to obtain the Bernoulli's, right, the equation of the Bernoulli's principle. This is a reference point that I'm going to say it is a ground. This is an initial point. This is a final point. In between initial and final point, I'm going to apply the Bernoulli's equation. Non-conservative forces are not there, only external forces there, right? That is equal to P2 minus P1 into V. Change in kind, here the V speed is V1, here the speed is V2. So the change in kinetic energy, V2 square minus V1 square. Right? Plus, there is the difference of the potential energy of the fluid, mgh2 minus h1. Can I replace mass as density into volume? All of the volume will get cancelled, and finally we will reach to the Bernoulli's equation. Right? We are reaching up to the Bernoulli's equation. Okay, this is a proof. See, this is one of the applications of the energy conservation is helpful in rotational dynamics, into the gravitation, into the solids, into the fluids, into the SHM, into the waves, into the electrostatics, into the capacitors, into the magnetism. Everywhere energy conservation is there. Everywhere, right? Energy conservation is there. Come on, everyone, those who are live. Okay, so this is how the Bernoulli's principle is applied, right? And according to that, the equations are given. Okay, this is a 9th chapter, the elasticity and viscosity and everything. Okay, the Young's modulus, right? 9th chapter is quite easy. Okay, 9th chapter is quite easy. Now, in the entire fluids, there are something remaining that we need to discuss, right? Before surface tension, we need to discuss the law of flotation, okay, and Archimedes principle. Okay, Archimedes principle and the law of flotation. Archimedes principle and the law of flotation, right? Now, what does this Archimedes principle states? It states that the amount of the fluid that is added into the system, the amount of the the mass that enters the fluid, the same amount of the fluid is getting displaced. Mass that enters the fluid, same amount of fluid gets displaced. Same amount of the fluid is getting displaced. Yes or no? Come on, everyone, those who are live. Right? The same amount of the fluid is getting displaced. Right? Students, come on, everyone, those who are live, can I have the thumbs up into the comment box, please? Right? Can I have the thumbs up into the comment box? Those who have attended now, please don't spam. Right? Please don't spam. Come on, everyone. Okay, so this is now Archimedes principle. With Archimedes principle, we are having law of flotation. The law of flotation states that if, see, this is mg, right, and here into the upward direction the buoyant force is acting. If mg is less than buoyant force, object is going to be above the surface. If mg is equivalent to buoyant force, object is going to be float at any depth. If mg is going to greater than fb, object is going to sink. Right? So this is what the Archimedes principle and the law of flotation is all about. Now only right, the surface tension is there. Surface tension is force. Surface tension means what? Suppose I'm going to give you all an example of it. Okay, I'm going to give you all the example of it. What happens here? Surface tension. Suppose I'm keeping this entire cloth as a wet. Right, entire cloth is wet. Entire cloth. I'm going to stretch this. So what happens? The fluid tries to adjust itself into the minimum surface area. The fluid tries, right, itself to adjust into the minimum surface area, right? And it acts like, while acquiring the minimum surface area, fluid acts like the elastic stretched membrane. Elastic stretched membrane. So as of that reason, okay, elastic stretch membrane, as of that reason, what happens here, right, the property of the surface, it acts like an stretch elastic membrane. So as of that reason, right, the property of the, right, surface tension acts. Okay, so it is defined as force per unit length, right? Yes or no? Okay, for a soap bubble, see, on the basis of this soap bubble in NEET 2022, one question was asked. You can check into the paper, right? On the basis of this soap bubble, whenever the soap bubble expands, what is pressure inside? Thousands of times this question has been discussed, right? Okay, thousands of times this question has been discussed. Okay, so this is all about the surface tension. Now, before moving on to the thermodynamics, can we have, right, the break of, let's say, can we have the 10-minute break, please? Can we have 10 minutes break, please? Otherwise, students are going to write, okay, sir, 3 and 5, half hour, and you are not going to give. Okay, now it's 11:18. Again, we are going to come back at 11:30. 11:30, we are going to come back. Now it's 11:18 and 11:30, we are going to come back. Yes or no, guys? Come on, everyone. Thumbs up into the comment box. Right, thumbs up into the comment box. Right. If your object is moving with the constant velocity, then acceleration is 0. Okay, it is said to be the uniform motion. Okay, now we are going to again come back at the 11:30. Come on. Hello. Hi everyone, those who are live. So I think we are back. Still 2 minutes are remaining. Till then we can have a review of all of your session. Hi everyone. Can I have the thumbs up into the comment box, please? Can we have the thumbs up into the comment box, please? Okay, now see this last moment revision is divided. Okay, then I'm going to deliver. Still 2 minutes are there. Okay, and we are going to wait and then we are going to deliver. Okay, I'm going to roam here and there for 2 minutes. Someone is saying, sir, आप बहुत cute दिखते हो. Thank you, बच्चा जी. Thanks a lot. Right. Thanks a lot for this, भाई. Sir, चक दे फट्टे. Okay, sir, very bad teaching. Thank you. दुनिया जल्दी है, PWD चल्दी है. Here we took approximately for completing entire 12th, we took approximately 4 hours. Right, all of the important formulas with all of those shortcuts are discussed, guys. Right. Okay, so okay, nothing is getting in my brain. If nothing is getting in your brain, okay, go in temple, stand in front of God. Hey Bhagwan, मेरा कुछ नहीं हुआ, अब तू कुछ कर. This is only the last way for you all who are not getting anything. Okay, this is only the last way, right? Okay. This is only the last way for the all. Nothing is getting in my brain. So guys, can we resume? Can we resume? Yes or no? Right. Hello sir, how are you? I'm fine. Come on everyone, those who are live. Heat thermodynamics. This is a very simple, right, that we are now directly we are moving forward to the thermal energies, and in within next hour and half an hour and 45 minutes we are going to complete this session. Right, you are really great and thank you for this amazing session. See, the most important thing that I want to discuss with you all, okay, I think it will be injustice to complete the entire 12th by today. The moment we started the lecture into the morning, the same energy we are having right now, the same amount of the energy we are having right now, yes or no? Okay, the same amount of the energy we are having right now. Yes or no, guys? Come on, everyone, those who are live. Okay, so in this case, I want to tell you all, right? In this case, I want to tell you all, right? That. Boom. This last minute revision is divided into 2 to 3 multiple parts. The first part of the physics we completed by today. The first part of the physics we completed by today. The next part of the physics, the 11th we completed by today. The next part we are going to complete by tomorrow. Same time, 8 a.m. morning. You are going to come or not? Guys, thumbs up into the comment box. Tomorrow, yes or no? Today, right, the entire physics we have covered. Now Sagar sir will take the chemistry part, after Kamal sir will come upon, and tomorrow again we are going to come back with the 12th part of the physics into the separate manner, and we will take again 2 to 3 hours more than that to explain that entire part, and after that again the chemistry part, and on the last day or by tomorrow Max will come. You all are demanding the Max, right? It will come, don't get worried. Okay, all of the notes of the specific session, right, you will get on the PW app, and the link of the notes on the PW app, right, it is beneath the video into the description. So shall we begin? Yes or no? Come on, guys. Heat and thermodynamics. Before moving on to the heat and thermodynamics, I want to tell you all we are directly going to deal with right? Before moving on to the heat and thermodynamics, bhangda kar do sir. Harsha ma'am is going to come. Don't get worried. After the completion of the 11th physics, Sagar sir will come and he will give you all the explanation. Tomorrow for 12th physics into the morning 8 a.m. you are going to come or not? You are going to tell your peoples or not? Thumbs up into the comment box. Come on everyone, fast. Now Harsha ma'am is not going to explain you all physics, right? Now Harsha ma'am is not going to explain you all physics, please. Harsha ma'am is not going to explain you all into the physics, please, right? Physics, me or any some of the Kshitij sir, Sams or Akash sir, they are only going to explain. Okay, we want Harsha. How Harsha ma'am is going to explain, right? Explain the physics. Okay, see, heat and thermodynamics. Now we are completely going to deal with the heat, right? Specific heat capacity, latent heat, the state transformation, solid, liquid, gas, expansions of the solids, right? The black bodies, the Kirchhoff laws, the Stephen's laws, the Wayne's displacement law, all of those new things are going to come upon here. Jo bole so nihal. Okay, Sat Sri Akal. So this is the heat and thermodynamics, Carnot engine, all of those 3-4 types of processes, isobaric process, isochoric process, isothermal process, all of those processes, everything we are going to discuss it. Okay, everything we are going to discuss, yes or no? Come on everyone, those who are live. Okay, one day what we are going to do, we are going to keep the midnight session right now, starting it from midnight 12 a.m. and we are going to complete at the morning 6. What say? Right, overpowered lecture. See, still energy of Indrajit sir is what extending, right, is the same as with what we have begun the lecture. Yes or no? Yes. Okay, let's focus here. Okay, so now let's move on to the new topic of the heat, and again we are going to come back here, but before that let's move on to the right. I think this the thermodynamics has been capped. Okay, heat engines are capped. Thermal efficiency of the okay. Here comes the thermal physics starts with, guys, thermal physics starts with the concept of, I'm going to discuss that part. The thermal physics starts right with the concept of, okay, sir, you are the best. Okay, thank you guys, thanks. No, it's not like sir bus or something. Your efficiencies, someone is saying your efficiency is like the Carnot engine. It's not like that, right? If say Jaisi Raja Vaisi Praja, the energy, the efficiency with which teacher is teaching, okay, with the same efficiency students are willing to understand, they can sit for the long hours. Okay, if I am starting with the energy and after 1 hour, hello bachcho samajh mein aaya, do you understand, like that way. So at the end of the time the student is also going to think bhagao is teacher ko, bhagao, like that way, right? Okay, so the thermal physics is going to start with the temperature scales and the faulty thermometers, right? For all of those temperature scales and the faulty thermometers, we are having a single concept, right? Reading of the thermometer minus lowermost point, uppermost point minus lowermost point is constant in all temperature scales. Right, it is constant into the all temperature scales. Yes or no? Right, it is constant into the all temperature scale. This is an important formula. It is even used into the case of the faulty thermometers and everywhere. right? It is used into the case of the faulty thermometers and everywhere. After this, some of the basic definition into the thermal physics are going to come, right? Like what is heat supply, right? What is specific heat, Cp, specific heat, Cv, relation between Cp minus Cv, that is equal to R. Before that, ideal gas equation is going to come, including the state variables. PV is equal to nRT, right? Again, the things are going to come for monoatomic gas, diatomic gas, triatomic gas, for the linear and non-linear variables, Cp, Cv value for all of this. And after that, it is going to come the degrees of freedom. After that, it is going to come upon as degrees of freedom, right? Now, after this, here comes the expansions of the solid. Suppose if heat is applied, right? Suppose this is a rod of length L and continuously the heat is supplied to it. This is a rod of length L and continuously the heat is supplied to it, right? Then what is going to happen if continuously the heat is supplied to it? Okay, then what is going to happen, right? Okay, so in this case, what is going to happen, I'm going to tell you all, right? It is going to expand. So this expansion into the length is defined as the change in length by original length is directly proportional to change in temperature. Change in length by original length is directly proportional to the change in temperature. And here, removing the proportionality sign, the one proportionality constant it is coming out, that is alpha. Okay, that is coefficient of linear expansion. Second, if square plate is continuously given the heat, then it expands, right? Length also changes, breadth also changes. So that results into the change into the area. So here comes the concept of the coefficient of area expansion with this formula, where beta is coefficient of areal expansion. Similarly, for coefficient, the volume expansion of the solids with the respective formula, and gamma is the coefficient of the volume expansion. The relation is mentioned. Right? Okay. So this is what about the thermal expansions of the solids. After this, this is the formula of the energy stored per unit volume. Why it is kept here? Because it is compared, right? Now, the most important thing that is going to come upon as principle of calorimetry. What does it states? All of those questions from the principle of the calorimetry are going to come, right? This topic holds the highest importance and is having the highest possibility to come up into an examination. What does this principle of calorimetry states? Right? Simple. Heat loss by one is equal to heat gain by another. Heat loss by one, that is equivalent to heat gain by another. All of those sums you have heard of. What? Ice mixed with water, right? Water mixed with water at the different temperatures, right? Okay, and after that, ice mixed with steam, water mixed with steam. All of these sums, right? All of these sums, right, are based on only one principle. In some of these sums, even the calorimeter is also introduced, right? All of those sums are only based on this thing. What? Principle of calorimetry. Yes or no? On the principle of calorimetry. Heat loss by one, that is equal to heat gain by another. Heat loss by one, that is equivalent to heat gain by another. Yes or no? Come on everyone, those who are live, answer into the comment box beneath the video, please, fast. Now here it starts the conduction. The modes of heat transfers are there. I am going to give you all a simple example of the modes of heat transfer. I'm going to give you all the simple example of the modes of the heat transfer. Three modes are there: conduction, convection, radiation. I'm going to give you all one example, right? With that you are easily able to understand all of those three stuff. Only single example. What? There are group of 8 friends. We are having limited amount of the time. Let's say there are group of 5 friends. One wants to transfer the information to 5th person. One wants to transfer the information to the 5th person. There are 3 ways. First way is one will transfer to second, second to third, third to fourth, fourth to fifth. This is conduction. Whenever the heat transfer takes place from 1 to 5, whatever the mediums they are present in between, all will get heat. First way. Second way, convection. One is going to pick 3 and it is going to transfer the information or heat to the 5. Oven. Surrounding in only one intervening medium is heated and that transfers the heat energy to the from source to destination. What is the third mode of the heat transfer? One direct transfers the information to 5th. So this is what conduction, right? Convection and the radiation. Conduction, convection and the radiation. Right? Now, this is all about when 2 rods are connected in series. Suppose if 2 rods are connected in series, here comes the concept of thermal resistance. Like electrical resistance, we are having the thermal resistance. Electrical resistance opposes the current flow, thermal resistance opposes the heat flow. Suppose here if 2 of the rods they are connected, one is having the thermal conductivity K, second is having the thermal conductivity K2. What is the formula of thermal resistance? L by K of A. K is a thermal conductivity. So whenever they are connected in series, we are having this formula. Whenever they are connected in parallel, we are having this formula. Generally from this, see, this is a formula of thermal resistance. This is the thermal conduction. The thermal conduction, it means in another sense the rate of heat flow. Okay, the rate of the heat flow. The rate of the heat flow. Yes or no? Okay, practical example of the conduction and convection. Okay, practical example of the conduction. If the what we can say, the vessel with the water is kept, okay, on the gas, okay, and it is getting heated. Suppose if another vessel touches that previous one, then that vessel is also going to get heated. If suppose I am going to touch all of those intervening mediums, those who are going to touch that vessel, it is going to get heated. That is conduction. Convection, only one, right? Microwave oven, only the inside surrounding medium is getting heated and that will transfer direct energy to the destination. This is the best example of the convection and conduction. Okay. Okay. Now this is convection is not even least included into our syllabus, right? The conduction and the radiation previous was the part of the conduction. This is the part of the radiation. Radiation, there are some definition. Emissive power, energy incident per unit area per unit time. Not incident, energy per, because there is a incident, there is a radiated, lots of concepts are there. So right now I'm just saying emissive power, energy per unit area per unit time. Spectral emissive power. What is the difference between emissive and a spectral? Spectral emissive power is for the specific wavelength of the emitted heat. Emissive power is generally defined. And emissivity, this all are the simple definition, right? Okay, this all are defined for the black body or the general body. See, let's take an example. This is a black body. Okay, having the surface temperature of the T. Okay, T is the surface temperature. Yes or no, guys? Okay, T is nothing else the surface temperature. Now it is having the capability to radiate the energy. So what does this Stephen's law state? The energy radiated per unit area per unit time is directly proportional to the fourth power of the temperature. So E, that is equal to sigma into AT to the power 4. This is for black body. Generalized form of this equation, E is equal to sigma emissivity T to the power 4. This is a generalized Stephen form. Stephen's law. Stephen's-Boltzmann law. They are talking about the body that is having the capability to radiate the energy, heat. Now what does this Wein's displacement law say? It states that the body that is having the capacity to emit the radiations, right, its surface temperature is T. So whatever amount of the lambda radiations they are getting emitted, it is inversely proportional to temperature. It is inversely proportional. This is a Wein's displacement law. This is a Stephen's law. And Kirchhoff law states that the ratio of E by E of all bodies are equivalent to the black body. This is very least asked, but it's okay. Maximum questions based on the Wein's displacement law and the Newton's law of cooling are asked. Newton's law of cooling states that any heat object, right? Okay. Suppose if this object is heated and it is at the higher temperature as compared to the surrounding, obviously it is going to cool down. Why? If it is at the higher temperature, it is going to radiate some heat. It is going to radiate some heat. Obviously, after radiating, after emitting, okay, temperature of it is going to get decreased. And if temperature is going to get decreased, it means it is going to get cooled down. After this, there comes upon, see, these are the type of the thermometers. Okay, here comes upon the concept of the thermodynamics, right? Thermodynamics. What does it state? Basically, thermodynamics starts from 4 types of processes. Thermodynamics starts from 4 types of processes, right? Okay. The first one, that is iso. See, 4 types of processes are there. First one is isobaric process, right? Second one is isochoric process. Third one is isothermal process. And the fourth one is adiabatic process. Isobaric process, pressure is constant. Isobaric process, volume is constant. Isothermal process, temperature is constant. And adiabatic process, net heat flow is 0. Questions on this adiabatic process are coming up into an examination. Why adiabatic process is having net heat flow is 0? Because the adiabatic process is so rapid. Adiabatic process is so rapid that system does not get much amount of the time to exchange its heats with the surrounding. Similarly, this is the formula for the work done. This kind of the derivation you have seen. For isochoric process, work done is 0. Right? For isobaric process, adiabatic process, everything we have seen. Right? Everything we have seen. Okay. Now what is going isobaric process? See, this thing I told you all now, for monoatomic gas, Cp, Cv, for di, for tri, right? Specific heat capacity. This is the formula of the specific heat capacity. This is work done for the isobaric process, and this is the first law. First law of thermodynamics states whatever the heat is supplied, that will resultant a change in internal energy plus net amount of the work is done. So thermodynamics is all about the 4 simple processes. Thermodynamics is all about the 4 simple processes. Right? This is a general formula to find the gamma, and this is a work done for the May, right? Apart from this, only Carnot cycle and heat pump and heat engine are remaining, right? Okay, heat engine. What does this heat engine states? It's a very simple heat pump and heat engine. This is source, this is sink. Source is at the high temperature, right? Sink is at the low temperature. As because of the temperature difference, right, heat is getting flowed and we are getting the work done. So efficiency is equal to output by input. So that is work done by heat supplied. So from this you are going to get the equation of the efficiency, right? Heat engine, heat pump is completely based on the second law of thermodynamics. Second law of thermodynamics is having two statements, Kelvin-Planck statement and Clausius. Kelvin-Planck states that, right, it is impossible to construct an cycle, right, construct an engine operating in cycle which will produce no effect extracting heat. Kelvin state that it is impossible to construct a cycle that can complete heat transfer. Transfer is heat from source to sink. The Clausius statement states that efficiency of an engine can't be 100%. We can't construct an engine having the efficiency as 100%. Right? This is a Clausius statement, and after that, okay, entropy is not there. The efficiency of the Carnot engine, right, and this respective graphs are given. See, this is what the entire Carnot cycle is all about. Okay, this is the first state is of isothermal expansion, right? First state is of the isothermal expansion. Second is an adiabatic expansion. Okay, second one, it is an adiabatic compression, or isothermal compression, right, and adiabatic compression. Okay, thermal efficiency of the Carnot engine formula is defined. 4 stages are defined. Suppose if you want to design the first stage, P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Adiabatic, isothermal expansion. Second one, P2 V2 raised to gamma is equal to P3 V3 raised to gamma. Third, P3 V3 is equal to P4 V4. Fourth process, P4 V4 raised to gamma is equal to P1 V1 raised to gamma. Okay, so this is all about the Carnot engine. And apart from this, into the kinetic theory of gases, right, one thing is remaining, okay, that I'm going to tell you all in front. Okay, this kinetic theory of energy is only about the speed, VRMS speed, average speed, right, and the most probable speed, relation of energy with the temperature, and mean free path. See, this is VRMS speed formula, right, the relation of kinetic energy with the temperature. This is the most probable speed. Like this way the average speed is defined. Okay, the kinetic theory of energy, kinetic theory of gases is very simple. Okay, come on everyone, those who are live, fast answer into the comment box. Right, fast, come on everyone, those who are live, students. Thumbs up into the comment box, come on everyone. Now SHM and waves are remaining and we are going to complete within short period of time because SHM waves are very simple. Right, I can't say equivalent to, or right, purpose of application of heat engine may be same, right, one of the applications can match it up, but this is not an actual thing. One of the applications may match it up. Okay, now see, simple harmonic motion, right? It starts with the concept of the periodic motion. It starts with the concept of the periodic motion. Okay, it starts with the concept of the periodic motion, and it's a very simple thing. Periodic motion is a simple category of the motion in which oscillatory will come. After oscillatory, simple harmonic motion will come, right? Okay, so these are the very basic. The reason for the SHM is F is equal to minus kx. This is an angular frequency equation. This is a time period of an SHM, right? Okay, after this is a kinetic energy, this is a potential energy, this is a total energy, and with that we are having one graph. You have heard about the graph of the SHM, right? The kinetic energy variation. Suppose this is a mean point, this is having the maximum kinetic energy, so the graph is like this way. This is the graph of the kinetic energy, right? This is negative of A, this is positive of A, right? Now what happens here? It is very simple thing. What happens here? What will be the graph at the negative A? The potential energy is maximum, so the graph is like this way. This is a graph of the total energy, which is constant, kinetic plus potential. At what point the kinetic energy and potential energy becomes equal? These questions are also asking to an examination. KE by root 2. TE, that is equal to KE by root 2. Yes or no, guys? Come on, everyone, those who are live. Okay, these are the multiple cases in which the time period of the SHMs are calculated. I am going to provide a shortcut for it. For all, right, for all cases there is one shortcut. Formula we are going to use is equal to T is equal to 2 pi under root of M by K equivalent, right? T is equal to 2 pi under root of M by K equivalent. Okay, now how we are going to? Step 1, use formula K, that is equal to K of spring into tension of block whole square. This is a shortcut. We have discussed this shortcut. Second step, if more than one spring is there, consider all in series. Consider all in series, right? Numericals, beta separate session we have done. This is a last moment revision is going on, right? This is a shortcut for all kind of the problems, right? This is a shortcut for all kind of these problems, right? Okay, suppose if more than one spring is there, right? Suppose pulley based problems are asked into an examination, na? Like this way, that suppose if this is a pulley, right? This is a spring, this is also the spring, and block is attached. Okay, calculate the time period of the SHM of the block. Consider this as spring 1, consider this as spring 2. K1, that is equal to K of spring, tension of block by tension of spring whole square. K2, that is equal to K, tension of block by tension of whole square. Consider this is into the series. Find the K equivalent. Okay, replace into the formula to get the answer. Very simple explanation. This is how the shortcut is applied. And I have discussed this into the champion series. I am going to discuss this into the victory batch everywhere. See, combination of series combination, parallel combination, right? This is a time period for the compound pendulum. Compound pendulum, it means the rigid bodies, they are getting oscillated, and time period for that. Okay. Damped oscillation and forced oscillations, we are not wasting time on that. You all are aware of the formulas are already present. Okay, now directly we are moving forward to the waves, the last part of it. Okay, as compared to the SHM, we can say it is waved. longitudinal displacement of the sound wave, pressure waves. See, in sound waves, right, everything is going to come up into the wave optics. The interference is going to come up into the wave optics, right? In this chapter, Doppler effect, right, the organ pipes and the speed of the sound into the multiple mediums, these three things are important at the very last moment. So you are aware of the speed of the sound into the elastic medium is given by this equation, right? Speed of the sound into the gaseous medium is given by this equation. Okay, this is a formula to calculate the loudness of the sound, right, in which the intensity is directly proportional to A square, right? Okay, max intensity is directly proportional to A1 plus A2 for the two sounds getting interfere, right? And minimum intensity is directly proportional to A1 minus A2 whole square. Ratio of it are also asked sometime into an examination. Okay, the most important thing that we are going to discuss, that is organ pipes, right? I'm going to give you all the Brahmastra. This is the interference. Again, this interference we are going to discuss into the wave optics. Don't get worried, where there we will have the maximum amount of the time. The most important thing is a closed organ pipe and open organ pipe. Into the booster pack, I have provided the shortcut for all of those stuff. For all of those organ pipes, you have to consider only one thing. There is only one Brahmastra. See, suppose this is a closed organ pipe. This is a fundamental mode, right? This is a closed organ pipe, right? This is a first overturn, second overturn, third. In all of those cases, you have to do only one thing. Calculate the length of the tube. Suppose this is node, all of the time into the closed organ pipe, on the one side antinode is formed. Distance between node and antinode is lambda by 4. So this distance lambda by 4 is equal to length of the tube. Lambda is equal to 4L, V is equal to lambda F, frequency is equal to V by 4L. We got fundamental frequency. Frequency of first overturn, node, antinode. Lambda by 2, lambda by 4, 3 lambda by 4. What will be the frequency of the first overturn? 3V by 4L. So here, as because of one side is closed, odd harmonics will come. The same thing you have to do into the open organ pipes. Suppose this is an open organ pipe, right? This is a fundamental mode. Antinode, node, antinode. What is the length of the tube? Distance between the antinode and antinode, lambda by 2. That is equal to length, lambda is equal to 2L, right? Frequency, fundamental frequency is V by 2L. Like this way, they can oscillate into the first overturn, second overturn, third overturn, right? So it is not important to remember all of those stuff, right? You can just remember how to calculate the length of the tube. Fundamental frequency you will get, first overturn you will get, second overturn you will get, right? Everything will get from that equation. Finally, right, the Doppler effect you all are aware of. Okay, the Doppler, the maximum part of the wave is again going to come back into the right wave optics. Don't get worried. See, this is a standing waves, the concept of the standing waves, right? Same happens into the standing waves. What is the length of this string? Fundamental mode. This is node, this is node. Distance between them is lambda by 2. See, like this way it is calculated in all of those cases. Doppler effect. Whenever there is relative motion between source and observer, the Doppler effect is produced. The Doppler effect is there. Whenever there is a relative displacement, a relative motion, right? Suppose I am a source. Somewhere here is a listener. I am emitting the sound of the frequency f. He is listening. If there is a no relative motion, then whatever I am emitting, the front person, the same he is listening. Suppose there is a relative motion. So there is a change into the frequency, the apparent frequency is heard by the listener if there is a relative motion. That same happens onto the station. Whenever I am standing on the platform, train comes. If it is a stationary, it blows up the horn with the same frequency I can hear. But suppose if it is moving, right, then suddenly the frequency increases and decreases. So
hello champions, how are you all doing? Tell me, how's your preparation going on? Well, I'm hoping that you all are doing great and you all must be gearing up for your preparation, as we all know that we are approaching the JEE date, that is 25th. So guys, even we are here for you all to make you prepare in the best possible way at Physics Wallah. So this is Sagar Dalvi, your organic chemistry teacher, and I welcome you to last minute revision part 1, in which we will be discussing organic chemistry concept here. So dear student, let me just brief you first how exactly the flow of this booster pack would be. So today is day number 1. It's a part 1 of booster pack where you already had a session on mathematics and physics. Today, as far as chemistry is concerned, we will be covering organic chemistry, and soon after this session you will be having session on physical chemistry as well. And tomorrow, which is part 2 of this booster pack, you will be having another session of inorganic chemistry as well. Now guys, let me just brief you about how exactly are we going to go ahead in this organic chemistry session today. So well, we all are aware that organic chemistry is one of the very important part of chemistry as far as the competitive examination like JEE is concerned. So we have to make sure that we are preparing this session very well. So in this organic chemistry part, since we have some 2.5 hours, we are going to make sure that all the most important concept of organic chemistry would be covered in this particular today's session. Well, so you might see that sometime we'll be doing the concept via questions. So we'll be taking some previous year question, and through that questions we will be covering some of the concept, or sometime we'll be doing theory followed by questions on those. So it's going to be a mixture of questions, previous year question, as well as the theory, that is the concept related to that particular theory. So guys, without wasting even single minute, let's get started with the last minute revision for organic chemistry. To begin with, we'll be covering some part of general organic chemistry, followed by isomerism and reaction mechanism as well. To begin with, straight away we have got the previous year question from 2013 JEE main on your screen, and the question speaks about the concept of the resonance from general organic chemistry. Well, the question is the order of stabilities of following carbocation. Dear students, on your screen you can see we have been given 3 carbocations. The first one is allyl carbocation. Hold on everyone, a little correction here. Hold on, let's keep this. Okay, come back to this question first. Little correction over there. Well, on your screen you can see we have been given several carbocation, and they're asking us to find out the order of stabilities of carbocation. So the 4 structures have been given. In the structure number 1, as you all can see here, we have been given secondary carbocation. That's secondary. Here we have got yet again a secondary carbocation. Here we have got carbocation connected to only one carbon, and this is also a primary carbocation. Now, when you talk about the order of stabilities of carbocation, there are several electronic effects which contribute towards the stabilities of carbocation. Sometimes those electronic effects also are responsible for the destabilization of carbocation. So what we are approaching here is the application of all the electronic effects that we have studied so far in general organic chemistry. So let me just brief you. When you talk about electronic effects, we talk about inductive effect, which is the shift of sigma electron pair, and then we study 2 types of inductive effect: electron donating inductive effect, that is plus I, and electron withdrawing inductive effect, that is minus I. Likewise, we also study electromeric effect, but we don't really use that as an application for the stabilities of carbocation. Then the most important one, we call it as mesomeric effect or resonance effect, which is again of two types: electron donating, that is plus M effect, and electron withdrawing, that is minus M effect. And then we also talk about the application of hyperconjugation effect. So the regular hyperconjugation, where the delocalization of sigma bond pair takes place into the vacant orbital of sp2 hybridized carbon, or sometime into the antibonding molecular orbital of the pi bonded carbon atom. Again, this is of two types. The regular one, where sigma bond is in conjugation with the pi, you call it as plus H. At times you might see the delocalization will be in other way around, that is pi bond delocalizing towards sigma bond, you call it as reverse hyperconjugation. Guys, keeping all these electronic effects in mind, if you look at this particular question, let us first see which electronic effects will be applicable for these carbocations in order to find out their order of stabilities. So the first one you see here, we have got carbocationic carbon. So this is the sp2 hybridized carbon, and the adjacent carbon is going to be sp3 hybridized carbon, which you call it as alpha carbon. So at this alpha carbon, since I am representing this in the form of a bond line formula, we know the fact at this carbon we will be having 3 more H's, so we will be having 3 alpha H's here. So the number of hyperconjugating structure depends upon how many number of alpha H's does that particular compound contains. So with respect to this sp2 hybridized carbon, this is sp3 carbon called as alpha carbon carrying 3 alpha H's. Likewise, adjacent to this sp2 there is one more sp3, I'll call it as 3 more alpha H's present here. So there will be 6 hyperconjugating structures stabilizing the carbocation. In addition to that, we also have oxygen atom carrying lone pair here. So other than hyperconjugation, lone pair in conjugation with the vacant orbital will also stabilize the carbocation. So structure number 1 is getting stabilized by hyperconjugation as well as one of the condition of resonance. Coming to structure number 2. In structure number 2, with respect to sp2 carbon, this is sp3 carbon carrying 3 alpha H's. With respect to sp2, this is sp3 carrying 2 alpha H's. So we have got altogether 5 alpha hydrogen atoms contributing towards stabilities of this carbocation. And then in structure number 3, with respect to sp2, this is sp3 hybridized carbon carrying 3 alpha H's here, and the adjacent oxygen atom carrying lone pair will also delocalize its lone pair into the vacant orbital of sp2 hybridized carbon. So other than hyperconjugation, again one of the condition of resonance, or you can say backbonding as well, stabilizing this carbocation. And now in fourth one, adjacent to this sp2 there is sp3 carbon carrying 2 alpha H's. So 2 hyperconjugating structure for the fourth one. While keeping this fact in mind, now if you look at the order of stabilities of carbocation, in carbocation number 1 and carbocation number 3, other than hyperconjugation, there is condition of resonance as well, meaning for sure first and third are more stabilized than the second and the fourth. Now between first and third there is a resonance condition in both, but structure number 1 is stabilized by 6 hyperconjugating structures, which means structure number 1 is the most stabilized, followed by structure number 3. So 1 is greater than 3. Which option says so? You can say 1 greater than 3. After that, between 2 and 4, fourth is stabilized only by 2 hyperconjugating structures, and in structure number 2 we have got 5 hyperconjugations. So the next best stabilized after 3 is 2. So 1, 3, 2 and 4. That is the correct order of stabilities of carbocation. The point to be understood here, whenever they ask us to find out the order of stabilities of carbocation, we should always keep the electronic effects in mind. Out of several electronic effects, we know the fact that resonance stabilization or destabilization will be dominant over hyperconjugation and then inductive effect. Hence the impact of resonance effect will always be considered as highest among these 3 electronic effects. Guys, whatever we discuss with respect to the concept of the electronic effect, we are going to apply it more with some more questions from the previous year. So taking you to the next question. Well, the question is from again 2013 JEE Main. The question says arrange the following compound in the order of decreasing order of their acidic strength. Well, whenever you see any question about finding out the order of acidic strength or finding out the order of basic strength, one simple thumb rule which I want you all to remember, that is, if we have to find out the order of acidic strength, remember a compound is acidic when its conjugate base is stable. Now what is conjugate base? Any anion obtained after removal of proton is what you call it as its conjugate base. So in order to compare the order of acidic strength of several acid, we will convert all of them into their corresponding conjugate bases. Once you convert all of them into their corresponding conjugate bases, you check the stabilities of conjugate bases. Whichever conjugate base is most stabilized, its corresponding acid will be considered as stronger acid. Similarly, when you talk about the order of basic strength of several bases, so just like we say compound is acidic when conjugate base is more stable, dear student, compound is basic when its conjugate acid is more stable. So how do you get conjugate acid? In a base, if you add a proton, because base is a proton acceptor, so upon accepting a proton, the positively charged, that is cationic species which we get, we call it as conjugate acid. So to check the order of basic strength, I'll check the stability of conjugate acid. Whichever conjugate acid is more stable, its corresponding base will be considered as more basic. So whatever we said, let's try and apply it here. Well, so we have been asked to find out the decreasing order of acidic strength of following compound. Well, all are the derivatives of phenol. What are we going to do here? To check the order of acidic strength of phenol, we'll assume all these phenols have lost proton and got converted to their conjugate bases. So simply we'll check the stability of conjugate base. To convert them into conjugate base, remove H plus ion. Imagine if H plus have been lost here. So what are we going to get? O minus, finite ion, carrying chlorine at para position. Likewise, I'm going to do it with all of them. H plus is lost, you got conjugate base. H plus is lost, conjugate base, and here as well we've got conjugate base. Now everyone, whether or not these conjugate bases are stable can be checked by looking at the charge carried at this particular carbon. For example, if I say somehow at this carbon if we get positive charge, meaning if you get a deficiency here, so this deficiency will withdraw this negative charge. Withdrawal of negative charge is what we call it as dispersal of a charge. More the dispersal of a charge, more the stability of that anion, meaning more the stability of conjugate base, and more stable the conjugate base, stronger is corresponding acid. Hence, in simple words, if you see a carbon carrying that O minus carries positive charge, it will stabilize that anion, and by somehow if we get negative charge here, then you can clearly see like charges will increase the energy of molecule, which means like charges will destabilize the anion. Now whether are we going to get positive charge here or negative charge will be dependent upon the substituent which is present on the benzene ring. Hence now we need to know that every substituent shows which particular electronic effect, whether plus M, plus H, minus H, or plus I or minus I, and accordingly will decide the order of stabilities of conjugate bases. Hence in turn we'll talk about the order of acidic strength. So firstly, when you talk about chlorine, always remember, whenever you have got halogens, only minus I effect to be considered. So chlorine will withdraw electron through sigma bond. When it withdraws electron through sigma bond, this carbon will become deficient, which means now at this carbon we'll be having a positive charge here. Positive charge on this carbon will withdraw the negative charge, meaning dispersal of negative charge. So chlorine is stabilizing the carbon ion. Stable the carbon ion, relatively stronger the acid is. Likewise, we have to check for all other substituents. Let's come to second one. Well, to this sp2 hybridized carbon of benzene ring, there is sp3 hybridized carbon which is attached in the form of methyl, and this sp3 hybridized carbon is carrying 3 H's, which means which means this molecule is going to show 3 hyperconjugating structure. So let's say out of these 3 H's, I am highlighting one of that. Let's say this is one of the H's. Whenever sp3 carbon carrying at least one alpha H is connected to sp2 hybridized carbon, there is a scope of hyperconjugation. And hyperconjugation, dear student, is nothing but sigma pi conjugation, meaning the sigma bond will completely delocalize towards pi. So this carbon will become pentavalent, this pi bond will move further, so this will become pentavalent. So pi bond has to further settle at the carbon to which O minus is connected. If pi bond settles here, this is going to be anionic carbon. Now you see 2 like charges, so it will destabilize this carbon ion. Destabilization of carbon ion, which means the compound is not that acidic. Likewise, you have to check for rest of the 2. So plus H effect here is destabilizing the carbon ion, minus I is stabilizing. Now let's talk about nitro. Well guys, when you talk about nitro, precisely the structure of nitro can be represented like this. Let's say this NO2 I'm writing like this. N single bond O minus and double bond O. So the first atom of the group which is directly connected to ring is nitrogen, which is doubly bonded connected to oxygen. So pi bond will break towards O, making nitrogen deficient. So pi bond will shift here, making this carbon deficient. So this pi bond will shift here, now making this carbon deficient. So deficiency here will withdraw the negative charge, will disperse the negative charge, hence stabilizing the conjugate base. But this dispersal has taken place due to minus M effect. So nitro here is showing minus M effect, which is the most dominant among all these 3. So the stabilization by minus M is going to be at the highest level. Now in case of 4, the first atom of the group is carrying lone pair. So lone pair in conjugation with the pi bond, if you delocalize it further, we are going to get a negative charge which is destabilizing via plus M effect. Well, so among all this structure, you can see structure number 2 and structure number 4 are getting destabilized. So the corresponding acid is least acidic. Structure number 1 and structure number 3 having positive charge here, meaning it will carry out dispersal of charge, so it is stabilizing the conjugate base. So these are most stable acid, most stronger acid. But between 1 and 3, because the positive charge here you got it through the more dominant effect minus M, so the dispersal of charge here in structure number 3 is most. So 3 is most acidic. So among all the options given, 3 most acidic. After 3, next one is 1, which you can see here. And after this, between 2 and 3, for between 2 and 4, 4 is most destabilized because negative charge here is via mesomeric effect, which is dominant effect. So 4th corresponding acid is least acidic. So 4th is least, relatively more acidic is 2. So guys, hence I would say that the correct option here is 3, 1, 2, 4. The whole idea is, first example which we saw where we compared the stabilities of carbocation directly. Now they are asking us to find out the order of acidic strength. The best way to do is, whatever acids have been given to us, will convert all of them into their conjugate bases like here. Then if conjugate bases are anion, then the carbon to which that anionic atom is attached, you have to check what charge are we getting here. Positive charge here will stabilize it, negative charge here will destabilize it. More stable the conjugate base, stronger is going to be its corresponding acid. Everyone out there, are we understanding or not? Yes? Excellent. So guys, let us do one more question. Here it is. The correct order of acidic strength of following acids here. Well, firstly, when you see structure number 1, 2, 3 and 4, you will see 3 and 4 are straight away carboxylic acid functional group. Structure number 1 and 2 are phenolic group. So one thing is for sure, if you directly compare the pKa values, we all are aware that carboxylic acid are more acidic than phenolic group. Hence, number 3 and number 4 are certainly going to be more acidic than 1 and 2. So 3 and 4 has to be more acidic. So you just have to check where 3 and 4 are more acidic. 3 and 4 more acidic, so this could be probable option. Here, they are saying 2 is more acidic, certainly ruled out. Again, after 3, they are talking about 2, so ruled out. 3 and 4. So see, we have ruled out 50% options. What is left is A and B. Now let's come back to the basics. How do we check whether compound is acidic or not? By checking the stability of its conjugate base. Hence what I'm doing, I am converting all of them into their conjugate bases. So I removed H plus, you got O minus. That is benzoate. Removed H plus, benzoate. Removed H plus, phenation. Removed H plus, phenation. Okay. Now check the stabilities of conjugate bases here. Well, if this is CO minus, if I manage to get positive charge here, it will destabilize, it will stabilize the anion, and negative charge here will destabilize the anion. But apparently in structure number 3, there is no substituent present, so we can't have any charge here. So this O minus can only be stabilized by the resonance happening in the carboxylate group only. No impact of substituent because there is no substituent. But in structure number 4, I have got methyl group. Just now we saw, when the substituent is such where the first atom of substituent is sp3 carbon carrying at least 1 H, it shows plus H. Plus meaning donation. So because of donation of electron at this carbon, we will get electron density. Hence this carbon will become anionic, which is destabilizing the conjugate base. So this conjugate base is destabilized, meaning it is relatively lesser acidic. So in comparison to 4, relatively more acidic is 3. So 3 is most acidic and then 4. So 3, 4 I see only here, not here. So we know that the answer is going to be A. But still, let's see the concept also. We discussed between 3 and 4. Now let's come to 1 and 2. Well, in case of 1 and 2, there is no substituent present in 1. But in structure number 2, we have got chlorine group present here. And the chlorine shows electron withdrawing inductive effect, that is minus I. If it will withdraw electron through sigma bond, a withdrawal will create deficiency of electron here, meaning the positive charge. So presence of positive charge here will stabilize the carbon ion. Stable the conjugate base, relatively more acidic, the corresponding acid. So 2 is more acidic than 1. That's why 2 is more acidic than 1. So dear students, our final order of acidic strength of this 4 compound is 3, the most acidic, followed by 4th, followed by 2nd, followed by 1st. Guys, that was all about the impact of electronic effect in deciding the stabilities of carbocation or carbanion, or in other words, deciding the order of acidic strength of several acids. Now, let's have a look at one more question where we are going to discuss about the order of basic strength. So you can see 2001 previous year question this was asked. Okay. Everyone pay attention to what I'm saying. Firstly, let's keep this question aside. Okay. And let us first understand one simple trick if the question is asked on the basis of order of basic strength among aliphatic amines. Alright, everybody pay attention here. So when they ask about order of basic strength in aliphatic amines, remember, you need to first understand whether the question they are asking in aqueous phase or gaseous phase. I am telling you directly a conclusion. Remember this conclusion and you will be able to solve several questions. Look, suppose if they have given us several aliphatic amine, you will see generally the question will be asked with the value of alkyl as either methyl or ethyl. So if the value of alkyl group is methyl, then in aqueous phase order of basic strength will be S, T, T, A. As of now, I want you guys to remember this simple trick. S stand for secondary amine, P stand for primary amine, T stand for tertiary amine, and A stand for ammonia. So among several alkyl amines, if the value of alkyl group is methyl, guys, let me remind you, I'm talking about several amines, as in I'm talking about the amines could be RNH2, R2NH, secondary amine, R3N, and ammonia. Okay, I'm talking about this. So if they are asking us to find out the order of basic strength of several amines in aqueous phase, and if the value of alkyl is methyl, then the order of basic strength will be secondary, primary, tertiary, and then ammonia. But if the value of alkyl group, let's say, is ethyl, then the order of basic strength will be S, T, P, and A. That is secondary, the most basic, just like in previous case when the value of alkyl was methyl, then tertiary, then primary, and then ammonia. Simply remember this order. Now suppose if they're asking the same order of basic strength in gaseous phase, then conceptually speaking, hydration effect and steric effect does not come into picture, and straight away you can say in this case the order of basic strength, whether alkyl is methyl or ethyl, would be tertiary the most, then secondary, then primary, and then ammonia. Okay, I want you guys to remember this simple conclusion. Now let's come back to the question. In the question they ask the correct order of basic strength of following compounds. Okay, when you see this, the correct order of basic strength of following compound, out of this four options, option number 2 and option number 3 seems to be simple alkylamines, just like this. Yeah, wherein to the value of alkyl is ethylamine, but it's a primary amine. You can see that this is primary amine, and this is dimethylamine, so this is secondary amine. Well, whenever they do not mention in which medium do we have to consider the order of basic strength, by default we consider that the question is in aqueous medium. So that's why everyone, I'm assuming that the medium is still a water. So in water, irrespective what is the value of alkyl, the secondary amine is most basic, which means between second and third, because third is secondary amine, it is going to be more basic than the primary amine. So between these two, I'm saying 3 is more basic than 2. 3 is more basic than 2, and that's why any option which does not say so will be ruled out. So 3 greater than 2, I can see that here. Here 2 greater than 3 ruled out. 3 has to be greater than 2. 3 greater than 2. Here also 2 they are saying greater than 3, so even this is ruled out. Now what is left is between 1 and 4. Well guys, when you talk about in general alkylamines, and if you compare their basic strength, if you just go back to the basics, when do you say any compound is base? Well, according to Lewis theory, any substance that donate lone pair is what you call it as a base. So a lone pair donor is called as an base. So in case of any alkylamine, because alkyl group shows electron donating inductive effect, because alkyl donate electron density on nitrogen increases, as a result of which it becomes better electron pair donors. Hence alkylamines are basic in nature. If you talk about this acetamide, structurally, if I draw acetamide here, CH3, C double bond O and NH2. My dear student, pay attention here, look at the structure. You all can see that. So in this acetamide, the lone pair of nitrogen atom are in conjugation with the pi bond, lone alternate pi. Because they are in conjugation with the pi bond, their delocalization tendency is more, which means in other words, the electron pair donating tendency is very less. If lone pair donating tendency is very less, meaning its Lewis basic character is also very less. Hence, fourth is certainly going to be less basic than 2 and 3. So fourth has to be less basic than 2 and 3. So 4 less basic than 2 and 3, which is here as well and here as well. So B and C are still in competition. Now let's come back to the first one. First one, I'll write it here. Well, we have got CH3, C double bond NH, where N will be carrying lone pair and carrying NH2. Everyone here. So what we have learned, compound is acidic when the conjugate base is stable. Similarly, compound is basic when its conjugate acid is stable. So to check the order of basic strength, I'll have to compare the stability of its conjugate acid. So how are we going to get conjugate acid? Well, conjugate acid we get by addition of protons. So let's say this doubly bonded nitrogen attacked at the proton and became NH2 plus. So the molecule will now look like NH2 plus and NH2. So this NH2 plus indicates now pi bond will be broken over N, making this carbon deficient, so lone pair can further delocalize and you'll get yet another resonating structure. So we have got CH3 C. This became singly bonded NH2 with the lone pair attached on nitrogen, and this is NH2 double bond and positive charge on it. What do we understand from this? We understand that when we had this starting compound, a base which upon protonation gave us a conjugate acid, and this conjugate acid is stabilized by the resonance, because conjugate acid is showing phenomena of a resonance. So as a result of the phenomena of a delocalization, you can see the positive charge from this nitrogen have been transferred, have been dispersed to another nitrogen, and dispersal of a charge decreases the energy of molecule, which means in turn stabilizes the corresponding ion. So that indicates the conjugate acid of this compound is stabilized. Now think about the statement that we have been talking so frequently. Compound is base when its conjugate acid is stable. So this compound is basic because its conjugate acid is stabilized by the phenomena of resonance. Because its conjugate acid is stabilized by resonance, it is more basic. So among all, the most basic will be the one whose conjugate acid is resonance stabilized. So 1 is most basic, followed by 3, because second is anyways more basic than primary. So 1, 3, 2, and the least basic is 4. So 1, 3, 2, 4 is your answer, option B. So dear students, so far what we have done, the most important part of general organic chemistry, that is application of electronic effect. So here we saw several questions from the previous year where we covered the concept of application of electronic effect in terms of inductive effect, hypoconjugation, and resonance effect. Now taking you ahead with yet another next question, but this time it is from isomerism. You can see here year 2000 question, which of the following compound will exhibit geometrical isomerism? Well, we all are aware that isomers are the compound having same molecular formula but different physical or chemical properties, or maybe both. Now such isomers could be of two types: structural isomers and stereoisomers. Structural isomers are of further several types. But what are structural isomers? When two or more compounds have same molecular formula but different structural formula, you call them as structural isomers, which can be of several types: chain isomers, positional isomers, ring chain isomers, functional isomers, metamers, and tautomers. These are some of the structural isomers. And then comes the next category called as stereoisomers. What are stereoisomers? Everyone, compounds having same molecular formula as well as structural formulae, but different arrangement of atom in a space. So if arrangement of atoms in a space differ, you call them as stereoisomers. And we further classify the stereoisomers into two categories: configurational and conformational. Now these configurational isomers are of further two types: geometrical and optical. So in a way you can say stereoisomers are of three types: geometrical isomers, optical isomers, and conformational. Out of which, if you just see the previous year question, you will realize that the geometrical and optical is one of the most important part of chemistry, where you will see the question have been asked very often. So we are taking example from the geometrical isomerism. Question is, which of the following compound will exhibit geometrical isomerism? Well guys, let me just brief you about the concept first. Pay attention here. Look, let's say I have got a molecule 1,2-dichloroethene. Okay, 1,2-dichloroethene. That's 1,2-dichloroethene. Okay. This 1,2-dichloroethene, I can put it in two ways. The first one is carbon-carbon double bond. I'm writing that here. At every doubly bonded carbon, there are two valencies. Here as well, there are two valencies. Here as well, at the doubly bonded carbon, there are two valencies. To the left doubly bonded carbon, one of the valencies is hydrogen, other is chlorine. Let's put that, hydrogen and chlorine. Here as well, I've got hydrogen and chlorine. Okay, this is one way of writing the structure. And in the second structure, to the left hand side carbon, I'm keeping hydrogen and chlorine as it is, like we had it here. But now at the second carbon, let's say the compound is formed in such a way that this chlorine is up here and hydrogen is down here. Okay. Now, let us first talk about these two compounds, what kind of isomer they are, whether they are structural or whether they are stereo. Well, for two compounds to be called as structural isomers, they need to have same structure. And when do we say that the structure of two compound is, for any two compounds to be a structural isomers, they need to have a different structures. And when do we say that they have got different structure? When the connectivity of at least one atom differs in the molecule. So if you see the connectivity of even one atom in the two structures differs, you say they are structural isomers. But here, look, the left hand side doubly bonded carbon carries one hydrogen and chlorine. Here as well, the left hand side doubly bonded carbon is connected to hydrogen and chlorine. The other doubly bonded carbon has further two more valences, one of which is hydrogen, other is chlorine. And here as well, one of which is hydrogen and other is chlorine. Meaning connectivity wise, there is not even single atom which is showing different connectivity. If connectivity of none of the atom differs, we say structure is no more different. So they can't be called as structural isomer. So these two are not structural isomers. But having same molecular as well as structural formula, if you see the arrangement of atom, as in, let's say I am saying chlorine is my reference atom. So in the first structure, two chlorines are on the same side of carbon-carbon double bond. In second structure, those two chlorines are on the opposite side of carbon-carbon double bond. So when the arrangement of reference atoms in a space differs, so we call them as space isomer, meaning stereo isomers. Hence we say two or more compounds having identical molecular as well as structural formulae but different arrangement of atoms in a space, we call them as stereo isomers. Now question arises, how can we say that the arrangement of atom in a space is different? Well, let us say experimentally using some spectroscopic method, if we find out the distance between these two chlorine atom, let's call it D1, and the distance between these two chlorine atom, let's call it D2. If you compare the D1 and D2, you will realize that this distance is not equal. If the distance between the two reference atom is not equal, that itself is a proof that the arrangement of this atom in a space is certainly differing. Because the arrangement of atom in a space is different, we call them as space isomer, meaning stereo isomer. Hence we are saying these are space, meaning stereo isomers. Now stereo isomers are of two types, that is optical and geometrical, and conformational is third category. Now how do we say that they are geometrical isomers? Look, geometrical isomerism arises when the distance between the two reference atom is different. Because here the geometrical distance between the two reference atom is differing, I am referring them as geometrical isomers. Now let's come back to question. Once you know that the given compound are geometrical isomer, how do we know whether this compound can actually exhibit geometrical isomerism or not? Well, so for any compound to exhibit geometrical isomerism, at every doubly bonded atom, the two groups present must be different. Like this molecule is showing geometrical isomer because at every doubly bonded carbon at a time. So at a time, if I look at this doubly bonded carbon, one group is hydrogen, other is chlorine. Two different groups. Here at doubly bonded carbon, one is hydrogen, other is chlorine. When two groups attached at the doubly bonded carbon are different, that molecule is eligible to show geometrical isomerism. Hence, such carbon-carbon double bond will be referred as geometrical center. This is called as GC. So, any doubly bonded part of a molecule could be carbon-carbon double bond, could be carbon-nitrogen double bond, could be nitrogen-nitrogen double bond as well. This kind of centers can be geometrical centers only if at every doubly bonded carbon, the two groups present are different. And that's what we have to apply in this question. So guys, we have learned the concept. Let's try and apply that. We have to find out which of the following compound is capable of showing geometrical isomerism. Well, looking at the first question here, 1-phenyl-2-butene. Let us draw the structure, okay? 1-phenyl-2-butene. So 1, 2, double bond, 3 and 4. one phenyl. So at carbon number 1, you're putting phenyl here. Important is the doubly bonded carbon. At doubly bonded carbon, I can see 3 bonds. So the fourth has to be H. At this doubly bonded carbon also, I can see 3 bonds. 1, 2 and 3. So the fourth has to be H. Remaining, if you just want to satisfy, this is CH3. This is CH2. Now what's the criteria? For any compound to show geometrical isomerism, at every doubly bonded carbon, the two group must be different. So at this doubly bonded carbon, two groups are hydrogen and phenyl methyl. So these two are different. At this doubly bonded carbon as well, one is hydrogen, other is methyl. So because at every doubly bonded carbon, the two groups present at a time are different, I will say this molecule will exhibit geometrical isomerism. So how will you show the geometrical isomer structures? You will draw them in this fashion where, let's say, the reference atom is hydrogen. So in one structure you put them on the same side of double bond, in other you put them on the opposite side. Those will be two JEIs, geometrical isomers of each other. Let's check that out with option B. 3 phenyl, 1 butene. Okay, 1 butene. So double bond at first, 2, 3, 4. And phenyl at 3, 1, 2, 3. What is important is not substituent. What is important is the valencies at the doubly bonded carbon. So everyone, look at this doubly bonded carbon here. Do you see there are two H's here? At doubly bonded carbon, two atoms are identical. Straight away this is ruled out. This cannot show geometrical isomerism. So B ruled out. C. 2 phenyl, 1 butene. Okay, again a butene. Number 2, 3 and 4. Phenyl group at number 2, alright. And then no other substituent. So at carbon number 1, remaining two valencies would be fulfilled by hydrogen. Yet again, at this doubly bonded carbon, two groups are different. One is phenyl, other is ethyl. But at this doubly bonded carbon, both being identical groups, this molecule cannot show geometrical isomerism because this is not a potential geometrical center. So option C is also ruled out. Guys, are you understanding? Whatever we learned here quickly in a concept, we are just applying to the options given to us. Then comes is D. 1,1-diphenyl propene. Propene. At first, you have got two phenyl. See, this condition itself is ruling out that this is going to show geometrical isomer. This won't ever show. Why? At this doubly bonded carbon, the two groups being identical, this is not a potential geometrical center. Hence, this will also not show geometrical isomerism. So straight away, if any structure is given to us and if they ask us to find out which of them can show geometrical isomerism, just look for the two valencies of every doubly bonded carbon. Such compound will show geometrical isomerism. However, let me just tell you some extra thing. It's not always required that there has to be a carbon-carbon double bond. There are some more geometrical centers which also show geometrical isomerism other than carbon-carbon double bond, such as you may have, I'm writing down that here, okay? We may have a compound like oxime, that is C double bond N and OH. So here, other than 3 bonds of nitrogen, there is a lone pair. So I'm writing that lone pair which is present in sp2 hybridized state. So whenever you look at the two groups present at the doubly bonded carbon, whatever group you have here, it could be R and H or it could be R and R dash as well. So at this doubly bonded carbon, if you see two groups different, this carbon is eligible. Now you might be thinking, what about N? Because we don't have any group here. So when it comes to N, you don't need a group. You compare lone pair with a bond pair. And always remember, the bond pair has a higher or highest priority over lone pair. So bond pair will always be prioritized over lone pair. So lone pair and bond pair by default are considered as two different valencies. So nitrogen is satisfied for sure. Only at this carbon the two group has to be different. Then such oxime, meaning carbon nitrogen double bond, will also show geometrical isomerism. And then there comes azo compound, that is N double bond N. So for these N's, we are going to have one bond here and one lone pair. Here as well one bond pair, another lone pair. So let's say if this is R and this is R. So when two bond pair containing alkyl groups are on the same side, you can call it as syn, SYN. If you put one alkyl here and if you interchange these two, if R goes up, then two alkyl will be opposite side, you'll call it as anti. That's how, other than carbon-carbon double bond, you can also see there will be several compounds containing carbon-nitrogen double bond in oxime and nitrogen-nitrogen double bond in azo can also show geometrical isomerism. Guys, that was first question from geometrical isomerism. Taking discussion ahead straight away. In 2016's JEE main question about finding out the RS designation of a compound represented in a Fischer's projection containing two chiral carbon. So here is the compound. This is some butanoic acid given to us carrying hydroxy and chlorine as a substituent. Okay, I want you to have a look at this question first. I need few seconds to drink water, guys. Have a look at the question. Try to recall what you have learnt about RS designation. Try to recall CIP sequence rule because that is what helps us to find out the designation. Come on. Okay, everyone here? Look, whenever we see any compound represented in the Fischer's projection, first of all, RS designation, where R stand for rectus, meaning to the right or clockwise, S stand for sinister, meaning to the left or anti-clockwise. Okay, now what is that clockwise or anti-clockwise? Before which, always remember that RS designation is an absolute configuration or a designation given to only that carbon which is a chiral carbon. So let's assume I have got Fischer's projection of a chiral carbon having four groups attached here, A, B, C and D. Generally, according to the guidelines of Fischer's projection, we always represent the molecule in the Fischer's projection in such a way that the carbon containing groups are written on the vertical line. That too, the most oxidized group occupies the top position here and the rest of the carbon chain. What we do here, we first identify which is the chiral carbon. Like here, let's assume that this is the chiral carbon. Then whatever four groups attached to it, we give priority to those groups. So let's say somehow we managed to give priority. This is 1, this is 2, this is 3 and this is 4. How to get priority? Of course, we'll discuss that. Somehow we managed to assign the priority using CIP sequence rule this way. Then we ensure that the fourth priority, the least priority group, is on a vertical line, either up or down. If it is down, then you see the remaining group and you read them like 1, 2 and 3. When you read those 1, 2 and 3 priority, our eye is moving in a clockwise direction, isn't it? 1, 2, 3. If it moves in a clockwise direction, you see the designation of this chiral carbon atom is R. Suppose if I would have had a structure like this. Let's just to take an example, this is A, let's say this is D, this is B and this is C. So according to the priority using CIP sequence rule, we got priority to the A as 1, priority of B was 2, priority of D was 3 and priority of C was 4. Again, you will always ensure that the fourth priority group is on a vertical line, either up or down. Now it is down, absolutely fine. Then you read other groups 1, 2 and 3. So your sequence of 1, 2 and 3 is moving. Your eye is moving in an anti-clockwise direction while you read it. Because it is in anti-clockwise direction, you call it as sinister. So I'll say designation here is S. But sometimes it happens that we might not have a fourth priority group neither up nor down. Let's see if I have something like this. Let's say I've got C here, then A, B and D. So what is our priority? A was prioritized as 1, B was prioritized as 2, D was prioritized as 3 and C as 4. Now see, it is essential that the fourth priority group is either on vertical line, in a vertical line, either up or down. Now we don't have fourth priority group neither up nor down. So ideally we are supposed to exchange the position using some rule. But let's apply a simple trick. Tell me how many designation possible, either R or S, right? Either R or S. So here, when the fourth priority is on a vertical and whatever answer you get is your correct answer. Now suppose if the fourth priority group is not vertically up or down, still I ignore it, and if I see how my eye is moving, then I can see 1, 2, 1, 2 and 3. It is moving in a clockwise direction, meaning I am getting my answer as R. Hold on. We got our answer as R when the fourth priority group is not at the position where it should be. Meaning the fourth priority group is not on a vertical line and you got your answer R. Meaning this is not going to be your correct answer. So your correct answer in that case would be S. Because if when fourth is neither vertically up or down, if answer is R, naturally had it been on a vertical line, then the answer would be S. Because there are only two probabilities, it has to be either R or S. So when the fourth priority group is at the appropriate position where you want, it is R. It is the appropriate designation. If it is not, then find out the designation and reverse the answer. That's how you find out the RS designation. Now, this was the example of compound containing 1 chiral carbon. The molecule which they have given is the compound containing 2 chiral carbon. Before which, how did we find out these designations or the priorities? Well guys, the priorities attached, the priorities of the group attached to the chiral carbon are given on the basis of set of 4 rules defined by 3 scientists called Kahn, Ingold, Prelog, CAHN, Ingold, Prelog, PRELOG, which we call it as CIP sequence rule. So CIP sequence rule is a set of 4 rules which we apply and accordingly find out the priority. Quickly revising these 4 rules, everyone, for you all. Rule number 1 says atom of the first point of attachment with higher atomic number receives the higher priority. Let's say in the chiral carbon, if I've got chlorine, OH, CH2NH, then you look for the atom of first point of attachment. Like to this chiral carbon, first point is oxygen, this is chlorine, this is carbon. Although methyl is the group, the first point of attachment is carbon and their hydrogen. So the chlorine is of higher atomic number, so given priority 1. Then in this group, first point of attachment is oxygen, given priority 2. Then carbon, relatively less atomic number, priority 3. Hydrogen, least atomic number, priority 4. That is CIP sequence rule number 1. CIP sequence rule number 2 says if there are atoms which are isotopic with each other, let's say hydrogen, deuterium, chlorine and methyl. So among all these atoms, chlorine of course of higher atomic number, priority 1. Then there is a carbon, priority 2. Between hydrogen and deuterium, if there are 2 atoms which are isotopic with each other, then the atom with a higher atomic mass number will be given higher priority. So I will say deuterium is prioritized over hydrogen. So priority 3 is to deuterium and then to hydrogen atom. Now let's say if we have a group such that, I'll write it down here. Let's say we have CH3 and CH2OH. Here it is H and here it is chlorine. Now see, chlorine and hydrogen is fine. Between CH3 and CH2OH, the first point of attachment is same. First atom here is also carbon. First atom here is also carbon. So when the atom of first point of attachment is same, you go on to the second point of attachment. If second point of attachment is also same, you go on to the third point of attachment. What does that mean? Just to simplify, CH3 can be written like this: CH, H and H. CH2OH can be written as C, H, H, and OH. So the first point of attachment is carbon, first point of attachment is carbon. After carbon, what exists? The second point of attachment could be this H, or this H. Whatever atoms you have, put them in the decreasing order of atomic number. So I've got H, H, and H because all are identical. Whereas in case of the second example, after carbon, the next point of attachment could be either this H, this O, or this H. So if I put them in the decreasing order of atomic number, I'll have O, H, and H. And now you compare the set of among the set of three atoms, first atom of first set with the first atom of second set. See if there is a difference. Is there a difference? Yes, oxygen is of higher atomic number than hydrogen. So this whole group will be prioritized over methyl. So if chlorine was priority 1, between these two, CH2H is priority 2 and methyl is priority 3. So when the atom of first point of attachment is same, go on to the second point of attachment. If that is also same, go on to third, so on and so forth. Let's say if the first atom would have been identical, I would have gone for the second point of attachment, so on and so forth. And the fourth priority and the fourth CIP sequence rule says if any atom is doubly bonded, it is to be duplicated, and if any atom is triply bonded, it is to be triplicated. What does that mean? In short, look here. Let's say if I have to decide the priority between C double bond OH aldehyde and between C triple bond and nitrile. Here it is doubly bonded atom, here it is triply bonded atom. So what I said, any atom which is doubly bonded is to be duplicated, meaning to this carbon, hydrogen is singly bonded. I'm putting that down here. Now because oxygen is doubly bonded, I will consider duplicate of oxygen. So meaning I'll consider oxygen twice. So this is one oxygen and this is second oxygen. Okay. Now in reality, do we have two oxygen? No, we have only one oxygen. So out of two, one is the real one and the other is considered as unreal, a duplicate. So let's say I'm assuming this as real and this is unreal. Whatever is unreal, put box around it. That is parenthesis, rounded bracket. Now guys, because oxygen was doubly bonded, you consider duplicate of that. Similarly, the carbon is also doubly bonded connected to oxygen, meaning even carbon has to be duplicated. So I've got only one carbon, I need to put one more carbon, but I'll always put it to the real oxygen. So I put one more carbon. But do we have two carbon in reality? No, only one is real, other is unreal. So this is real, that's your unreal carbon. That's how we simplified the aldehyde. Now how do we simplify the nitrile? Look, a carbon, we wrote it here. Nitrogen being triply bonded, you will triplicate it, meaning write it down thrice. 1, 2 and 3. But in reality, do we have 3 nitrogen? No, we don't have 3 nitrogen. We have just 1 N, meaning out of 3 N only 1 is real, other 2 are unreal. So let's call this is real, rest 2 are unreal. Put them in a parenthesis, rounded bracket. Because nitrogen was triply bonded, we consider it to be triplicated. Likewise, even carbon is triply bonded. So I must consider carbon to be also triplicated. So to the real N, I put two more carbon. One is here, this is second and third, and these are unreal. Now look, if the first point of attachment is carbon in both the cases, so after carbon, what is the second attachment? OOH. Like we did earlier, we put them in a decreasing order of atomic number, OOH. Here, after carbon, what is the next atom? N, N, N. All three are identical, so put them down, N, N, N. Now compare the first atom of this set with the first atom of second set. See the atomic number. Is it identical? No, it is not. Oxygen is of higher atomic number than nitrogen. Hence, this is a priority, meaning aldehyde is given priority 2, nitrile is given priority. Aldehyde is given priority 1, nitrile is given priority 2. Guys, that's how using this set of 4 sequence rule, we assign the priority. Once you assign the priority, you know you have to bring the fourth priority group vertically up or down. If it is already there, see how your other groups are moving. Clockwise call R, anti-clockwise call S. If fourth is not vertically up or down, then wherever it is, find what is your designation and reverse the designation. That will be your correct answer. Keeping this fact in mind, now we are solving this 2016 JEE main question of assigning the RS designation to this molecule. Well guys, we have got COOH. I'll just simplify that for you. Where shall we do it? Okay. Look, so here we have C double bond O OH. This is OH. Chlorine, methyl, hydrogen, and hydrogen. Now, if you look at this carbon, this is chiral, this is chiral. Second carbon, this is third carbon. So the designation RNS will be always at second and third. That's why in option you say 2R, 3S, whatever it is. So at this chiral carbon, the first point of attachment is C. Here it is O and here it is C and then H. So OH is priority 1. Now carbon and carbon, if the first point of attachment is same, you go for the second point of attachment. So after this carbon, second will be Cl, CH, right? Cl, CH. Above, after carbon, doubly bonded O, meaning OO, duplicated. OO and O. So here the groups are O, O, O. But naturally, chlorine is higher atomic number than O, so the whole group will be priority number 2. So this is priority 2, this is priority 3, and this is priority 4. Fourth is not where we want it. So we'll assign the designation and we reverse it. So it is 1, 2, and 3. 1, 2, 3. Your eye is moving in a clockwise direction, meaning ideally it is anti-clockwise. So at second carbon, anti-clockwise meaning S. So 2 will have a designation of S. Fine. And now come down to this carbon. Well, for this carbon, number 3, first point of attachment, this is carbon. To the right, I've got chlorine, down carbon and hydrogen. So chlorine is priority 1 for sure. Chlorine is priority 1. Now between this methyl and the entire group, after first point of attachment, remaining atoms are HHH, H, H, H. Up here, after the carbon, like you had carbon, you had HHH. After carbon, you have got OCH, OCH. So this is very clear that O is higher atomic number than H. Hence the whole group is priority 2. This is priority 3. This is priority 4. Again, 4 is not where we want it. So whatever answer we are going to get, we are going to reverse it. So 1, 2, 3. Your eye is moving in anti-clockwise direction, meaning it is going to be in clockwise, meaning R. So at carbon number 3, the designation will be R. So check for the option of 2s3r. Where do you see 2s for 2s3r? 2s3r is straight away answer option A. That's how guys, if any molecule given to you, you find out the priorities using CIP sequence rule. Apply this 4 CIP sequence rule in a sequence. Then decide the priority. Once you decide the priority, see whether the fourth priority is at the position where you want it or not. If it is, whatever is your answer is your correct, you can say, configuration. If not, reverse the configuration, that will be the correct one. Lovely guys. So that was about finding out RS designation. Next question is from reaction mechanism. I've told you that we are going to cover this 3 chapters together, which is GOC, isomerism and reaction mechanism. So just read the question first. You can see this is 2020 JEE main question. The mechanism of SN1 reaction is given as follows. Well, they have given SN1 already. Alkyl halide is given to us, meaning certainly if it is SN1, preferably the degree of alkyl halide has to be tertiary, which first slowly undergoes in a rate determining step. So slow dissociation of carbon halogen bond produces carbocation and X minus. Then once carbocation and X minus is formed, it is stabilized by the solvent, which is generally a polar protic solvent, and then Y minus attack at the deficient carbon in either ways, that is from front side or back side, and we get formation of a product which is a partial racemization. Right guys, this is what we have studied. Now they're asking, find out which of the statements are the correct characteristics of this corresponding reaction mechanism. Well, guys, you might see several times the question will be asked in such a way that there will be two mechanisms which will confuse you. For example, SN1 and E1 are two such mechanisms which can only be distinguished from each other by the temperature. Otherwise, most of the condition you'll always find seems similar. So in such case, how are we find out, or how are we going to judge the substitution versus elimination? Hence, before we answer this question, I want you to have a quick eye on comparison of four mechanisms. So what I'm going to do here, I'm going to compare several mechanisms. Like first I'll talk about SN1 or SN2, comparing that with SN1 followed by E2 and E1. So this is substitution versus elimination. Okay, everyone, pay attention to what I'm saying. Now all these points will be discussed with respect to first one, nature of substrate. Second one, nature of nucleophile or base, whatever it is. If it is substitution reaction, of course, if it is substitution, you will be talking about nucleophile. If it's elimination reaction, you'll talk about base, whether stronger or weaker. That's what we are talking about here. Number three, is nature of leaving group, L group. Number four is nature of solvent. Okay, everyone. Now look, whenever you talk about SN2 reaction, the most important thing that you should remember, which is called as key feature of four mechanism that we have to understand, is SN2 is a concerted step. Concerted step meaning when the simultaneous attack of a nucleophile and simultaneous departure of leaving group takes place, meaning when reaction takes place in one step, you call it as concerted. So remember, SN2 is concerted, and whenever you refer the term as concerted, this clearly indicate the nucleophile or base, whatever, has to be strong enough, because only when it is strong enough it will attack at the deficient carbon and simultaneous departure of leaving group will take place. So in SN2, it's a concerted step, meaning one step. For reaction to take place in one step, the nucleophile has to be strong enough. Okay. SN1 is a two-step reaction. SN2 is one step, SN1 is two steps. So in that two step, the first step is the rate determining step, which is formation of a carbocation. So SN1 involves its key feature, that is formation of carbocation. SN1 involves formation of carbocation. E2 is again bimolecular elimination. Even this is concerted step. So concerted meaning what? Even this is a one step reaction. So because in E2 you need a base, abstraction of a proton and departure of leaving group will take place simultaneously. Whereas even again this is two steps reaction which involves formation of carbocation. So formation of carbocation. Okay, everyone. Now let's talk about the features of all this reaction. Substrate. Well, when you talk about nature of substrate, SN2 reactions, only SN2 is such reaction where methyl halide is most reactive, followed by primary, followed by secondary, and tertiary alkyl halide will not give you SN2 reaction. Nature of substrate for SN1 is reverse. Because it involves formation of carbocation, whichever alkyl halide will form stable carbocation, it will react fastest towards SN1. So I will say tertiary alkyl halide is most reactive, followed by secondary, and then primary but it will be least reactive, and methyl anyways it doesn't form stable carbocation at all. So methyl halide won't have any reactivity towards SN1. Now everyone, E2. E2 involves abstraction of a proton simultaneously with the departure of leaving group to form an alkene. So naturally, thermodynamically, whichever alkene will be more stable, its corresponding alkyl will be most reactive. So if you compare the hyperconjugation stability to the alkene, we say more the number of alpha H's, more the stable alkene is. So for more stable, meaning for more substituted alkene to be formed, the alkyl halide has to be sterically hindered. Hence the order of reactivity of E2 will be tertiary the most, then secondary, and then primary. Methyl halide won't have beta carbon at all, so methyl halide won't give you E2 at all. Okay, so like I said, only in SN2 methyl is most reactive, meaning less sterically alkyl halide, but in rest all tertiary is going to be most reactive. Again, even the key feature of even says it involves formation of carbocation, so logically tertiary has to be most reactive. So that's the nature of substrate for all these four mechanisms. Second is nucleophile or base. Remember, SN2 is a concerted step. Concerted meaning simultaneous attack of a nucleophile and departure of a leaving group. Meaning the nucleophile that we have in that reaction should be a strong enough. So strong nucleophile, which means anionic nucleophile. So I would say strong nucleophile meaning anionic. Meaning anionic nucleophile will favor SN2. For SN1 you don't need strong nucleophile, you need weak nucleophile. Weak nucleophile meaning solvent itself. Solvent itself meaning let's say you may have water or methanol or RCOH, anything like that will favor SN1. E2, just like SN2, even E2 is concerted. So you needed strong nucleophile, here you need strong base. And I want you to remember 5 examples. Everyone here? Strong base. When you talk about strong base, remember this 5 simple example. Start with alcoholic KOH. Alcoholic KOH. From this term alcohol, remember 3 more alcohol. First is ethanol. So take ethanol's conjugate base, meaning ethoxide. So from alcoholic KOH, you remember alcohol, ethanol, remember methanol. So methanol's conjugate base. This will be very rarely given, but you can have this. From this also remember tertiary butyl alcohol. So tert butyl. CH3 thrice, CO minus. Fine. So 4 strong bases we have used which are related to alcohol. Alcoholic KOH, from alcohol ethanol's conjugate base, from alcohol methanol's conjugate base, and from tertiary butyl alcohol it's tertiary butoxide. And now finally also remember sodamide. So let's say if I have got NaNH2 sodamide. So guys, if you ever find any of these anionic species, see here also we need anion. But these anions are other than this. If you have got anion this one, then they are always a strong base. Strong base will always carry out E2. So in 90% of the cases, any of this anion given would carry out E2. Only exceptional thing would be, imagine if they give you ethoxide. And if alkyl halide given is methyl halide. So methyl halide to anyways doesn't give E2. And methyl is most reactive for SN2. So although you have any one of this and methyl halide, then it will give you SN2, not E2, although that is a strong base. But in such case, it is going to act like a strong nucleophile. And even, well, weak nucleophile favors SN1, just like that. Weak base. So when I refer weak base, meaning it talks about solvent itself. Solvent itself will favor the even reaction mechanism. Leaving group, well guys, for leaving group remember universally it always has to be a good leaving group. So whether it is SN2, SN1, E2 or even, good leaving group favors all this mechanism. So good leaving group everywhere. So good leaving group will favor all these reaction mechanisms. Okay. Solvent, yes, the important one. Think logically. When you talk about SN2 reaction, we are saying it's a concerted step, meaning you want your nucleophile to be stronger, meaning you want it to be anionic. Now imagine with anionic nucleophile, if I take polar protic solvent, protic meaning where hydrogen is connected to more electronegative atom. So that hydrogen in the solvent, like alcohol, ROH, so that hydrogen connected to oxygen will always carry delta plus charge. Such delta plus charge will always form hydrogen bond with anionic nucleophile. Hence, if anionic nucleophile will be forming hydrogen bond with the protic solvent, then that anionic nucleophile will be now binded to solvent, meaning that anionic nucleophile will be captured by the solvent. So it won't be free enough in the solution to go and attack at the nucleophile, which means we won't require polar protic solvent in this case, because having polar protic solvent will decrease the nucleophilicity of nucleophile, but we want strong nucleophile, so we will not take polar protic. Hence, the solvent required here is polar aprotic. So polar aprotic solvent will favor SN2. For SN1, you want carbocation to be formed, so the solvent should be polar protic solvent, which will help the dissociation of a carbon halogen bond and form carbocation. And not only that, even after formation of carbocation, that carbocation should be stabilized. So always a polar protic solvent stabilize the carbocation and the leaving group as well. Hence for SN1 you will need polar protic. E2, well, you need a stronger base. So again, the base, if it is stronger and if you take polar protic solvent, then the base, instead of attacking at the alkyl halide, it will accept H from the protic solvent. So ensure that you are not using polar protic. So I will say polar aprotic. Polar aprotic solvent will favor E2. And even again forming a carbocation. So any solvent that helps formation of carbocation and stabilize the carbocation will favor E1. So it has to be polar protic. Now guys, I want you all to focus at polar protic. Guys, I want you all to focus at SN1 and E1. Do you see any difference? Look, tertiary, secondary, primary, tertiary, secondary, primary. Weak nucleophile solvent itself, weak base solvent itself. Good leaving group, good leaving group. Polar protic, polar protic. So there is no difference as such when it comes to SN1 and E1. So question arises, if the question I've been asked to identify the given reaction will show which of the following mechanism, and the probable ones are SN1 and E1, then how are we going to distinguish between these two? So the simple way, see, in case of elimination reaction, the bond breaking takes place, right? I mean, the bond is broken for the proton as well as it is broken for the leaving group. In SN1, it's just the carbon and leaving group bond is broken. So bond breaking process is more in elimination. So bond breaking process is generally favored by the higher temperature. Hence elimination is favored by high temperature. So if the set of reactants for SN1 and E1 are identical, the only condition that will differentiate between these two is the temperature. So E1 reaction takes place at high temperature. SN1 reaction will be favored, E1 reaction will be favored by high temperature. So if you see condition for SN1 and E1 are identical, the only factor that will define that it is E1 is going to be high temperature. And one final thing to compare all of them together, substitution versus elimination, is rate expression. Rate expression. You may have some question related to rate expression as well, so we are covering it here. So guys, for SN2, rate of reaction is proportional to, I'm converting proportionality into equal to, is equal to molar concentration of substrate into molar concentration of nucleophile. So by changing the concentration of any of this, rate will also change. If you increase the concentration of either of this, rate will change. If you decrease the concentration, rate will also change. While SN1 rate of reaction is proportional to molar concentration of only substrate. So there is no effect of nucleophile as such for SN1. Hence we say weak nucleophile is good enough, solvent itself. Hence SN1 is also referred as solvolysis. For E2, again, rate is equal to molar concentration of substrate into molar concentration of base. E2 bimolecular elimination, and even just like SN1, rate of reaction is proportional to molar concentration of only substrate. So guys, this is a clear comparison of substitution versus elimination, and now you can revisit the question. See how helpful would this be for us. Okay, everyone here? Well, so the SN1 mechanism given already. We have to find out that which of the following observations are correct. The first one, the reaction is favored by the weak nucleophile. Yes. SN2 and E2 were concerted. So you need a strong nucleophile and strong base respectively. Here it is SN1, which means you need solvent itself as a nucleophile. So yes, weak bases are required. Weak nucleophiles are required. So A is correct. R plus would be easily formed if the substituents are bulky. Well, the question is about nature of substrate. So what does nature of substrate says? Nature of substrate says in SN1, if you have such alkyl halide which can form stable carbocation, the rate will be faster. So tertiary meaning bulky. So yes, R plus would be formed easily when the substituent is bulky. So B is also correct option. Then the reaction is accompanied by racemization. Yes, of course. When the nucleophile, which is solvent, is attacking at the deficient carbon of carbocation, carbocation is planar. If carbocation is planar, attack of nucleophile can take place from front side or back side. However, in reality, backside attack is more favored. So you get partial racemization, not complete racemization. But yes, racemization does take place. So C is also correct. And now when they talk about solvent, the reaction is favored by non-polar solvent. Is it? Absolutely not, because we want carbocation to be formed, and after formation of carbocation it will be stabilized by the solvent. So the polar protic solvents help stabilization of carbocation, not the non-polar. So option D is incorrect. So only correct option among this are A, B and C. Where do you see that, everyone? Look at option C. A, B, C are absolutely correct options. Right, everyone? Great. So based on this substitution versus elimination which we studied here, let's have a look at one more question. Well, they have given us some secondary alkyl halide, carbon to which bromine attaches secondary, but not to forget adjacent carbon is tertiary. Then on an arrow they have given us some solvent. Firstly, a given solvent which is polar protic and a substrate which is secondary. Based on this, what probable mechanism we can think of? We'll have to think about it. So simply, let's consider, we have to find out which mechanism is it going to follow. Is it going to follow SN2, or is it going to follow SN1, or it is going to follow E2, or is it going to follow E1? Guys, hold on. SN2, SN1, E2 and E1. Perfect. Okay. Now, first of all, when you talk about SN2, the nature of alkyl halide has to be least sterically hindered, either methyl or primary, at the most secondary. But the nucleophile has to be strong enough. When you say strong nucleophile, what does that mean? We refer strong nucleophile meaning to the anionic nucleophile. So is this nucleophile anionic? No. So SN2 is ruled out. Now let's talk about SN1. For SN1, the nature of alkyl halide has to be most favored will be tertiary or secondary. Least will be primary. Methyl won't show at all. So this is secondary. Okay, so substrate might favor SN1. But let's talk about the solvent. We say in case of SN1, the solvent itself act like a nucleophile and it has to be polar protic. So this is polar protic. So this could be SN1. So let's keep SN1. E2. Will this give you E2? Well, for E2, we have to look for any of these bases, either alcoholic KOH, ethoxide, methoxide, tert butoxide, or sodamide. I said these are the most commonly asked bases, the stronger ones. Do we have any of that? No, we don't have. So straight away E2 is being ruled out. Even. For even, secondary is fine. Solvent itself is also fine. So the probable mechanism has to be either SN1 or even. That is what I was talking about, dear students. When you have got two sets of reactants such that they are favorable for SN1 as well as even, how are we supposed to finalize which is the preferred mechanism? So when you compare SN1 and even, the only factor that distinguishes the two is the temperature. If temperature is mentioned, you will carry out even. If not mentioned, you will carry out SN1. So do we have temperature mentioned here? No temperature, meaning elimination is also not possible. So the preferred mechanism is SN1. So let's do SN1. What do we do in SN1? Well, SN1 is a two-step reaction mechanism, involves the formation of carbocation as step 1 in RDS. So let's say bromine left. From here, you got carbocation at secondary. So the substrate now is CH3, H, CH plus, and CH3. Guys, we studied something called as rearrangement reaction. So if the existing carbocation is not the most stable one, but if that carbocation has a scope of rearranging itself and form more stable carbocation than the existing one, then the rearrangement takes place either via hydride shift or via methyl shift or via ring expansion. So here, existing carbocation is 2nd degree, but the adjacent carbon is 3 degree. So when the adjacent carbon is higher degree than the existing one, then the rearrangement via hydride or methyl shift does takes place. So the entire hydride along with the bond pair will shift here. CH plus will become CH2 and this will become cationic carbon. So we say hydride shift took place and we got CH3, CH3 plus, this CH now became CH2 and CH3. Okay. Once we got C plus here, now the nucleophile solvent itself can attack at this cationic carbon through its nucleophilic atom, that is oxygen. So let's say here, if methanol attacks through its electron rich oxygen like this, followed by deprotonation. So effectively OCH3 will be attached here. So if you get OCH3 attached here, what product do you see will be formed? Here we go. Guys, do you see option C here? We are getting methoxy group attached to this tertiary carbon. Methoxy attached to the tertiary carbon. Hence, the right choice is option C. The right choice is option C here. Did you get that, everyone? So see, having clarity in substitution versus elimination is essential, because sometimes the substrate and the reagent would be such which might make you think about which precise mechanism it has to follow, and accordingly you have to work out on the mechanism to get the correct answer. Guys, that was all about substitution versus elimination. Well, one more question asked in 2017 JEE main. The increasing order of reactivity of following halides towards SN1. Well, they have mentioned the question is all about SN1. So different substrate have been given. So it's just the one factor that they're asking to compare with each other towards SN1. So find out order of reactivity. Just to help you out, I'm going to convert them into their precise structure so that it is easier for you to compare them. The first one is 2-chlorobutane. CH3CHCl. CH2CH3. Second one is N-propyl chloride. So that's secondary alkyl halide. This is primary, and then we have got paramethoxy benzyl chloride. Paramethoxy, this is benzene ring, by the way. I'm writing that first. Here we have got CH2 Cl, and then down here we have got methoxy group at para position, carrying 2 lone pair on it. All right. Well, now the question is, what is the correct order of reactivity of following? Guys, I want you to think about something. I'm taking short break of few seconds. What I want you guys to think about is, well, they're asking about SN1. What is the key feature? Think of it. Key feature is the formation of carbocation. So what will you do? You will try to convert all of them into their corresponding carbocation. Check which carbocation is more stable, because whoever's carbocation is going to be more stable, that will be formed faster. So its reactivity rate will be better than other. So here are the substrate. Think about it. I'm giving you few seconds. Come on, your time starts now. Are you all ready, everyone? Okay, so because the question is with respect to SN1 and the key feature of SN1 being formation of carbocation, I'm going to convert all of them into their corresponding carbocation, and I will check the stabilities of carbocation. Whichever carbocation is more stable will be formed faster, hence the rate will be highest. So here, if carbon-chlorine bond breaks, you will get secondary carbocation. If carbon-chlorine bond breaks, you get primary carbocation. And if this bond is broken, you're going to get benzyl carbocation. So that's primary. That's secondary. And that is benzyl. Secondary carbocation, assume chlorine is not there. So at this secondary carbocation, you have got total 2 alpha H's. This is 1 alpha, this is 1 more alpha. Total 5 alpha H's. So the carbocation is stabilized by 5 hyperconjugating structure. In case of N-propyl, upon departure of chloride ions, primary having 2 alpha H's here, so 2 hyperconjugating structure. So this is less stable than the first. Because first carbocation is more stable, its reactivity rate will be more than second. And here, benzyl carbocation, now what to say? Right in the beginning of our today's class, we mentioned first atom of the group, it carries lone pair, it shows plus M effect. So if there is going to be operation of plus M effect, this carbocation will be stabilized way more than any of these two. So third is the most stable carbocation, hence its reactivity rate will be highest. So 3, 1 and 2. Which option says so? 3, 1 and 2. Here we go. 3, 1, 2. The right choice is answer option B. So everyone, reaction mechanism, we made sure that we are comparing substitution versus elimination and several questions just to revise the concept that we did to understand the application of concept. Now after this, proceeding further with the next question. Hold on guys, I wanted to have a look at this first. Well, halogenation reaction, we are including some reaction part now here. So it could be from hydrocarbon, alkyl halide, or you may have some question from alcohol, phenol, ethers, anything it could be. Okay, if time permits, we'll go even beyond that and try to do some carbonyl compound question as well. But keeping timeline in mind, I don't think so we'll have really time to go ahead with that, but at least few questions from important reactions here. So what halogenation reaction is? If we have got alkene and if we carry out addition of halogen, which is generally carried out in presence of a non-polar solvent, it results in the formation of vicinal dihalide. Okay, the most important feature of this reaction is this reaction involves anti-addition. Let us try and understand this anti-addition. Okay, let's say I've got some alkene here. So carbon carbon double bond. I'm representing a precise three-dimensional arrangement. We don't know what groups are present here, but these two bonds are coming outside the plane of paper, the one which are represented by the solid wedge, and the other one indicates the bond going behind the plane of paper, that is hatch wedge bond. Okay, and we are carrying out halogenation. So let's say this is the X2 molecule. X bonded to another X. Now every X carries 3 lone pair. Okay. Now look, ideally speaking, because both are identical atoms, there is no electronegativity difference as such, so development of polarization does not take place that easily. However, we must not forget, between the two nuclei of halogen atom, there is an electron density of 2 electrons, that is bond pair, and electron density is always movable. Hence, for some instance of time, it might happen that electron density is shifting in favor of one of the halogen atom. Let's say for some instance it shifted towards another halogen. Let's say this is number 2. So this halogen will acquire delta minus and this will become delta plus. The moment it becomes deficient halogen atom, pi bond breaks towards one of the carbon, because alkenes are always pi bonded nucleophile. Being pi bonded nucleophile, they always look to attack at the deficient species. So alkene is attacking at the electrophilic halogen atom by breaking its pi bond, so making this carbon electron rich. So this carbon attacked at the halogen. As soon as this attack takes place, other halogen leaves in the form of X minus. Now see, when this pi bond is broken towards carbon, this carbon is becoming deficient, but before it could exist in the form of carbocation, the same halogen attacks at this carbon. So whatever arrow I have shown, everything is taking place simultaneously. Let's have a look at one more time. Look at it one more time. What happened? Because for instantaneous dipole, this carbon became deficient, and alkene being pi bonded nucleophile, it immediately attacked at the deficient carbon with the simultaneous loss of X. The moment the attack took place, the carbon became deficient and the lone pair of the same halogen attacked here. So out of 2 halogen, one X in the form of X plus has attacked at the carbon carbon double bond from one of the side of double bond, because this molecule is planar. But because X have been added in the form of X plus, this first step is called as electrophilic addition. Hence, halogenation reaction is electrophilic addition reaction. Well, so what happened? So this molecule got converted to a carbon-carbon single bond. Halogen attack, let's say, from below the plane, carrying 2 lone pair intact, positive charge on it. And now these 2 bonds will be as it is, just that because X is attacking from below the plane, this 2 will shift a bit up. These 2 bonds shifting a bit up. So that's how we can represent it. Likewise here as well. Okay. Now once this is formed, this is called as cyclic halonium ion. This cyclic halonium ion will now be attacked by X minus, which had left in the step number 1. So everyone here, look, the X minus which left earlier is now available to attack at this carbon, but where the attack would take place. Guys, not to forget, this is 3-membered cyclic ring, and having studied earlier, 3-membered cyclic rings are always unstable because they have lot of angle strain. Hence, in order to release such angle strain, they would always want to open up the ring by breaking any one of these 2 bonds. Hence, the probable attack of X minus might take place at this carbon or might take place at this carbon. So both attacks are equally probable. Hence, we are assuming this is attack via path A, this is via path B. So we'll be getting 2 product, one via path A, other via path B. Now what kind of product are we going to get? Let's have a look at it. If X minus is attacking via path A, so let's call this is carbon 1, this is carbon 2. The incoming X minus is attacking at carbon number 1 from above the plane, so this bond will break. Everyone, because of this, look, since attack of X minus took place from the side which is opposite to the existing halonium ion, because the attack of X minus took place from the side opposite to the existing halonium ion, this kind of attack is what we refer it as anti-attack, or you can call it as anti-addition. Let's call it anti-attack. Okay, so if X minus attacking at carbon number 1, this bond have been broken towards X, so this product obtained will look like this. This is carbon number 1, so X minus attacked at carbon 1 from above the plane, that's X. So these two bonds will flip downward, which in Sahor's projection can be represented like this. If this bond breaks, the existing X will be below the plane here. So these were the two X's. You can see they're on the opposite side. That's why we tried representing in 2D on the opposite side. And these two bonds as it is. If attack took place via path B, then the incoming X minus will be attacking at carbon number 2 from above the plane, and existing halogen will go below the plane at carbon number 1. So structurally it can be shown like this. This is your X attacked here. These two bonds will flip downward. This bond will break, pointing downward, remaining 2 are as it is. Okay guys, so these two are product obtained. Now whatever Sahor's projection of the two products obtained, we have to relate them and find out their isomeric relation. So sometime you might see the two products obtained are enantiomer, because both enantiomers are of the same compound, obtained in equal amount because attack was equally probable. We say this is a racemic mixture. And sometime it might happen the product obtained is a meso compound. So the point to be understood here, the starting compound, imagine if we have got some alkene having specific stereochemistry, maybe cis or trans. When you carry out halogenation in presence of non-polar solvent, which follows anti-addition, and you get a product of a specific stereochemistry. So a particular stereoisomer, when produces specific stereoisomer, either racemic mixture or meso, such reaction where your starting compound, the substrate was a particular isomer, cis or trans, and produced a specific stereoisomer, we call it as a stereospecific reactions. So when we have any such kind of reaction, how are we supposed to identify the stereochemistry of product? Because you will see in one of the previous year question, there was a question where they asked how many isomers obtained by addition of bromine to, let's say, trans 2-butene. So I'm going to share one simple trick to find out how many and which isomers will be formed. Stay tuned and pay attention here, everyone. Before you understand or before you learn the trick, first understand some basic things, which is look, whenever I use term cis or syn or same side, cis, syn or same side, I'll call it plus. Okay. Whenever I say trans or anti or opposite side, I will call it minus. Okay, let's put this back in a cloud. Cis, syn, same side is plus, trans, anti, opposite side is minus. Okay, and then we'll do simple mathematics. Plus plus is plus, minus minus plus, plus minus is minus, or minus plus is minus. That's what we're going to apply here. Now how does that work is, look, let's say the first example which is given to us is addition of bromine to cis 2-butene. Let's say cis 2-butene. In simple two-dimensional structure, we write it this way. So this is cis 2-butene. to which we are adding bromine in presence of non-polar solvent CCl4. Okay, so addition of bromine to butene is going to produce what kind of compound? That is what we have to find out, whether it's going to be just one isomer or two isomer. Okay, how do we do that? Look, let's apply the simple trick. Since it is cis, I'm going to consider it to be plus. We also know the fact addition of bromine to alkene follows anti-attack, isn't it, everyone? So this is definitely an anti-addition. If it is anti-addition, for anti we use minus. Now plus and minus, the product which you are going to get is going to be minus only. What is minus meaning? Opposite. Whatever product you get, you check the last term, same or opposite. Now minus meaning you are going to use it as opposite. What is opposite? The two new bromine that you are adding across carbon-carbon double bond should go on the opposite side in the Fisher's projection. Since your answer is minus, I'll say the two bromine that I'm adding across carbon-carbon double bond should go on the opposite side in the Fisher's projection. So how are we going to represent Fisher's? Look, your compound is a 4 carbon, 1, 2, 3, 4. Bromine will be added across carbon-carbon double bond, so unsaturated compound will become saturated, and the two bromines are going to be at carbon number 2 and 3. So basically, at least I know that the product is going to be in the Fisher's projection containing 4 carbon like this. First is methyl, last is methyl. Let's put that. I'm writing it one more time. You'll understand why am I putting it one more time. First and last carbon is methyl. Okay. And now, look, we said the bromine is added at carbon number 2 and 3, meaning I'm going to add bromine at carbon number 2 and 3. But where I'm going to add? Whether both bromine on the same side or whether both bromine on the left hand side. How are we going to do it? So plus and minus is minus. Minus meaning opposite, meaning two newly added bromine should go on the opposite side. Meaning, if one bromine I'm putting it to the right at carbon number 2, at third it has to be put to the left. That is a simple trick to get the answer. But how can we certainly say that at the carbon number 2 bromine has to be right? It is also possible at carbon number 2 bromine could be to the left. Okay, no problem. So that is another combination. Then at 3 it has to be to the right. So these are the two possibilities we get. That's why I took two Fisher's projection. And the remaining valency are going to be fulfilled by what? The hydrogen atoms. So I'm putting those H's here. 1 and 2. 1 and 2. And now find out the relation. How do we do that? You look for this carbon. Is it chiral? Yes, it is chiral. Is this chiral? Yes, it is chiral. Do we have any plane of symmetry? No. No plane of symmetry, meaning this is optically active. So this is optically active isomer of 2,3 dibromobutane. Likewise here, this is chiral. Even this is chiral. No plane of symmetry. So this is also optically active isomer of 2,3 dibromobutane. So both are optically active isomer of 2,3 dibromobutane. If both are optically active isomer of 2,3 dibromobutane, then see their mirror image relation. Are they mirror images? Well, if I consider and mirror here, these two are certainly related to each other as a mirror images. When two compounds are optically active isomer of the same molecule, that is 2,3-dibromobutane, and if they are related to each other as a mirror images of each other, then I will say these two are pair of enantiomer. Because this pair of enantiomers are formed with the equal probability of path A and path B attack, I will say this product is nothing but racemic mixture. This is the racemic mixture. So guys, you see, a particular stereoisomer produces specific stereoisomer, that is racemic mixture, and this is stereospecific. Now what I was talking about earlier is this question. See, 2017 previous year JEE question which asks us the number of stereoisomers obtained by the bromination of trans-2-butene. Imagine if the same question would have been number of stereoisomer obtained by bromination of cis-2-butene. So this would have been our question. So in case of cis-2-butene, addition of bromine producing two isomer. One is dextro, other is levo, because they are enantiomers. So answer would have been 2. Now let's try and find out what is our answer here. The number of stereoisomers obtained by bromination of trans 2-butene. So now I have to consider trans 2-butene. Well guys, trans 2-butene. Trans V1, right? So that is CH3 here and H here. So we note it down that this is trans, to which we are adding bromine in presence of CCl4. Guys, put down all the important feature that we have noted earlier. Trans meaning, well, where is that? Trans meaning minus. Anti-addition, anti meaning again minus. Okay. So trans is minus. Anti-addition, addition of halogen will always be anti-addition. So anti-addition is also minus. Minus minus meaning our product would be plus. Okay. Plus meaning same side. So the two newly added bromine will be put on the same side in the Fischer's projection. That's what it means. So let's say this is one. I'm writing two Fischer projection because we know that there are two paths will be followed, right? See, it's a compound of 4 carbon. 1, 2, 3, 4. Unsaturated compound upon addition of bromine will become saturated. So I made it saturated already. First is methyl, fourth is also methyl. So let's put that first. Following the guideline of Fischer's projection, that's methyl. Even this is methyl, everyone. CH3 and CH3. Now, what we said earlier, plus meaning same side. So the two bromine added has to be on the same side. Same side meaning I may put both bromine on the right hand side in the Fischer's, or I may put both bromine on the left hand side in the Fischer. Let's do that. So bromine. Remaining valencies of course would be satisfied by H, or you can put two bromine both on the left hand side. So I'm putting both of them onto left hand side. Now what is the relation between the two? Well, firstly, is this a chiral carbon? Yes, it is a chiral carbon. Even this is a chiral carbon, right? So two chiral carbon present, but now there is a mirror plane of symmetry. If I consider an imaginary plane cutting this molecule through this such that it is dividing the molecule into two equal halves which are mirror images of each other. Such compound having two chiral carbon having mirror plane of symmetry, meaning it is optically inactive due to internal compensation, is what we call it as meso. So this compound is meso. Similarly, other compounds, see, even there is a chiral carbon here, a chiral carbon here as well, and a mirror plane of symmetry which will make even this compound meso. So these are one and the same thing. These are not two different isomer. They are one and the same thing because both are meso. See, 2,3 dibromobutane, 2,3 dibromobutane. Imagine if I rotate the molecule 180 degree, keeping it in the same plane. I said imagine if I rotate the molecule 180 degree within the same plane, this molecule will be nothing but this only. So they are one and the same thing. So this is nothing but meso 2,3 dibromobutane. So in earlier case we got two isomer, both were enantiomer. Now these are not two isomer, they are one and the same thing. That is a meso compound. So this is 2,3 dibromobutane, which is just one isomer. So how many number of stereoisomer obtained? Just the one. Understanding, everyone? Just hold on, guys. All right. So yes, How many isomers are we getting? One isomer, which is nothing but a meso compound. Right, guys? So that's how halogenation of alkene will give you some product. We took both the example. In case of cis, what are we getting? In case of trans, what are we getting? Just one extra thing I would like to tell you. Look, imagine instead of trans to butene, imagine if I would have taken trans to pentene. Okay, just giving you idea. So pentene would have been 1, 2, 3, 4 and 5. So this would have been, instead of CH3, it would have been C2H5. So if you replace one methyl by C2H5, here also one methyl would have been C2H5. Right? Here also one methyl would have been C2H5. Remember, in that case, this wouldn't be meso. Because if these two groups would have been ethyl, this won't be a mirror plane cutting the molecule into two equal halves. No, that's not a mirror. Bromine, bromine, hydrogen, hydrogen is fine like a mirror. But against methyl, we have got ethyl now. So when your alkene is unsymmetrical with respect to the position of double bond, 2-butene we say symmetrical with respect to position of double bond, meaning you have got 4 carbon, double bond is between 2 and 3. So symmetrical with respect to position of double bond. In that case, this racemic and meso is possible. If your alkene with respect to position of double bond is unsymmetrical anyways, so whether you take cis or trans, in that case you are going to get racemic mixture only. See, when you had a ethyl, this is not a mirror plane of symmetry. So this is optically active isomer of 2,3-dibromopentane. This will also be optical active isomer of 2,3-dibromopentane, which are mirror images of each other. So that is racemic mixture. So what I'm trying to tell you, if your alkene is symmetrical with respect to position of double bond, meaning if double bond position is such that it is having two identical sides on both the sides, in that case, taking cis will give you racemic mixture, trans will give you meso compound. But if your alkene with respect to position of double bond is not at all symmetric, meaning if it is asymmetric, then whether you take cis or trans, your product is going to be racemic mixture only. Because in spite of having two bromines in one line on the same side of Fischer projection, because one is going to be methyl and other is ethyl or anything else which is asymmetric, it will always be a racemic mixture. Alright guys, well, I want you all to have a look at this carefully for a moment. Well guys, I hope you understood this concept. Just remember that whenever you have got an alkene and you're carrying out halogenation, you can use this simple trick and find out the answer accordingly, keeping the fact in mind whether this is symmetric or unsymmetric alkene. So guys, that was all about our organic chemistry concept. Of course, we couldn't cover many topic as such due to limitation of time, but we have made sure that whatever are the important concept from the first few important chapter like GOC, isomerism, reaction mechanism and alkyl halide, we tried covering that. So I wish you all the best and I hope that you have understood what we have studied today. We shall meet soon, very soon with some more such sessions. And guys, again wishing you all the best. I'll see you soon. Thank you so much for attending the session. Thank you everyone.
Hello, dear students. So, how are you guys? First of all, give me a thumbs up who are watching it right now. Audio and video is clear or not? Hello. Am I audible? Am I visible? And are you guys awake? Come on, give me a thumbs up right away. Whoever watching is. And we are going to start now physical chemistry of session. Okay. Yes. Come on, give me a quick thumbs up. And then we will start right away. So what we are targeting, that your JEE mains is about to come. So we are at the end game right now. So what I am trying to target here, to give you maximum revision, maximum content in the least possible time, because time is a resource that we don't have much right away, right? But remember this, even God doesn't help those who don't help themselves. So first of all, you have to help yourself, then whole physics wala family is with you, right? And after that, the God above us is watching us and is trying everything to help us. Yes, MIQ means most important questions, MIC means most important concept. Yes, chakma. Okay, so what we will do in physical chemistry, that we will do a formula sheet revision, that what are the important formulas of physical chemistry, and I am targeting those questions which are most probable to come in your upcoming JEE exam. Okay, and before starting, I just want to know how many of you have watched Bahubali movie. How many of you have watched Bahubali movie, in the scene where original Bahubali and all the Sena went to war with Kalke? Remember that scene? And what the Shivgami told Kalke. So this is your fight, right? JEE mains is your fight. Your goal, your 1 year hard work is going to fulfill right now after JEE mains. So this is your fight and you have to push yourself. You have to keep fighting until you are selected. Because if you want to be an engineer, see, engineering college are many, almost in every street there is an engineering college like a mushroom. But if you want to be an engineer from a reputed good college, you want to have a good start, you want to see yourself in next 5 years at a good position, then you should work hard for this. Because be very clear that this is not an easy exam, but this is a conceptual, this is a logical exam, and you have to fight for it. You have to fight for it. So even if your body is tired, I will repeat the Shivgami dialogue in my sense. Even if your body is tired, even if your mind says that this is enough, you cannot do anymore, you have to keep pushing. You have to keep fighting. Okay? You have to keep pushing yourself. You have to keep hustling, that you have to do it. You have to say to your mind that no, this is not my limit. My limit is much beyond that, much more beyond this. So I am going to keep fighting. I am going to keep studying. I am going to do whatever it requires to have me a decent rank in JEE mains. Right. Okay. So we will start with the physical chemistry in the NCERT order. Okay. First of all, our first chapter is the mole concept. In the mole concept, I can divide the chapter into 4 parts and 4 formula diagram. The first is mole analysis. The second is stoichiometric analysis. The third is concentration term. And the fourth is empirical and molecular formula. See, for mole conversion, you are required to know these 3 formulas. These 3 formulas, first of all, conversion of mole. And for this formula, the short trick is that whenever you want to find mole, you have to divide by 1 mole quantity. Mole, divide by molar mass, divide by Avogadro number, divide by 22.4 liter. And whenever you want to find anything else from mole, you have to multiply. You have to find mass, mole multiplied by molar mass. You have to find number of particle, mole multiplied by Avogadro number. You want to find volume of gas, mole multiplied by 22.4 liter. So the mole conversion is very easy. You have to divide in order to get to the mole, and you have to multiply in order to get beyond the mole. Beyond the mole. Second is that whenever you want to have the mole conversion, mole interconversion, suppose you have a molecule also has so many particles inside it, whether it's atom, electron, proton, neutron, anything else. So whenever you want to go from a bigger particle to inside of that particle, you are going to multiply by the atomicity. What is atomicity? The number of particles contained in a single molecule. Suppose you want to find the mole of electron. So you will multiply the mole of molecule to mole of or number of electron in a molecule. Yes? Yes, Professor H. Mishra, what is your doubt? Tell me. After that we have stoichiometric analysis. This is called as stoichiometric analysis. And for that you should know the balance equation. If you have the balance equation, then all the time mole and their stoichiometric coefficient ratio is equal for everything. So mole of A, that is reacting in the reaction, divided by P, mole of B divided by Q, mole of C divided by R, and mole of D divided by S, that is mole divided by stoichiometric coefficient, is going to be equal for all. But for that you always should have a balanced chemical equation, right? And if in the question you are given with more than one quantity, you have to compare their mole, and whichever is the smaller will automatically become their limiting reagent. Ayush Kumar, this is not an Hindi channel, so I think we have to compensate with the English only. Okay? Okay, so you have to compare their mole and find one which is having the smaller one ratio wise will automatically become the limiting reagent. So what you have to do whenever you have a reaction, first of all convert every quantity into mole, and then you can apply the stoichiometric analysis. So these three diagrams are required in order to solve the question based on chemical reaction, right? Okay, then moving to the next section, now we have concentration term. And this is the general formula. If you don't want to remember all other formula, you can directly remember the concentration term. Or concentration defines the ratio of quantity of solute present in the given quantity of solvent or solution. This amount can be in mass, can be in mole, can be in volume as well. Similar with this amount. So if you have mass by mass, that will become mass concentration. Volume by volume, that will become volume concentration. Mole by volume, that will become molarity. Mole by mass, that will become molality. Equivalence by volume, that will become normality. So similar, all concentration terms are similar. All concentration terms are similar. All have same formula, amount of solute divided by total amount of solvent or solution. Only one concentration term is there which has solvent, and that is molality. Except all the concentration terms involve the amount of solution in the denominator. For percentage, as percentage is part of 100, we multiply by 100. For mole fraction, as fraction is part of 1, we multiply by 1. For molarity, if volume is in ml, we multiply by 1000. If mass is in gram, we multiply by 1000 to convert it. Right? Yes. Professor H. Mishra, we will definitely discuss about the proof of Avogadro number, but this is not the time. You don't have that much time if you are JEE aspirant. And another, we have a strength gram per liter, that also means gram divided by liter. So every time amount divided by total amount. One more thing that sometimes is asked, whether any concentration term having mole and mass is temperature independent. They are not changed with temperature. But the volume is temperature dependent. So if any concentration term has volume, it becomes temperature dependent. Otherwise, it is temperature independent. That is, if you don't see volume in the unit or in the formula, the term is going to be temperature independent. The term is going to be temperature independent. Yes, that's correct. So molality, temperature independent. volume, 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 rest all three are temperature dependent. Mass by mass, temperature independent. Volume, temperature dependent. Mole by mole, temperature independent. So very easily you can find which is temperature dependent, which is temperature independent. Vedant Bhandari, you just have to go through the formula, and the more you use the formula, the more easier it is to remember. If you haven't used these formula up to this point, then you have to mug it up. But the trick is, every concentration term is having amount divided by total amount. Amount divided by total amount divided by total amount. Okay? Now moving to the next section. Next section we have concentration conversion. This is called concentration conversion. These are many times required during a question. During a question, that whenever you have molarity and percentage composition, you can convert them by use of density. By use of density. So if you are given mass composition, you can convert that into molarity, and if you are given molarity, you can convert that into percentage composition. Percentage composition. Similarly, you have for molality and molarity. Small m is mole per kilogram, capital M is mole per liter. Try to focus what I am saying and try to absorb as much as you can, and surely your score will improve in the JEE mains. Okay? Don't try to miss a single line, because I am not repeating so much right now. So whatever I am saying, try to absorb it as much as you can. This is last minute revision. Last minute has a significance. And if you have mole fraction, you can convert mole fraction to molality and molality to mole fraction. Just remember, these three conversion formulas are enough, and one and second have molar mass of solute here, but the mole fraction conversion has molar mass of solvent. So be cautious about this. When you are converting mole fraction to molality and vice versa, you are going to use the molar mass of solvent, not molar mass of solute. For empirical formula, we have to just simply find the simplest mole ratio, and empirical formula calculation involves the determination of molar mass. For that, usually they give you vapor density. Usually they give you vapor density, which is twice of vapor density is equal to molar mass. Okay. Now we are going to see those questions which are asked from this chapter in the previous year JEE trend. Let's see. First question is about a stoichiometric question. The target is you have to try this to solve this question first by yourself. Just try to solve it and see you can find the answer or not. Try to solve this question. We are given with hydrogen cyanide. We are given with hydrogen cyanide, which is prepared from this particular reaction, ammonia, oxygen, methane, in presence of platinum to give you hydrogen cyanide and 6H2O. We are given with the reaction vessel content 11.5 gram ammonia, 10 gram oxygen, 10.5 gram methane. Okay? Yes. Yes, this class will be available after the live streaming as well. Then what is the maximum mass in grams of hydrogen cyanide that could be made assuming the reaction goes to completion? First of all, if you read this question, you will see we have a balanced equation. So we can use stoichiometry. We are given with the amount of this, this and this. Whenever you are given with amount of more than one reactant, Vedant, I already considered normality, and I don't think formality is that much important. So whenever you have an amount of more than one reactant, first of all you are going to find limiting reagent. How we will find limiting reagent? Let's see. Mole of ammonia. Ammonia is mass 11.5 divided by molar mass. This is mole of ammonia. I use the mole formula directly. Mass divided by molar mass. Then we have 10 gram oxygen. So mass of oxygen divided by molar mass of oxygen. Many times you students do mistake in taking the molar mass of oxygen. Whenever you are talking about oxygen gas, you are talking about molecule. So you are talking about the 32 gram per mole as the mass. So this should not be mistaken. Mass of methane is 10.5 divided by 16, which is the molar mass of methane. But that is not enough. For mole, you have to take the coefficient as well. For mole, you have to take the coefficient as well. Coefficient of ammonia is 2. Coefficient of oxygen is 3. And coefficient of methane is 2. Then you have to compare all of them. I can see this. This is, let's say, 11.5 divided by 34. 10 divided by 96. And 10.5 divided by 32. As the numerators are not very much different, so I can compare that this 10 by 96 is going to be the smallest. So just by comparing the mole coefficient ratio, we could directly find which one is limiting reagent. Which one is limiting reagent? So this is going to be limiting reagent. So first of all, in stoichiometry, we may have to find the limiting reagent. Now, we will solve by the limiting reagent. We got the oxygen ratio, this is methane ratio, and this is ammonia ratio. Oxygen became our limiting reagent. That means the oxygen ratio should be equal to hydrogen cyanide ratio. Oxygen ratio should be equal to hydrogen cyanide ratio. So mole of hydrogen cyanide divided by 2. What we did, we find the limiting reagent by comparing the ratio. Yes, thermodynamics. I am trying to repeat again. We compared the mole ratio and found the one which is smaller, that became limiting reagent, and then we can use the limiting reagent ratio to equate it with product mole by coefficient ratio. So from here, mole of SCN, that will come 10 by 48 mole. So mass of SCN, that will come as 10 by 48 multiplied by molar mass of HCl. Hydrogen 1, carbon 12, 13 plus 14, 27. So that is approximately 5, closer to 5. The option which is closest to 5 is B option. That became our answer. That became our answer. Right? So the question was very easy, I think. Okay. Moving to the next question. So this is again a stoichiometry based question, a direct question. And try to solve this question. We are trying to cover as much as important question as we can. An amount of 2 mole of KClO3 is decomposed completely to produce oxygen gas. How many moles of butane can be burnt completely by the oxygen gas produced? See, if you read this question, you are going to find that this is a sequential reaction type question. What happened here? KClO3 decomposed, and that gave you oxygen gas. And the same oxygen gas was used to combustion of butene, not butane, combustion of butene to give you product, right? The same oxygen has been used here. So these type of reaction are called as sequential reaction. Product of one reaction became the reactant of the second reaction. Let's see if you have found the correct answer or not. So first of all, we will write the balance equation. A smarter student can do this by POAC as well if you have read it. Principle of atomic conservation. If we balance 2, 2, 3, any hydrocarbon upon combustion will produce CO2 and H2O. Here carbon is 4, H is 8. Total we have 4 to 8 plus 4, 12 oxygen, so 6 O2. Now we can see here 2 mole of KClO3, because we are given with 2 mole of KClO3, will produce 3 mole of oxygen. So that means here oxygen we have is 3 mole. Now we are going to apply the stoichiometry. Mole of butene divided by 1, mole of oxygen divided by coefficient of oxygen, which is 6. So mole of butene will come as 0.5. That means 0.5 mole of butene can be combusted under the given condition. Option A will be the correct answer. Very good, Vedant. Very good. Yes, Garvit. Okay, moving to the next question. A gaseous alkane is exploded with oxygen. This is called as eudiometry. For gas, you know that. I think all of you know that. For gas, PV is equal to mole into RT. So similar to stoichiometry as for mole, For gas, we can apply the stoichiometry for volume as well as the stoichiometry for partial pressure. For gaseous compound, we can apply the same stoichiometric analysis for mole, volume as well as partial pressure. Okay. Now see the option for this. First of all, they are saying a gaseous alkane. If it is alkane, the formula is going to be CnH2n plus 2. Is exploded with oxygen. Okay, no problem with that. So this will give you CO2 and H2O. Right? Now they are saying if alkane is the formula, this should be N. This should be N plus 1. So we have a total of 2n plus n plus 1, that is 3n plus 1 by 2. This type of questions are most expected for JEE mains from this chapter. This type of question of volume analysis, pressure analysis. Yes. Yes. So we are given with the volume ratio of CO2 and oxygen. Let's see. Similar to stoichiometry, volume of oxygen divided by coefficient of oxygen is equal to volume of CO2 divided by coefficient of CO2. So from here we will get volume of oxygen divided by volume of CO2 will be 3n plus 1 divided by 2n, and this ratio oxygen divided by CO2 volume ratio is given as 7:4. So that will give you 12n plus 4 is equal to 14. 12n plus 4 is equal to 14n. So 2n is equal to 4. N is going to be 2. That means that gaseous hydrocarbon should be C2H6. C2H6. Yes. Oh mama, we are discussing concept along with formulas and some of the questions. Yes, session 2 is starting from 25th of July. I think that has been that is given in the NTA notification right in the today's morning, right? And admit card are I think available from the tomorrow onwards. Yes. Okay, now moving to the next chapter, which is structure of atom. See, structure of atom is having mainly 4 parts. One is photoelectric effect, E is equal to W plus K. Second is Bohr model. Third is de Broglie equation, Heisenberg part. And fourth is quantum number. The majority of problem that can come in your JEE exam is I think from quantum number or from spectral lines. Quantum number or spectral line. So let's see. For Bohr model we have the formulas. This is the Bohr quantization condition. MVR is equal to NH by 2 pi. Radius of nth orbital is A naught multiplied by n square by z, where A naught is called as Bohr orbit or Bohr orbit's radius. This is the radius of first orbit of hydrogen atom. Okay, this is the velocity 2.18 into 10 to the power 6 z by n meter per second. The total energy of electron in electron volt unit minus 13.6 z square by n square. The kinetic energy of electron is equal to total energy in magnitude, and the potential energy is double of total energy. Number of spectral line when electron goes from one state to another is delta n plus 1 by 2 for the emission line. So delta n is n2 minus n1, and number of absorption line is delta n. Again delta n is n2 minus n1. So when electron goes from lower state to higher state, there is going to be absorption lines or absorption photons. When electron come from higher to lower state, there is going to be emission lines or emission photons. Okay. For Lyman series, we have n to 1 ultraviolet range. Balmer series is n to 2 visible range. Paschen series is n to 3. IR, that is infrared series. And Brackett series is n to 4, again infrared. And P fund series is n to 5, that is again in infrared region. So we study these five series for hydrogen spectrum. Lyman, Balmer, Paschen, Brackett, P fund. Another series is also there, Humphrey series, which is not of much importance. Okay. For any spectrum or any transition, you can find the energy gap by using N1 and N2 transition. So these are the formulas of energy of photon, wavelength of absorbed or emitted photon, or wave number of absorbed or emitted photon. These are for the transition. Transition means when electron moves from N1 to N2 or N2 to N1. Both of time we are going to get the same energy photon, only the difference is there that from low to high the photon is going to be absorbed, from high to low the same photon is going to be emitted. So we have energy 13.6 Z square 1 by N1 square minus 1 by N2 square electron volt. Alternatively, this is a very useful formula. In this formula, what you can do, you can directly convert any wavelength, whether it's of photon, whether it's of electron, any wavelength to energy, energy to wavelength, by using the formula 12375 upon lambda. Wavelength should be in angstrom, and energy is directly found in electron volt. So this formula is going to be very useful in MCQ type problem, because in MCQ they don't ask in joule, but they give you wavelength in angstrom. So what we did, we used this formula, the Boring method, E is equal to SC by lambda. Then we convert this joule energy to electron volt. So this is a Boring way. What we are going to do, we are going to smartly convert electron volt to wavelength and wavelength to electron volt directly. Okay, right. Then we have de Broglie equation. Lambda is equal to h by momentum, and that can be written as in terms of kinetic energy as well as in terms of voltage difference. And this is again a very useful formula. This formula came by merging the Bose quantization condition and de Broglie equation. And many times questions have been asked using this formula. 2 pi r, that is circumference of any orbit, is n times lambda, where lambda is the de Broglie wavelength of electron. Using this formula, you can relate the kinetic energy of electron to its wavelength, the momentum of electron to its wavelength, and 2 pi r, you can use this equation to find momentum and other things. Structure of atom. You are dreaming to go to IIT Bombay and you are asking what is SOA? It's structure of atom. Okay, no problem. Then we have Heisenberg principle. This is the original form, that uncertainty of position and momentum is more than h by 4 pi. This momentum can be converted to uncertainty in velocity. There is another form, energy and time. That uncertainty is also greater than or equal to h by 4 pi. This came from modification of the first one. Okay, modification of first one. So Heisenberg principle. After that we have quantum number in this chapter. What? Oh mama, what we have to explain again? So quantum number, in this we have two important quantum numbers. This is called as principal quantum number, which tells us about the main shell of electron. This tells us about the main shell of electron, and whenever you have to find some information inside a shell, you are going to use this form. Suppose you have to find how many orbitals are inside fifth shell. How many orbitals? 5 square 25. How many electrons are possible in 10th shell? 10 square by 2, that is 200 electrons. So whenever you want to know the subshell, orbital or electron inside a shell, then you are going to use these three formulas. Okay? Which one? Heisenberg principle tells us about the uncertainty. Uncertainty means we cannot determine the position and momentum of any moving particle, not only for electron, any moving particle inside the atom. We cannot find its exact position and exact momentum. So this momentum and position uncertainty product is greater than or equal to h by 4 pi. Momentum can be written as mass multiplied by uncertainty in velocity. From there we get this formula, h by 4 pi m. Momentum can be written as force multiplied by time uncertainty. Force multiplied by distance is nothing but work or energy. From there we get this formula. Okay? Okay. The second quantum number that is very important is azimuthal quantum number, which tells us about the subshell of electron. The subshell of electron. So whenever you want to know any information inside a subshell, you are going to use the formula of L. So don't be confused when you have to use N, when you have to use L. This formula also gives number of orbitals. This formula also gives number of orbitals. This one gives the number of orbitals inside a given shell like K shell, L shell, M shell, and this formula gives the number of subshell within a particular number of orbitals within a particular subshell. Like P subshell will have 3 orbitals. D subshell will have 5 orbitals. Okay, so whenever you want to know inside subshell, you are going to use the formula of L, and whenever you want to know inside a shell, you are going to use the formula N. Okay, yes, and remember, the magnetic properties are also asked. If there are some unpaired electron, that is going to be paramagnetic. If there is no unpaired electron, the molecule or the species is going to be diamagnetic. The magnetic moment can be calculated by under root n plus 2, where n is number of unpaired electron. N is number of unpaired electron. So this is your quick summary about this chapter, which is structure of atom. Okay, shall we move ahead? The de Broglie equation. This is obtained by merging MVR. Let me give you a quick theory. MVR is equal to NH by 2 pi, right? And MV is equal to H by lambda. Divide these two, you will get this desired equation. Which is 2 pi times of radius of nth orbital is equal to n lambda. Okay? Yes. Bm means Bohr magnetron. Bm is the unit of magnetic moment, which is Bohr magnetron. This is the Bm. So Bm is the unit of magnetic moment. This mu represents magnetic moment. Shell is the region inside which we found subshells. Inside subshell we find orbital, and orbitals are the region where finding probability of electron is maximum. Okay, let's see some of the question from this chapter now. Okay, I want you all to solve this question, because I know most of you will do give the incorrect answer. I want all of you to solve this question. Consider this a challenge. To yourself. Let's call it a challenger problem. The number of possible spectral lines in bracket series. Bracket means electron should come from higher to 4. In hydrogen spectrum, when electron present in the 9th excited state, that means electron is actually present in 10th state. Because n is equal to 2 is the first excited state, n is equal to 3 is the second excited state, n is equal to 5 is the 6th excited state. Yes, Sarthak. Come on, solve this question, everyone. Everyone, pick your pen, pick your paper and solve this question. You want to crack JEE, you have to solve this question. Let's see how many of you get the correct answer. Till now, I'm making the diagram for fun. This is n is equal to 10, n is equal to 9, n is equal to 8, n is equal to 7, n is equal to 6, n is equal to 5, n is equal to 4, n is equal to 3, n is equal to 2, and finally n is equal to 1, and your time's up. That doesn't matter, Mukesh. We are alone. Everyone is alone for his own. right? Okay. Sarthak is saying B. Modi ji is also saying B. Oh Mama is also saying B. And let me tell you, B is incorrect answer. B is incorrect answer. See, we don't only have to learn the formula, we have to understand their meaning as well. That you got correct, that delta n plus 1 by 2 is the formula for emission line. Electron from 10 is coming to be 4. So 10 minus 4 should be 6 multiplied by 6 plus 1, that is 7 by 2. So that will give you, just a minute, 10 minus 4, 10 minus 4, that is 6, okay, 21 lines. That is given you 21 lines, first thing. Then you said, okay, 10 minus 1, 10 minus 1 is 9 by 10 by 2, that is giving you 45 lines, right? You can use this formula like two way, 10 to 4 for bracket series and 10 to 1 for the all of the series. And if you say option A is not okay, these are not the correct answers. See, first of all, this formula always gives you the total possible lines between two states. This formula gives you the total possible line between two states. If you see from 10 to 4 and use this formula, then 21 line include 10 to 8 as well, 10 to 6 as well, 9 to 5 as well, 10 to 4 as well, 9 to 4 as well. Many lines will be included. Just look here closely. Whenever you are using this formula between two states, suppose I am using the formula between 10 to 4, then it will include all the possible line between 10 and 4. It will be 10 to 9 as well, 9 to 7 as well, 10 to 6 as well. Any line that you can think between 10 to 4 will be included in this formula. Will be included in this formula. But is all the lines are belonging to bracket series? Bracket series will be only when the electron come directly to 4, right? This 10 to 9 is not bracket series. This 10 to 6 is not bracket series. So whenever you apply the formula, you find all the lines between two states. You never find a particular series line between the two states. For a particular series, you just have to do direct analysis n2 minus n1. That's it. That's it. For a particular series, you direct have to use n2 minus n1. 10 to bracket 4, 10 minus 4, 6 lines are going to be in the bracket series. These are the types of questions that are asked in JEE, even in JEE Advanced as well. Option D is going to be the correct answer. Option D is going to be the correct answer. Yes. If I have asked you Balmer series, 10 to 2, 8 lines are going to be in Balmer series. If I have asked you only Lyman series, 10 to 1, 9 lines are going to be Lyman series. If I ask you how many total lines will be emitted, your answer will be 45. It includes all series, all. Even 10 to 9 which we haven't named, 10 to 8 which we haven't named, 10 to 7 which is not named yet. So whenever you are using this formula, be very alert that whether you are trying to find the total lines or a particular series. Okay? Is this clear to you all? Is this clear to you all? Just give me a thumbs up right away. For any series, you are just going to use the formula n2 minus n1 directly. There are only 6 possible ways. 10 to directly 4, first way. 9 to directly 4, second. 8 to directly 4, third. 7 to directly 4, fourth. 6 to directly 4, fifth. And 5 to directly 4, sixth and last line. Sixth and last line. Okay, moving to the next question now. The orbital angular momentum of an electron in 2s orbital. That is a very easy question. Just you have to remember, we have 3 types of angular momentum. One is called as orbit. Recently in JEE, integer type question was based on this. Orbit angular momentum is given by nh by 2 pi, orbit or shell. Another is called as orbital angular momentum, electron momentum in orbital motion. So orbital angular momentum is given by under root LL plus 1 h by 2 pi, which is also called as h cross. And another is a spin angular momentum, which is given by under root SS plus 1 h by 2 pi. So for orbital S, L is 0, orbital momentum is going to be 0. Orbital momentum is going to be 0. Okay, moving to the next question now. Which of the following ion is expected to be colorless? Whenever you have to find colorless, or the one which is having no unpaired electron is usually colorless. The one which is having no unpaired electron is usually colorless. The one which is having at least one unpaired electron may show color due to electron excitation. So if you look for zinc 2 plus, the outermost configuration will be 4s2 for zinc, 2 plus 4s0, 3d10. It is diamagnetic, so this is going to be colorless. Rest all are paramagnetic, and paramagnetic compound are usually colored. You can do the configuration of everything here. One which is having d subshell fulfilled is not going to have any unpaired electron. Right? Yes, that was an easy question. Moving ahead, we are going to have states of matter, the third chapter, gaseous state hour. This chapter is mainly based on PV is equal to nRT, which is the ideal gas equation. Most of the numerical can be solved by only this, that PV should be equal to nRT, where P is pressure, V is volume, N is mole, T is temperature. That's it. You can compare them, P1, V1 by N1, T1. No need to use the experimental laws separately, you can directly compare them. P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Whatever things are changing, just have them, rest all things will be cancelled out. Yes, yes. Okay, then we have to be cautious about using the value of R, because R in ATM liter will be 0.0821, in joule will be 8.31, in calorie it will be 2. This is Dalton's law of partial pressure for non-reacting gaseous mixture. The total pressure is equal to sum of the partial pressure of all the gases, and partial pressure of any gas is equal to mole fraction of that gas multiplied by total pressure. This is the second form of Dalton's law. Sometime we can directly calculate the partial pressure of any gas in the mixture if we are given with the total pressure and the composition of mixture. Graham's law of diffusion. Graham's law of diffusion. In Graham's law of diffusion, what we are going to have, the rate of diffusion compared. Rate of diffusion compared, and that is inversely proportional to molar mass, but also if the gases are under different pressure, you are going to use the partial pressure of gases as well. You are going to use the partial pressure of gases as well. And then we have kinetic theory of gases, which have the average kinetic energy that depends only on the absolute temperature of any gas. The average translational kinetic energy. Also the three type of velocities or speed, most probable 2 RT by m, average 8 by pi RT by m, and RMS 3 RT by m. Sometimes questions are directly asked by the comparison of these velocity. Recently, the KTG section is more explored in the JEE exam rather than this PV is equal to nRT. They are focusing more on the KTG section recently, but that doesn't mean that this cannot be asked. So this is about ideal gas section. The real gas section has the van der Waals equation for real gas. The van der Waals equation for real gas. After that you have Z, which is called as compressibility factor, which is PV of gas compared to PV of ideal gas. What we do, we consider ideal gas Z to be 1 and compare our real gas, our actual gas with respect to ideal gas. Whether it is going above the ideal line, positive deviation, below the ideal line, negative deviation. But here's the catch. That if compressibility factor is more, that means gas is less compressible. Gas is going to be less compressible than ideal gas. Repulsion forces are going to be dominating. So try to remember this thing, that compressibility factor is higher, that means compressibility is going to be less. Compressibility factor is higher, compressibility of gas is going to be less. Gas is difficult to compress because of the stronger repulsion force. Because of the stronger repulsion force. And if Z is less than 1, compressibility factor is less, compressibility is going to be more. So what you can do, you can understand that compressibility factor and compressibility of gas are inversely related. Both are inversely related, not directly. Be very clear about this. Positive deviation means more repulsion. Negative deviation from ideal behavior means more attraction. The gas which is having more attraction is going to negatively deviate from the ideal behavior. Yes. After that we have, at low pressure we can almost neglect the van der Waals constant B. At high pressure, high temperature we can neglect A. That's why we have different formulas for Z and this equation at different conditions. What you have to do, just put B or A as 0 in this equation. You will get the modified van der Waals equation at that condition. And divide that equation by nRT, you will get the modified compressibility factor at that condition. Also, if both pressure are low, temperature is high, both are going to be neglected. So at low pressure and high temperature, a gas is going to behave ideally. At low pressure and high temperature, a gas is going to behave ideally. Yes, anything which can flow is called as a fluid. So gas and liquid both are called as fluid. Okay? Right. TC is called as critical temperature. You no need to remember all the parameters, critical parameters or their formula. Just remember what is TC. And if critical temperature is high, that means gas is having more attraction. So gas is easily liquefiable. Gas is easily liquefiable if critical temperature is high. Also at compressibility at critical point, ZC, which is ratio of PCVC by nRTC. So at critical point, the compressibility factor of any gas is 3/8. Compressibility factor of all the gases is 3/8, less than 1. That is, attraction force are going to dominate. That's why gas is going to be liquefied when attraction force are going to dominate. Is that clear to you all? Yes. Okay. Now we will see some of the questions from this chapter. Try to solve this question right away. Try to solve this question right away. We are going to crack open all this physical chemistry today. This is operation of physical chemistry. A gas has a volume of V centimeter cube at 10 degrees Celsius. Just remember, whenever you are using gas equation, you are going to use temperature in Kelvin all the time. If pressure is doubled, at what temperature will the volume still be V centimeter cube? So we are talking about two conditions, P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Let's see. Mole is not going to be changed because they are not talking about any leaking, any filling. So mole is constant, right? Pressure, let's say X, volume is V. T1 is 10 degree, that means 283 Kelvin. Now P2 is doubled. Volume is going to be still V. Volume is not going to change. T2. So we can clearly say T2 will be 2 into 283 Kelvin. 2 into 283 Kelvin, which will be T2, 2 into 283 minus 273. Minus 273. So this is going to be 293 degrees Celsius. 293 degrees Celsius. Could you find the answer? Yes. Okay. Moving to the next question now. Try to solve this question by yourself again. I urge you all to solve this question. This is just a practice session. At what temperature will the total translational kinetic energy? See, when you read that formula, kinetic energy average is 3/2 kBT. Kb is Boltzmann constant, which is R by Avogadro number. So this is the average kinetic energy per molecule for a single molecule. But if the question is talking about total molecule, Then for total we will multiply by n, and number of molecule divided by Avogadro number will become moles. So the total kinetic energy is given by 3 by 2 nRT. Total translational kinetic energy is given by 3 by 2 nRT. So the question says kinetic energy of helium should be equal to total kinetic energy of argon. Let's see. For helium we have 0.3 mole. R is same. 3 by 2 is going to same. Temperature of helium we need to know. For argon we are having 0.4 mole. 3 by 2 R. The temperature of argon is 400. 3 by 2 R, 3 by 2 R cancelled out. T will be 1600 divided by 3. That will be close to 500 Kelvin. We are not going to waste any time in doing the complete calculation. Just do the approximation and find the closest answer. Do the approximation and find the closest answer. Okay. Moving ahead. Now this is for a question for you to do. In case of positive deviation, what are we going to have? We are going to have Z more than 1, and gas are having very less interaction or mole repulsion. Gas are having very less interaction or mole repulsion, and mole repulsion occurs due to finite size of molecule. Mole repulsion will occur due to finite size of molecule. Okay? So C is going to be the correct answer here. Moving to our next chapter, which is thermodynamics, and many students find this confusing. See, thermodynamics is divided in two parts. One is thermodynamics, that is similar to physics. Another is thermochemistry, which is all about enthalpy, entropy, Gibbs energy and other factors. So thermodynamics has first law of thermodynamics, conservation of energy. Remember, whenever you are solving thermodynamics, you have to be very aware that whether you are solving it in chemistry or in physics. In chemistry, we say that the total internal energy is equal to heat flown plus work done. Whatever is coming inside the system is taken as positive in chemistry. Whatever is going outside the system is taken as negative in chemistry. So work done on the system positive, work done by the system negative. Heat given to the system positive, heat evolved by the system negative. So we are going to use first law of thermodynamics all the time. Heat is given by mole multiplied by molar specific heat capacity into temperature change. At constant volume, Cm becomes Cv. At constant pressure, Cm becomes Cp. Where F is degree of freedom, and you also know Cp minus Cv is always equal to R. Mayer's formula. And gamma, this is called as Poisson's ratio, which is Cp by Cv. Degree of freedom for a single atom gas 3, diatomic gas 5, triatomic linear gas 5, triatomic non-linear gas 6. So you can have the degree of freedom of all type of gases like ozone 6, CO2 linear triatomic 5, oxygen 5, helium, neon, argon, monatomic gases 3. Okay. So we can have the analysis of Cp, Cv from here. Heat at constant pressure is defined as enthalpy change as well. Heat at constant volume is defined as internal energy. So that's why enthalpy can be written as NCP delta T. Internal energy can be written as NCV delta T. Now the work done. Only 4 formulas are required for work done. If you have a slow, a reversible, a slow isothermal process, the work done is going to be minus 2.303 nRT log final volume by initial volume. Final volume by initial volume. If you have a fast, irreversible isothermal, how will you identify it as fast? If the question mention against a pressure. If something like this line is mentioned against this pressure, you can assume it to be irreversible isothermal. For isobaric, again minus P delta V. Isochoric, volume is constant, work done is 0. For adiabatic, using the first law, delta U, that is NCV delta T. NCV delta T. Okay. Moving ahead, the thermochemistry involves two main things. First of all, enthalpy change is given by delta H is equal to delta U plus delta Ng RT, where delta Ng is the gaseous mole on the product side minus gaseous mole on the reactant side. Gaseous mole on the product side minus gaseous mole on the reactant side. That is our delta Ng. Or you can use the general formula as well, but this is not required. This is more important. This is our useful formula whenever you want to have enthalpy and internal energy of any reaction related. Entropy change, sometime they ask question on the entropy change calculation as well. This is NCV. CV is again same, that molar specific heat capacity at constant volume. NCV ln T2 by T1 final by initial plus NR ln V2 by V1. If volume is constant, ln 1 will become 0. If temperature is constant, ln 1 here will become 0. So you can automatically eliminate any of the term if temperature or volume is constant while calculating the entropy change. Okay. Now this is a very good thing. Here gives energy, the free energy is given as delta H minus T delta S. If you want to remember all those sign convention, positive, positive, spontaneous, non-spontaneous, just make the graph. Delta H is going to be intercept of that graph. Intercept of that graph, that is, you are going to start according to delta H, and slope will be reverse sign of entropy. So if delta H is positive, starting from the positive, delta S is positive, so slope is negative, the downward line. Delta G positive, non-spontaneous. Delta G negative, spontaneous. Spontaneous at higher side of temperature. Spontaneous at higher side of temperature. Delta H positive, delta S negative, slope positive, always non-spontaneous. Always non-spontaneous. Always spontaneous if delta H is negative and delta S is positive. Based on the intercept and slope, you can make the graph and then you can find when it is spontaneous, that is negative. Make a graph between delta G and T. And when it is non-spontaneous, that is positive. Non-spontaneous, that is positive, right? Okay. So try to solve this question. This is again a JEE type of question. Everyone try to solve this question. Ideal gas undergoes isothermal expansion from 10 atm to 1 liter. This is again a challenger type problem. Again a challenger type problem. 10 atm 1 liter to 1 atm 10 liter. Either by path 1, which is infinite stage expansion. Infinite stage means very slow expansion. Very slow expansion, so that is going to be reversible. So let's find it. W reversible will be equal to minus 2.303 nRT. See here, N and temperature are not given. N and temperature are not given. Log final volume, which is 10, divided by initial volume, which is 1. But we can use PV is equal to nRT, right? So instead of nRT, we can put initial PV or final PV, anything. At isothermal condition, PV is always going to be equal to nRT. So we can put initial PV or final PV, that doesn't matter. But instead of nRT, we can put the PV, that is 10 atm liter. Log 10 will become 1. So this is the first work done. Or by path 2. In part 2, what is happening? First against this pressure, second against this pressure. So work done in path 2 will be minus P external delta V. See, I told you, whenever it is mentioned against a pressure, it is going to be irreversible isothermal. So work done will be first minus 5. When you are expanding against 5, it is going to come from 10 to 1 to 5 and 2. P and V should be constant. Then after that, it will go to 1 and 10. So the first portion, the volume change is 1. Plus minus external pressure is 1. And in this process, the volume change is 8. So the total work done here is 13 atm liter. 13 atm liter. We have to find the ratio. So the ratio will come as W1 divided by W2, that will be, minus sign will be cancelled out. So you can clearly see option A is the correct choice. Option A is going to be correct choice, right? So this question requires too many things to consider. Work done in reversible isothermal, work done in irreversible isothermal, and to replace nRT by PV, which we don't do so often. Now moving to the next question. Let's see. 2 moles of an ideal monoatomic gas is heated from 27 to 627 degrees Celsius reversibly and isochorically. Isochorically means volume is going to be constant. Volume is going to be constant. The entropy of the gas, we have to find the entropy change. As volume is constant, so NCV ln T2 by T1. Let's see, N is 2. CV will be F by 2R. For monoatomic, F is equal to 3. So CV will be 3 by 2R ln temperature T2. Add 273 here. So this will become, I think, 900. Divided by T1, add 273 here. So this will become 300. So we will get entropy change positive. That means increase by 3R ln 3. Increase by 3R ln 3. Option B is going to be the answer. Because entropy change is positive, that means it is going to be increased by this amount. Increased by this amount. Okay. Moving to the next question. Try to solve again this question. This is a question based on thermochemistry, and in thermochemistry the most hot topic is going to be bond enthalpy. Bond enthalpy. See, we are given with a question. Twice of carbon solid plus 3 hydrogen gas. This is the hydrogenation of carbon. That is giving me C2H6 gas. And the enthalpy change for this process is going to be minus 20.24. In terms of bond, what we do, we convert everything which is on the reactant side, to gas. So that means solid carbon is going to sublime to gas, and 2 moles, so 2 times of sublimation of carbon that we need to find. Plus, we have 3 moles of HH bond. So 3 mole of HH bond is 3 into 102.6. Then, so all on the reactant side are going to be positive for their gaseous conversion. Now we are going to convert all the gaseous atom to the product. So product side we have carbon-carbon bond. Carbon-carbon bond is 63, so minus, product side minus. And we have 6 CH bond. 6 CH bond will be 6 into 85.6. 6 into 85.6. From here we can solve for X and find the enthalpy of sublimation of carbon. Enthalpy of sublimation of carbon, that should come around option C, but you have to calculate it. You can take that approximate value 20, this to be 100, 60 and 90, and you will get the answer very easily. Okay. Now moving to the next question. Okay, now this is equilibrium chapter. Equilibrium is divided into 2 parts. One is chemical, another is ionic. In chemical equilibrium, what we see that equilibrium constant is any time can be written as RHS side by LHS side, product side divided by reactant side. For Kp and Kc, we have a relation Kp is equal to Kc into RT to the power delta Ng. And whenever we want to predict the direction of reaction, then K can be greater than reaction quotient. That means reaction is behind the equilibrium constant. So the reaction is going to move to the forward direction. If K is less than Q, that means reaction is ahead of the equilibrium. So reaction is going to be moving backward direction. Reaction is going to be moving backward direction. Now the Le-Chatelier principle says, if we increase pressure, the reaction is going towards less gaseous mole side. If we increase temperature, for endothermic there will be forward shifting, for exothermic there will be backward shifting. That is temperature, volume and mole. Three things are the things which are going to affect equilibrium. If we add inert gas at constant volume, then there is going to be no effect, but at constant pressure there is going to be shifting towards more gaseous mole side. Okay, now moving to the ionic part of equilibrium. See, I haven't fulfilled this formulas yet. Now this is the ionic part of equilibrium. In ionic we have two sections. One is pH, another is solubility. For pH we have four sections, and any question of pH can be done by this four section. You just have to identify the category. First is if you have a strong acid, pH, base, pOH. For acid you are going to find pH first, for base you are going to find pOH first. So for acid, pH minus log total concentration of H plus, pOH minus log total concentration of OH minus. For weak acid, pH, for weak base, pOH. Acid, pKa minus log concentration, base, pKb minus log concentration, half. For salt, if we have a salt of weak base, strong acid, that is going to be acidic salt, so H. As base is the weaker part, so B. If we have weak acid, strong base salt, that is going to be the basic salt, so POH. As acid is the weaker part, so pK. See, whichever part is weaker, for that we are going to use pKa or pKb. For buffer, if acidic buffer, pH, pKa log salt by concentration of acid. For basic buffer we have pOH, pKb log salt by concentration of base. So for any pH we just have to identify the category, and then we can find the pH by directly applying the formula. No need to solve all the things in the reaction analysis. We can do that as well, but this will save our time. Okay, you just have to identify the correct category, that when it is belonging to buffer, when it is belonging to salt, when it is belonging to strong electrolyte, and when it is belonging to weak electrolyte. The solubility has two sections. One is solubility, KSP is equal to, for AX, BY type, X to the power X, Y to the power Y, S to the power X plus Y. And for precipitation, the process should come backward. So QSP, that is ionic product, should be greater than solubility product. This is our sole condition for precipitation. If concentration of B is given, we can find the minimum requirement for A, and vice versa. Is this clear to you all? Just give me a thumbs up. Up to this point, everything is clear to you all. And whenever we have a common ion concentration, common ion effect, solubility is going to decrease. That is, AgCl solubility in NaCl, it is going to be less. MgCl2 solubility in MgNO3 whole twice, it is going to be less. So common ion concentration always decrease the solubility. Okay. So these are the formulas that are important. These are the concepts that are important for equilibrium section of ionic equilibrium and chemical equilibrium. Now moving to this question, try to solve this question. This is again, JEE finds this graphical type of question interesting to ask. These type of graphical questions where you have to draw the information from a graph. So try to solve this question. Right now. We have to find the value of n from the graph. This is capital B, and we are given with the equilibrium A gives NB. Anytime if you have any doubt in equilibrium chapter, you can always make a tabular analysis that what is occurring at t is equal to 0 initial time and after some time. What are the cases at these two times, and you can easily analyze the question. See, initially we can say that concentrate 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So concentration of A initially is 0.6. Concentration of B initially is 0. Okay. Now according to stoichiometry of 1 to n, so if out of A, X mole has been consumed, 0.6 minus X will be remaining. X mole will give n times, that is nx mole. So that is the situation after certain time if X mole of A has been reduced, NX mole of B will be formed. Again, a stoichiometric analysis. See, we are given at this particular time, we doesn't want to know whether it's equilibrium or not, but at this particular time, B is 0.6, A is 0.3. At this particular time, if you look closely, B is 0.6, A is 0.3. Is this the case or not? So if A is 0.3, this should be equal to 0.3. 0.6 minus X should be equal to 0.3. That will give you X as 0.3. This NX should be equal to 0.6. So that will give you X, we already have calculated, N will be 0.6 divided by X. So that will come as 2. We just put X here and N came out to be 2. So option B is going to be the correct answer. Option B is going to be the correct answer. The N value will be here 2. Right? Yes. Moving ahead. A 0.1 molar acetic acid solution is titrated against 0.1 molar NaOH solution. What would be the difference in pH between 1/4 and 3/4 stages of neutralization? Remember, whenever you are titrating an acid, a weak acid, with a strong base, salt of acid and base is going to be formed. What is going to happen at 1/4 stage of neutralization? At 1/4 stage, acid is going to be 1/4 neutralized. That is 3/4 of acid will be left out. Base will be consumed and 1/4 of salt will be formed. That is going to be happening at 1/4 stage of neutralization. So you can say that unless until you have completely neutralized, you are going to get buffer solution. A acid, a salt of that acid is present and that mixture is going to behave as a buffer solution. So every time in a titration of a weak electrolyte with a strong electrolyte, before neutralization, before end point, every point is going to behave like a buffer solution. Similarly, at 3/4 stage of neutralization, acid is going to be consumed 3/4, so 1/4 of acid will be remaining and 3/4 of salt will be formed. Again, we have acid and salt both in the solution. So again, this is going to be a buffer solution. Again, this is going to be a buffer solution. We have to find the pH difference in these 2 points. pH difference in these 2 points, we can directly apply the buffer formula. pH 1, pKa plus log salt. Salt is 1/4 divided by acid. Acid is 3/4. pH 2, again pKa plus log salt. Salt is now 3/4, acid is now 1/4. So we have to find the delta pH difference, that is going to be coming log 3 minus log 1/3. So that will become 2 log 3. So the difference in the pH will be 2 log 3. Option D is going to be our answer. Right? Option D is going to be our answer, 2 log 3. Moving ahead now. Moving ahead. The solubility product of zinc hydroxide is 10 to the power minus 14. That is, first of all, as we are going to be talking about zinc hydroxide, so we are going to write the equation of zinc hydroxide dissolution. Zinc 2 plus aqueous plus 2OH minus aqueous. Is that correct? Okay. Just find the answer for this question now. What would be the concentration of zinc 2 plus ion in 0.1 molar NH4OH solution, which is 50% ionized? The solution is 50% ionized. You can see that NH4OH is producing a common ion effect. NH4OH is producing common ion effect. Can you see that common ion effect? Now, if for common ion effect we talk, NH4OH is 50% ionized. That means out of 0.1, we are going to get OH minus as half of this. So the concentration of OH minus is going to be half, and let's say the concentration of zinc 2 plus is S. For equilibrium, we can write concentration of zinc multiplied by concentration of OH whole square. That should be equal to Ksp. Ksp is 10 to the power minus 40. So S will be 4 multiplied by 10 to the power minus 12, and that is going to be the concentration of zinc 2 plus in the solution under the given condition. Now few of you may ask me that, sir, when you are dissolving zinc hydroxide, it is also producing OH minus. Why I haven't considered OH minus coming from this salt? Why I am considering OH minus coming only from NH4OH? Every time when you have common ion effect, you can always ignore the concentration of common ion coming from the salt which you are dissolving. This can be ignored or neglected. Why? Because as compared to that common ion, it is going to produce very less amount. So this amount, that is OH amount coming from this salt, has been neglected. Already. So that's how you can find the solubility in presence of common ion effect. Just put the concentration of common ion, use your equilibrium equation, and you are good to go to find the solubility. Right? You can find the solubility. Okay. Now we are moving to the next chapter, which is redox reaction. In redox reaction, you are going to need three things. One is how to calculate oxidation number. That is the most extensive part of this chapter, how to calculate oxidation numbers. And from oxidation number, you can do many things. Like from oxidation number, you can do the naming of inorganic acid. From oxidation number, you can find the N factor and other things. Second thing, N factor of any acid is always equal to basicity. That is how many H plus ion it can give you. That will be the N factor of acid. For base, it is the acidity, that is how many OH minus ion it is going to give you. And for redox reagent, it is going to be atomicity multiplied by change in oxidation number. What do you want to know about the electronic configuration? YouTuber, what do you want to know about the electronic configuration? And this is called as law of equivalence. This is the most useful law of all the. That means whenever you want to solve physical chemistry in any chapter, you can use this law. Law of equivalence, that is equivalence of everything that is being involved in a reaction is always going to be equal. And equivalence can be written as N factor multiplied by mole, or equivalence can also be written as mass by equivalent mass. Mass by equivalent mass. You can also use that formula. Okay. So we are having only two major things in redox reaction: how to calculate N factor and how to balance or equate the equivalence. All the questions can be done by these two things. Look here. First of all, we have the sum of oxidation state. Again, this is a very good question because you are going to waste your time while solving this question. You are going to waste your time if you solve this question completely. See, we have to find the sum of oxidation states of all carbon atoms in toluene molecule. This is toluene molecule. This is again a challenger problem. Let's see who can find the answer for this question. Who can find the answer for this question? Let's see it. Sum of oxidation state of all carbon atoms involved in the toluene molecule. Let's see how many of you can find the answer. Okay, you are going to have popcorn right now. That's good. Eating is good. the sum of oxidation state of carbon atoms in toluene molecule. Could you find that? See, the formula of toluene is going to be C7H8. Now can you find it? We are already ahead of structure of atom chapter. That orbital notation is not very much important, SPDF only, right? You just have to learn the order of electronic configuration. See, let's say this is X, this is going to be +1, carbon with a hydrogen with a non-metal is going to be positive state, all hydrogen are going to be in +1. So we will have 7x minus 8 is equal to 0. X will be 7, 8 plus 8 is equal to 0. X will be minus 8 by 7. Remember, any time that you find the oxidation number using this formula, it is always average of all the atoms. It is always average value, and this is coming fractional. This is telling you that carbon is in different state. Some of the carbon are in different oxidation number and some of the carbon are in different oxidation number. But anytime you find oxidation number from the formula, that is average. So what you have to do, what is the meaning of average? Meaning means, average means you have to sum up all the oxidation number divided by total number of carbon atom. How many carbon atoms are there? 7. So the sum of oxidation number is going to be minus 8. You can directly find 7x from here. That is going to be the sum of oxidation number of all the carbon atom involved in the toluene molecule. That is going to be minus 8. That is going to be minus 8. Yes, that's correct. Okay. So this type of question has also been asked recently, because they want you to waste your precious time while solving the paper. So you don't have to find all the answer completely, but you have to think logically while giving JEE exam. JEE doesn't test your speed, JEE tests your logical and mental abilities. Okay, let's move to the next section, and this is an oxide X2O3 is oxidized by dichromate ion into XO4 minus in acidic medium. See, dichromate in acidic medium is always going to be converted into chromium plus 3. You can learn for it that dichromate in acidic medium is always going to be converted into chromium plus 3. Now let's see here. X is in plus 3. Here X is in plus 7. So the n factor, we have to find the moles of X2O3. Remember, you have to find the n factor of that for which you have to find the mole. We can solve this question by balancing as well. We can solve this question by balancing as well, but here we are going to use the equivalence analysis. So you have to find the n factor of that molecule for which you are going to solve, for which you are going to calculate quantity. For X2O3, the atomicity of X is 2. And the change in oxidation number plus 3 to plus 7, that is 4. So n factor is 8. N factor is 8. For chromate ion, you are having oxidation number plus 6 plus 3. Atomicity is 2 multiplied by change in oxidation number, that is 3. So n factor multiplied by mole of X2O3 that are going to participate in the reaction. Application of law of equivalence. Law of equivalence. So here we have to find the mole and we are given per mole, that is 1 mole. So mole of X2O3 oxidized by 1 mole of dichromate will be 6 by 8. Or we can say that 3 by 4. Option A is going to be our answer. Option A is going to be our correct answer. Right? Yes. Moving to the next question now, dear students. This is again a very good question. We have to balance this equation and find the coefficient here. So see what trick we are going to for balancing. We are given with iron and nitric acid. They react together to form ferrous nitrate, ammonium nitrate and H2O. See, we have to balance this equation, that is no doubt about it. We have to balance this equation. But if we use oxidation number method or half reaction method, that is going to take much of our time. So what we are going to do, we are going to find the n factor. N factor of iron 0 plus 2. Atomicity is 1, change is 2, so n factor is going to be 2. N factor of nitric acid plus 5, and this is minus 3. You can separate the ammonium ion from here because rest all having nitrate, there is no change for oxidation number. Just find that portion where oxidation number is changing. So 5 to minus 3, change of 8. Change of 8, atomicity is 1. So the n factor of nitric acid is going to be 8. Now what you do, just cross the n factor. 8 will come ahead of this and 2 will come ahead of this. Remember, this is all going here. This all is going here, none else. Now we are going to balance other things. 8 iron, so we are going to have 8 ferric nitrate, okay. 2 nitrogen, so we are going to have 2 ammonium. 2 ammonium. Now you can see that we are also having 16 plus 2, 18 nitrate ion extra. We have 18 nitrate ion extra. In order to compensate for those nitrate ion, because they are not getting oxidized or reduced, so in order to compensate those nitrate ion, we are going to add extra 18 nitric acid. Because this part is telling only about the redox change. This is telling 2 nitrate ion are being reduced into 2 ammonium ion, that's it. So whenever we are using n factor, that is only telling us about the change, the portion that is going under reduction or oxidation. If we have some extra portion, we are going to add them separately. Now you can say that we have 18 nitrate ion and you can balance the hydrogen from here. 18 hydrogen plus 2, 20 hydrogen here. We already have 8 here, so 12. That means we are going to add 6 water. The reaction is balanced now. The reaction is balanced now. Now we have to find the ratio of nitric acid coefficient 18 plus 2, 20. Ratio of ferrous nitrate 8. Ratio ammonium nitrate 2. So the ratio is going to be 10:4:1. 10:4:1 is the correct answer for this question. We could balance this question in 5 to 10 seconds. If I am not explaining, we can balance this in 5 to 10 seconds, and that is the fastest possible way to balance our redox reaction. You cannot do that by oxidation number change method or ion electron method. Right? Yes. Moving ahead now, we have next chapter which is solid state. What type of question is this? We are not talking about dark matter. Let's focus on the white matter for that moment. Okay, the matter which is present around us, not which is beyond us. So we have solid state. In solid state, we have a cubic system. The main crystal system is cubic. One type of question are density, which is Zm by Na(A)³, and that question are going to be involving lot of calculation. So we are going to avoid those questions even in the exam. And if there is a question based on density, we are going to do that question at the end of our exam. Then we have 3 types of ionic solid mainly, and we should know the structure of these ionic solid. One is of NaCl, where Cl minus is at FCC, Na plus is OH void, octahedral void. That will be from 6 p.m. partial class. Right? Okay. Then we have ZnS, sulfide ion in FCC and zinc ion in 50%, that is alternative tetrahedral void. Then we have cesium chloride, Cl minus in PCC and cesium plus in body or cubic void. Body or cubic void, that is at the center of the atom. For Schottky defect, you should know this is a vacancy defect, ion pair are missing. Frankel defect is a dislocation defect where a certain ion is dislocated from its actual lattice site to some smaller interstitial site. And this radius ratio determines which type of voids are occupied in an ionic solid. which type of voids are occupied in an ionic solid. If the ratio is less than 0.225, trigonal space, coordination number 3. 0.225 to 0.414 is the range for tetrahedral void. 0.414 to 0.732 is the range for octahedral void, and 0.732 to 1 is the range for cubic void. So these are three types of void. One is trigonal space, interstitial space. These are the three types of void which are occupied according to the radius ratio. So by finding the ratio of radiuses, we can find the coordination number as well. We can find the coordination number as well. Moving to the question, in a tetragonal crystal, see, if anytime you are having difficulty in learning all these parameters, you can learn by this trick C tall H empty. C tall H empty, where C is cubic, T is tetragonal, O is orthorhombic, R is rhombohedral, H is hexagonal, M is monoclinic, and T is triclinic. For first, we already know A is equal to B is equal to C. Now put one not equal to sign every time. A, B not equal C. All are not equal. Just repeat this process again. A, B, C equal. A, B equal, C not equal. A not equal, B not equal, C. So it is very easy to remember all the H parameters. Just add one not equal to sign every time and take the previous not equal to with you as well. For the angle, we already know for cubic, alpha, beta, gamma, all are 90. For first three, this is not going to be changed. Alpha, beta, gamma, all are 90. Alpha, beta, gamma, all are 90. So from here we get the answer for tetragonal. For tetragonal crystal, we are going to have this relation. For tetragonal crystal, we are going to have this relation, right? Okay. After that, similar to this edge thing, we are going to introduce one not equal to sign. Only difference is that we are not going to take the previous not equal to with us. Meaning, first of all, alpha, beta, gamma equal, not equal 90. Alpha, beta, this not equal to will come here, rest all are equal. Then not equal to will come here. So we will add one not equal to sign every time, but we are not going to carry forward the previous not equal to sign. So this can be written as like this. Alpha, beta and gamma and 90 are equal, but gamma is not equal. This can be written as alpha, gamma is 90, but beta is not equal to 90. So we can easily remember the angle and H parameters of all the crystal system. Triclinic is the most unsymmetrical crystal system, that is A, B, C, all are not equal, alpha, beta, gamma, these are also not equal to 90 degrees. So triclinic is the most unsymmetrical crystal, while cubic is the most symmetrical crystal. So this is the trick to remember all the 7 crystal system of solid state. The question asks about tetragonal. This is for tetragonal. You can see that this is for hexagonal. You can see that this is for orthorhombic. This is for A, B, C are equal, alpha, beta. Okay, this is not for anyone. Yes, no, this is not equal to anyone. 90 should be there. Yes, option B is the answer for this question, right? Okay, moving ahead, in a solid AB having the NaCl. That's why I told you, you have to remember which ionic solid has which type of structure. Here they are saying NaCl, that means cation or anion, one will form FCC, another will be in octahedral void. So A atom occupy the corner. So in FCC of NaCl, A is the corner atom. So A will be at every corner as well as center of each faces. Center of each faces. And if A is forming the FCC, then B is going to be in octahedral void. That is, B is going to be at the edge center. B is going to be at the edge center. All the edge centers will have B atom. and additional to S center, octahedral void is at the body center as well. So body center will also have B atom. Now the question is saying face centered atoms along one of the axes. Let's pass an axis from here. So face center atom, that is, this has been removed and this has been removed. So only face center atom along any of the axes. So you draw one of the axes passing through the center of the face and remove all the face center atoms. Then now we will have A atoms are at 8 corner having contribution 1 by 8. Out of 6 faces, 2 have been removed. So A atom will be at the 4 centers of faces having contribution 1 by 2. So effectively we will have 3 A atoms. B atoms are not disturbed, so B will be 4, and the formula of solid will become A3B4. A3B4, that will be in option D. So that will become our answer. A3B4 will be the formula of solid. Yes. Okay. Right. Moving to the next. An ionic solid is HCP. For any time you are given a question of SCP formula base, you can do it by assuming FCC. Because all have common similarity. X atom, whether in FCC or SCP, will form X octahedral void and twice of X tetrahedral void. X octahedral and twice of X tetrahedral void. Right? Yes, A3B4. Very good, Danish. Try to find the answer for this question. First of all, if we see from here, P is having a valency of X, Q is having a valency of 2. So ideally the formula should be P2QX. The formula should be P2QX. Let's see. Now we are having Q atom is forming SCP. So let's say in HCP, although X is 6 for SCP, X is 6 for SCP, but you can solve by X. Right? Q is X and P atom is in half of tetrahedral void, that is half of 2X. Let's not call it X because we are already assuming X here. Let's say we have A atoms of Q in SCP lattice. So P will be in half of tetrahedral void, that is twice of A. Half of tetrahedral, twice of A. So that will be A. So in that regard, the formula will be PAQA, or the simpler formula will be P1Q1. P1Q1. So if P is 2, then Q should also be 2. That means X, the value of X will be 2. The value of X will be 2 if we compare two formula. One we found by crossing the valency, another we found by using the SCP analysis. For any FCC or SCP, you can use this information all the time. X atom of those crystals form equal number of octahedral void and double number of tetrahedral void. Okay, moving to the next. This is about liquid solution. Liquid solution has 3 major portions. One is Raoult's law. This equation is for Raoult's law. The vapor pressure of a solution is equal to the vapor pressure of liquid A and vapor pressure of liquid B. The composition of vapor that can be found by merging Raoult's law with Dalton's law. The composition of vapors, right? YA, YB are the composition in vapor phase. YA and YB are the composition in vapor phase, while XA and XB are the composition in liquid phase, mole fraction in liquid phase. PA naught, PB naught are the vapor pressure of pure state A and pure state B. This is about colligative property, and whenever you are using colligative property, you are every time going to use Van 't Hoff factor. So these are our 4 colligative property: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Out of this, osmotic pressure is the best property to calculate to calculate or to determine the molar masses of polymers or proteins or higher biomolecules. Another thing, if osmotic pressure is equal, the solution are said to be isotonic. If they are not equal, the one having less is hypertonic, the one having more is hypertonic. The one having less is hypotonic, the one having more is hypertonic. And if you put these two solutions, the solvent always move from hypotonic, that is low osmotic pressure side, to hypertonic, high osmotic pressure side. The solvent moves from hypotonic solution to hypertonic solution. On that basis, you will decide whether it will shrink or expand. Right? Yes. Van't Hoff factor can be calculated in two cases. One is about dissociation, for which alpha is the degree of dissociation. Alpha is the degree of dissociation, and if alpha is equal to 1, that is strong electrolyte, then Van't Hoff factor is directly going to be equal to N. If question doesn't mention, you can consider every salt to be strong electrolyte. Similarly, for association, I is equal to 1 plus N, 1 by N minus alpha, where alpha is degree of association. And if alpha is 1, if it is not mentioned, you can assume it to be 1. I will be equal to 1 by N. I will be equal to 1 by N. You can directly find for dissociation or association the Van't Hoff factor. N is called as degree of association, or you can call it degree of polymerization. How many particles are joining, that is given by N. Suppose if dimer is being formed, you can say N will be 2. If tetramer is being formed, you can say N will be 4. So how many particles are getting joined, that is defined by N. Right? You can use accordingly for association or dissociation. For dissociation, colligative properties are going to get increased. For association, the colligative properties are going to get decreased. Right? Yes. Now let's see the question. At 323 Kelvin, the vapor pressure of a methanol-ethanol solution is represented by this equation. Let's see how many of you can find the answer for this question very quickly. How many of you can find the answer for this question very quickly, because there are 3 ways to do this question. One is the shortest way. Yes, Danish, we have done the equilibrium. You can go back and see the equilibrium again. I know many of you are tired right now because you are studying, I think, from the morning. Most of you are studying from the morning 8 a.m. Okay. Find the answer for this. X is the mole fraction of methanol, so I am calling methanol as the A and ethanol as the B. I can directly write the answer. We have to find a P naught of ethanol, that will be 140. Answer will be 140. Even without picking up the pen, we can find the answer for this question. Can you find it? Without picking the pen, can you find the answer for this question? Yes, DG Prince. That is a common thing that happens right now in today's generation. Okay. Let's see. First of all, you have to understand that this equation gives the pressure of solution according to the mole fraction of methanol. That is, this equation is going to hold true for every value of mole fraction of methanol. We are going to have 2 values. When methanol mole fraction is 1, when methanol's mole fraction is 0. If methanol mole fraction is 1, that means only methanol is present, and that represents the pure methanol condition. That represents the pure methanol condition. And if methanol value is 0, that means ethanol is only present, methanol is absent, and that represents pure ethanol. That represents pure ethanol. Now if you put X is 1, the pressure that we are getting is only because of methanol. That means you put XA as 1, you will get the pressure of pure methanol. The pressure of pure methanol by putting XA as 1, that will be 260 mm. 260 mm directly. If we put XA 0, then that pressure that will be obtained from this equation will be of pure ethanol. So you put XA as 0, and that will give you vapor pressure, pure ethanol, that will be 140. That will be 140. That's how, without picking the pen, I found the answer as option B. See, so by solving more and more question, by revising it again and again, by fighting with it again and again, whenever you see a question that you have solved earlier, don't think, okay, I have solved this question earlier, I have no need to solve it again. Think of any another good initiative or smart way to solve that question. Yes, 140 is the correct answer. So whenever you get a question that is repeated or that you have already seen somewhere or solved somewhere, you can find another alternative to solve that question. Every physical chemistry question at least have two methods to solve that. Yes. Moving to the next part. Aqueous solution of 0.004 molar Na2SO4. Na2SO4 is going to produce 3 ions, 2 sodium, 1 sulfate, and 0.01 molar glucose are isotonic. And we have to find the percentage dissociation of Na2SO4. Let's see. If both are isotonic, their osmotic pressure is going to be equal. So I of Na2SO4 multiplied by concentration multiplied by RT. Osmotic pressure is ICRT. Glucose, for glucose I will be 1. Glucose is non-electrolyte. Concentration is 0.01 into RT. So from here I will be 10 by 4, that is 2.5. First of all, we find the Van 't Hoff factor for Na2SO4. Van 't Hoff factor for Na2SO4. Modi ji, that was a PYQ, but not very recent. It was very earlier PYQ, but that is a very good concept to understand. I is equal to 2.5. Now we can use the formula for dissociation. I is equal to 1 plus n minus 1 alpha. That is given to us as 2.5. So 1 plus 3 minus 1, 2 alpha, that is equal to 2.5. So 2 alpha will be equal to 1.5. Alpha will be equal to 0.75. Isn't it correct? Alpha will be equal to 0.75. That is 75% will be the correct percentage dissociation of Na2SO4. Option C is going to be our answer. JEE doesn't ask you difficult question. JEE asks you logical things. Yes. Correct. Okay. Moving ahead. We are just about to complete. Only 3 chapters are remaining. Moving ahead, liquid A and B form an ideal solution. The plot of 1 by XA versus 1 by YA. See, this represents mole fraction of A in liquid phase on y-axis. This represents mole fraction of A in vapor phase on x-axis. They have mentioned liquid and vapor phase XA and YA respectively. We have to find the slope or graph between this, right? Yes. We know the previous question has the answer 0.75. Let's see. We had a relation between YA, YB relation. Whenever you want to find the composition of vapor, you can use this relation. Now we want to have only XA and YA, so we are going to convert it. It can be written as YA divided by 1 minus YA. That will be equal to PA naught by PB naught. XA divided by 1 minus XA. Let's just reverse this reaction, that is take reciprocal of equation. So that will become 1 by YA minus 1. Right? It will be reversed, 1 minus YA, and you can separate YA with both of them. That will become PB naught by PA naught, and this will again become 1 by XA minus 1. We have to put 1 by XA on y-axis, so we are going to separate this with other things. So this is going to be 1 by XA is equal to 1 plus PB naught by PA naught No, it will be PA naught by PB naught. PA naught by PB naught 1 minus 1 by YA minus 1. So this equation will come as 1 by X save, that we have to put on Y axis. PA naught by PB naught. PA naught by PB naught 1 by YA plus PB naught minus PA naught divided by PB naught. Just check it by yourself. This should be the equation that is coming. Okay, so this is going to be the slope of the equation is going to be PA naught by PB naught, and the intercept is going to be PB naught minus PA naught by PB naught. That is option B is going to be our correct answer for this straight line graph. If I plot the graph between 1 by XA on Y axis and 1 by YA on X axis, we are going to get slope as PA naught by PB naught and intercept as PB naught minus PA naught by PB naught. Okay. Yes, Mathas, it is totally possible. Just try to focus why your 2 drop year were wasted. What was the, I would say, what was the limitation that you felt during those preparation? Just have a thorough analysis, and definitely you can do it again if you do it properly. If you do it properly. Just have a bounce back again. Moving ahead, about the electrochemistry now. About the electrochemistry. So electrochemistry is divided into 2 portions. One is about galvanic cell and another is about electrolytic cell. For galvanic cell, you have E naught cell. A cell is composed of cathode and anode. So E naught cell is cathodic potential minus anodic potential. But remember, this potential should be in the reducing format. This potential should be in reducing format. And delta G naught is equal to minus NF E naught cell. And equilibrium constant is related with E naught cell as well. So we can relate E naught cell with delta G as well as equilibrium constant. From here you will get, if delta G is negative, E cell is positive, and equilibrium constant is greater than 1, all of these 3 signs indicate that the process is going to be spontaneous. And the major thing of electrochemistry is use of Nernst equation. Use of Nernst equation. You can apply this equation to any half cell or complete cell. E cell is equal to E naught minus 0.0591 by N, where N is the number of electron. Either take anodic or cathodic electron, both are going to be equal. Log RHS side by LHS side. For standard hydrogen electrode, that is She, you can have the reducing and oxidizing potential just by changing the sign. For hydrogen electrode, we assume E naught cell to be 0. If the pressure of hydrogen is not mentioned anywhere, you can directly use this relation. E of She in oxidizing format is 0.0591 into pH. Now this is our electrochemical series. And in electrochemical series, we determine by this thing, spontaneity. Low SRP to high SRP. So the higher SRP will be oxidizing agent. The lower one will be reducing agent. Higher one will be cathode, that is undergoing reduction. The lower one will be anode, that is undergoing oxidation. Rest all the question on electrochemical series can be solved by these 2 information. By these 2 information. The next portion is electrolytic cell, that mainly involves Faraday law of electrolysis, and that can be summed up like this. Again, law of equivalence comes into role here. N factor into mole is equal to charge by Faraday or IT by Faraday. For cell parameter, we have G star is equal to kappa, where G star is called as cell constant, which is length of between the electrode, distance between the electrode divided by area of the electrode. Okay. Molar conductivity is 1000 kappa by molarity when you have to find the conductivity in Siemens centimeter square per mole. One time JEE has played with you, they gave you it in Siemens per meter. So remember, kappa should be Simon per centimeter and del M will come into Simon centimeter square per mole if you are using this relation. Otherwise, you have to convert it into other units. Del E will be 1000 kappa by normality. Coller's law is about the infinite or limiting molar conductivity. At infinite dilution, it behaves like Dalton's partial pressure law. That is, at infinite dilution, for molar conductivity, you can directly add up the molar conductivity of ions. Just remember one thing, for equivalent conductivity, you are not going to use stoichiometry. For molar conductivity, the stoichiometric coefficients are going to come there. Okay? For molar conductivity, the stoichiometric coefficients are going to come there. Let's see some question based on this. The standard potential of OCl minus Cl minus Cl minus Cl2 are 0.94 volt and minus 1.36 volt. We have to find the E naught of this cell. E naught of this cell. Let's see how we can find that. E naught of OCl minus slash Cl2. See, I am going to give you one more trick. One more trick. That first of all, find electron. Plus 1, minus 1, 2 electrons. Minus 1, 0, 1 electron. Plus 1, 0, 1 electron. Now what you are going to do, whenever you have to find half cell potential from two different half cell. Half cell potential from two different half cell, pick one of them. OCl minus on the left side, OCl minus on the left side. No need to change the sign, 0.94. But whatever potential you are picking, take the electron of that process along with it. Take the electron of that process along with it. Again, Cl2 on the right side, Cl2 on the right side. No need to change the sign. If Cl2 was on the opposite side, we would have changed the sign. So Cl2 on the right side, Cl2 on the right side, no need to change the sign. So minus 1.36. Again, I am going to pick up the electron from here. So whatever potential you are picking up, pick the electron of that process along with it. And finally, divide it by the number of electrons for the process for which you are calculating. It has 1 electron, so we divide. And how to find electron? Just find a change in oxidation number. No need to balance it. No need to find the atomicity. Just find the change in oxidation number. That's it. That's it. Now we are going to solve it. It will be 8. So that will be, I think, 1.88, right? Minus 1.36. That will be 0.52. 0.52 volt is the answer. Positive 0.52 volt is the answer. Yes, Kaushik, there will be. Yes. Okay. Moving ahead. The molar conductivity of NH4 ClOH minus Cl minus at infinite dilution is given to us as 150, 200 and 75 ohm inverse centimeter square per mole inverse. If the molar conductivity of a 0.01 molar NH4OH solution is 22 ohm inverse centimeter square mole inverse, then its degree of dissociation. Degree of dissociation can be written in terms of molar conductivity at any concentration divided by infinite dilution. At any concentration divided by infinite dilution. So here we have del M given to us as 22. We need to find del M naught. Let's find it. Del M naught for NH4OH we need to find. Okay. First of all, I am going to use NH4Cl, that is 150. NH4 ion I got. Cl ion extra, we will think about it. Then OH minus, that is 200. I got OH minus ion as well because I needed NH4 and OH. But Cl minus is extra, so I am going to subtract the Cl minus, that is 75. Let's subtract that 75, so this will give me, I think, 275 as the molar conductivity in a particular unit. So the limiting molar conductivity is 275. This on solving will come as 0.08. This should come as 0.08. Option C will be our correct answer. Option C will be the correct answer. So we can find the degree of dissociation by using this relation for molar conductivity at concentration C divided by molar conductivity at infinite dilution. Molar conductivity at infinite dilution. Moving ahead, let's see. Standard electrode potential data are useful for understanding the suitability of an oxidant in a redox titration. This is a PYQ from JEE exam as well. And see, this question can also be done in 3 ways. Okay, I'm going to tell you the fastest way, but I can tell you 2 other ways for this question as well. Because earlier when I saw this question for the first time, I also did it in the longer way. Then I analyzed it again. I did it in a shorter way. Then I analyzed it again. I found another shorter way to solve this question. That way is very easy. We are given with the reduction. Electron on the left hand side, we are given with the reduction potential. That means let's arrange them the lowest value. The lowest values of Fe3 plus. Fe3 plus Fe2 plus pair is the lowest value, right? Okay. After that we have chromate ion. After that we are having chromate ion. After that we are having Cl2 pair. And after that we are having permanganate and Mn2 plus. One thing from here, we already know which is below in the series is oxidizing. Higher SRP, more oxidizing power. Less SRP, more reducing power. That we already know. Now the question is done. We can use, first thing that we can draw, bonus point, bonus fact. Permanganate is a stronger oxidizing agent than dichromate in acidic medium based on their SRP data. Permanganate is more stronger oxidizing agent than dichromate ion in acidic medium based on their SRP data. That you can draw from here. Another thing is that both permanganate and dichromate can be used for the titration of Fe2 plus. Can be used for the titration of Fe2 plus because both can oxidize Fe2 plus to Fe3 plus. Both can oxidize Fe2 plus to Fe3 plus. Both are below. Anything which is below can oxidize the other one. But permanganate can also oxidize Cl minus. Permanganate can also oxidize Cl minus. So if I take dichromate along with HCl, it is not going to affect HCl, it is directly going to react with iron, nothing else. So dichromate will give the correct analysis of iron with HCl. It will not react with HCl. HCl will only produce acidic medium, that is the work of HCl with the dichromate. So dichromate can be used with HCl. But if I use permanganate ion along with HCl as medium, so some part of permanganate is going to react with iron, some part of permanganate is going to react with HCl. That means the quantitative estimation will give the incorrect amount of MnO4. So that statement is not correct. Permanganate cannot be used with HCl for the quantitative estimation, otherwise our result will be wrong, and that can be directly told by reading the question and just seeing their SRP value. Just seeing their SRP value. So that is our going to be answer option A, because permanganate ion cannot be used with aqueous HCl. Dichromate can be used with aqueous HCl. So that was the shortest way, otherwise you can find the E0 cell and do other analysis as well. Yes. Let's move to the question. Okay, now we have chemical kinetics. Chemical kinetics is divided into 4 parts. One is about differential rate law. Rate of any reactant, any product divided by coefficient is equal. Same to stoichiometric analysis. Rate of disappearance of A can be written as minus d by dt of concentration of A. Similarly, for product we can apply plus sign. We can apply plus sign, okay? Yes. Okay. So we have rate of disappearance of A divided by P, rate of disappearance of B divided by Q, rate of disappearance of C divided by R, rate of appearance of C divided by R, rate of appearance of D divided by S. That will be equal for everything. That will be equal for everything. Second is called as rate law. The above one is called as differential law. This is called as rate law, which is determined by the order of reaction. X and Y are called as order of reaction, and one method to find order is by checking the unit of K. The K unit will always have mole per liter to the power 1 minus N, where N is the order of reaction. Third thing is called integrated rate law. All rate law have different purpose. Integrated rate law gives you the relation between concentration and time. Concentration and time, yes. So A naught minus AT is equal to KT, and KT is equal to 2.3 log A naught by AT. These are two relations that you should know about zero order and first order. About zero order and first order. We are on the second last chapter, so I think we are about to wind up. Also for first order, the 75% life is double of half-life. The 75% life is double of half-life. And we can also compare the half-life and find the order of reaction. This is called as half-life method. T1 by T2 is equal to A2 by A1 to the whole power n minus 1. So by comparing half-life at two different concentration, we can directly find the order of reaction. The maths class will be tomorrow. Yes. Maths class will be tomorrow. Okay. And lastly in this chapter we have Arrhenius equation. On Arrhenius equation you may find a question based on the graph of log K versus 1 by T. If you look at Arrhenius equation, log K versus 1 by T, slope of graph is going to be minus EA by 2.303 R. Minus EA by 2.303 R. Okay, yes. Okay. So we can get from slope the value of activation energy. So this type of question you can find in your exam, that you are given with a log K versus 1 by T graph and you have to find the activation energy. Or sometime question can be directly come on the Arrhenius equation original form. K is equal to A e to the power minus EA by RT. Okay? Yes. Moving to the next question now. This is again a challenger problem for you all. Let's see how many of you can solve and find the correct answer. Because you may have done this type of question and I am sure many of you will find the wrong answer if you are going to solve this. Okay? Let's try to find the answer for this question. This is a challenger problem. Let's see who can find the answer. Who can find the answer? Voice should be okay. Neeta Ghosh, voice should be okay. Okay. I'm getting a lot of fun, but see, it doesn't matter. But if you are studying, you should have fun while studying. Like when you play cricket, you enjoy it. So try to enjoy the study as well. Okay. Could you find the answer? We all know that we can relate the rate of any individual. For example, like this, we can relate those rate. Let's call it RNH3, similar for RH2, I am going to relate them. RNH3 by 2 should be equal to rate of disappearance of hydrogen divided by 3. We already know this type of relation, right? We already know this type of relation. Yes, but the one thing again that you should know about this differential rate law, that this rate law is derived from stoichiometry. This is similar to our stoichiometric analysis, and stoichiometric is not valid directly on mass. You cannot apply directly on mass the stoichiometric analysis because of conservation of mass. So every time whenever we have mass analysis, we used to convert it into mole in the stoichiometric analysis. So whenever you have rate relation, if you directly apply this equation and the rate is given in terms of kilogram, some of you will find this as the answer. This should, right? Rate of consumption of H2. Yes, this as the answer, and that will be incorrect answer. If your answer is option A, that will be incorrect. It's okay. So if this is the answer, that will be our option A is the answer incorrect. Now see here, what we are going to do. Let's skip the kilogram part. We assume a new quantity, let's call it kilomole. Okay, we are skipping the kilogram part, no conversion of kilogram to gram, because at the end we are going to have kilogram. First of all, we are given with the ammonia rate as 10 to the power minus 3 kilogram per hour. We are going to convert this gram into mole. Without converting into mole, we cannot analyze using this relation. So A is not the correct answer. It will be 10 to the power minus 3 divided by molar mass of ammonia. Let's call it kilomole. Kilomole per hour. Now we can use this relation. So R of hydrogen will be 3 by 2 multiplied by R of ammonia, but in terms of mole, we can only relate molar rate, not mass rate. So that will be 10 to the power minus 3 by 17 kilomole per hour. But again the option asks the answer in kilogram, so we are again going to convert that mole into gram, but now for hydrogen. Now we are going to use the molar mass of hydrogen, so that will be 3 by 2 multiplied by 10 to the power minus 3 by 17 multiplied by molar mass of hydrogen, that is 2 kilogram per hour. So that involvement of molar mass changed the answer. Now that is going to be coming, I think 1 point something into 10 to the power minus 4. 1 point something into 10 to the power minus 4, that should be option B will be the correct answer. Option B will be our correct answer. How many of you could find this question, find the correct answer in the first go? How many of you could find the correct answer in first go? Isaac, option A was incorrect. But very good, at least you are attempting, you are learning, and you are learning something new just before the exam. That is the life of a student. The learning never stops. 1.5 into 10 to the power minus 3 will not be the correct answer. It's okay, no worries. But remember, from now onwards, whenever you are using the differential rate equation, that is comparing the rate of different reagents in a given reaction, never directly compare their mass rate. Mass cannot be compared directly using stoichiometry. This ratio is always for the mole ratio. Yes. Let's see the next question. Okay, now you have to do this question. There are two ways to do this question as well. I'm going to tell you both ways. There are two ways to do this question. We have to just find the order of reaction. We are given with the rate equation, pressure of reactant. So for second order, either you can remember that for second order or for nth order. For nth order, the rate equation is concentration to the power n minus 1 minus initial concentration to the power n minus 1 is equal to k. N minus 1 kt. That is the rate equation or integrated equation for nth order equation. If you put n is equal to 2 here and instead of concentration take the pressure, this expression is going to come. So directly comparing with the nth order equation, I can tell the order for this equation will be 2. Answer will be 2. Order will be 2. Option C. Yes, Isaac, correct. Option will be C. But if somehow you get an expression which is not the standard form, then what will you do? Just differentiate that equation with respect to time. Differentiate that equation with respect to time, and that will give you k from this, k plus 0, right? So d by dt of 1 by p will be minus 1 by, minus 1 by p square dp by dt is equal to k. From here I will get minus dp by dt is equal to kp square. Isn't it the rate? Change with respect to time represent the rate. Now rate is depending to concentration or pressure to the power 2. From here we can also find the order of reaction, that will be 2. So if somehow you are getting as a fraction, suppose here p to the power 3 by 2 was written, then what will you do? It is not a standard form. So if p to the power 3 by 2 is written, you can just differentiate and find the order of reaction. So there are two ways to do such type of question. Either differentiate the direct equation or use this general equation. Half-life is directly proportional to initial concentration to the power n minus 1. So for second order, you can directly say that it is inversely proportional to concentration. Yes, Isaac. Yes, for second order, it is inversely proportional. Okay. Okay, now moving to the next question. Okay, now next chapter is surface chemistry. In surface chemistry, we don't have many formula. Only in surface chemistry, what you have to focus. First of all, you should know what is Freundlich isotherm. What is Freundlich adsorption isotherm? X by m is equal to k p to the power 1 by n, where 1 by n is in between 0 to 1. When 1 by n is 0, that represents saturation. That represents saturation. That's correct. Then in catalyst, you have to remember or memorize some of the common reaction and the catalyst that are used in those reactions. So I'm not going to tell you that because you already know which reactions are in the NCERT and you have to memorize the known example of those reactions. And third section is about collide. For collide, you mainly have to focus on the flocculation, or we say coagulation, the precipitation of collide according to Hardy-Schulze. This is an important thing. The coagulating power. Then you have to focus on the gold number, which is the protective power of a lyophilic sol, and little bit you have to focus on the classification of collide, which is gel, which is emulsion. That classification is also important. Which colloids are belonging to the category of gel, which are foam, which are solid form, and other that. So these are the main thing that you should know in surface chemistry. Otherwise, this chapter is kind of one read chapter. You just go through the complete chapter once in your life, and after that you are never going to forget anything in this chapter. This is such easy chapter. If you go through with a little concentration in this chapter, you are not going to forget the concept of this chapter. Okay? So we are going to see the question of this chapter. Gold number. What is gold number? Let's see. What happens? Lyophobic sols are easily coagulated. I am going to give you the definition of gold number and easy way to remember it. Lyophobic sol are easily coagulated. So we add lyophilic sol, which are highly stable sol. They are highly stable. They are called as protective sol. So we add lyophilic sol to protect lyophobic. Suppose we have mainly lyophobics are inorganic sol and lyophobic are mainly organic sol. So we have a 10 ml standard gold sol that we need to protect. Now this is our damsel in distress. This is the person which is in problem that we need to protect. To protect against, from, there should be something from which we have to protect it. So we have to protect it against 1 ml 10% NaCl solution. That is our villain of this story, which is coming to destroy this damsel in distress. Okay, 1 ml 10%. You can remember like this. If this is ml in 10, that is going to be ml 1% 10. Now our hero comes, the entry of hero. So this hero requires a minimum amount or minimum particles. So the milligram amount, the minimum milligram amount of a lyophilic sol, the minimum milligram amount of a lyophilic, our hero sol, that will protect our 10 ml gold solution, our heroine, against 1 ml 10% NaCl, that is our villain, then that amount is called as gold number. Okay, it is very easy to remember the definition. The milligram of lyophilic that will protect 10 ml of lyophobic gold solution against 1 ml 10% NaCl solution. Let's see. The amount of gold present in no, the amount of gold required no, the gold required no, the protective power of lyophilic. That is correct. Gold number represent protective power of lyophilic, right? The higher the gold number, that means you need more amount, so our hero is not very strong. Hero will be strong when it will require less amount. So if gold number is more, protective power is less. If gold number is more, protective power is less. Okay? Yes, option D is the correct answer. How C? Gold is not required to protect the colloid. That's why I told you the definition. Otherwise, you could start reading from here. You see protect word here and you find the answer C as the correct answer. Never do that in the statement type question. Gold is not required to protect. Gold is being protected by lyophilic. Okay, gold is not required to protect. Gold is the one that needs protecting. Yes. Okay, moving to the next. A freshly prepared ferric hydroxide precipitate is peptized. Now, what is peptization? In peptization, we have a fresh precipitate. We shake it with a particular dispersion medium along with a stabilizing agent which is called as peptizing agent. Along with a stabilizing agent which is called as peptizing agent. So this process of converting a fresh precipitate into a colloidal solution is called as peptization. Into a colloidal solution is called as peptization, right? So in terms of peptization, we are having converting fresh ferric hydroxide precipitate by adding ferric chloride. First on C, we have precipitate of ferric hydroxide. So we are going to get the colloidal solution of ferric hydroxide, right? Now every colloidal particle has a preferential adsorption. No, Mustafa, you are given wrong answer. Cl minus is not correct. Focus here. First of all, we are going to get colloidal solution of ferric hydroxide. Now every colloidal particle has a selective preferential adsorption. Why? Because if these two are combining, that means they are having more affinity, more attraction. So either it will absorb Fe3 plus or it will absorb OH minus. Are we adding OH minus ion extra? Anywhere. If we have chosen basic medium, if we have added NaOH for peptization, if our peptizing agent was NaOH, then it could have absorbed OH minus and then it will become a negatively charged salt. But we have chosen peptizing agent as ferric chloride. So ferric chloride will only provide Fe3 plus. That will be the main ion that will be absorbed. So option B is going to be the correct answer here. No, Bhanushali, it is not option C either. See, if this is peptized with FeCl3 or if this is peptized with NaOH, both are going to have different result. This will give you extra Fe3 plus ion. This will give you extra Fe3 plus ion. So Fe3 plus will be absorbed. This will give you extra OH minus, so OH minus will be absorbed. Every time those cation and anion which are present in the colloidal particle are going to get absorbed. Which are present in the colloidal particle are going to get absorbed. So that is the concept of preferential adsorption as well as peptization. On that note, we are going to finish our today's session of physical chemistry. I hope you have had your fun because I enjoyed it a lot, and I wish you all the very best for your JEE mains exam. I wish I could be little helpful whether 1%, 2%, but your score could be improved a little bit, and that is our target. Just to help you out and improve your score, improve your concept in this last minute. So thank you for being there. All the very best. Take some rest, but keep on fighting and keep on studying. Don't lose this fight at this end moment. Okay. Okay then. Tata. Bye bye.